Hi everyone and welcome back to the channel. Today we have got something special in store for you if you are gearing up for the CISCO CCNA certification exam. In this video I will be covering the topics and questions that will help you achieve two goals. Number 1, learn the CCNA content and computer networking concepts. And number 2, prepare for and pass the CISCO CCNA certification exam. In this video, we will be covering a powerhouse of 355 practice questions to get you prepped and primed for the success on the CCNA certification exam. But hold on tight because it's not just about answering questions. We will also be explaining the networking concepts that will make you feel like computer network superhero. So, if you are ready to ace the CISCO CCNA certification exam and elevate your career to new heights, make sure to hit that like button, share the video, and ring the notification bell so that you don't miss any upcoming contents. So, gear up and let's dive into the success. Question number 1. Which OSI model layer is responsible for end-to-end communication and error recovery? And the options are option A network, option B transport, option C data link, and option D physical. And the correct option is option B transport. And the explanation is the transport layer is responsible for end-to-end communication between devices. It handles data delivery, error detection, error recovery, and flow control. Protocols like TCP work at this layer to ensure that data arrives correctly and in order. So let me further clarify this concept with the help of this diagram. So the transport layer is basically layer 4, and we have these popular protocols such as TCP, UDP, SSL, TLS that work at this layer. And the important concept here is that the transport layer is responsible for end-to-end delivery of packets. So what do we mean by end-to-end delivery? Let me clarify it. Let's suppose we have this client device and a server device. And in this particular case, let's suppose this is a web server which is hosting the HTTP service on port 80. And our client may be having a random port number such as this 4595. So this client may also be running other services as well. A server may be also running other services such as SSH, Telnet, SMTP, etc. So when we say end-to-end delivery, it means that TCP or the transport layer is responsible for delivery the packet all the way up to the particular service. So if the client here is browsing the web, then the web server will be receiving the packet all the way to its service at port 80, and this will be done through the transport layer. Similarly, if this user is doing SSH, the packet will be delivered to this service. So this is what we mean by end-to-end delivery. And if we look at the network layer is only responsible for host-to-host delivery. Let's suppose is this client has an IP address of 10.10.10.10, and the server, let's suppose, has an IP address of 192.168.1.100. So the network layer is responsible for delivery packets up to this IP address. Further, up to particular service is the responsibility of this transport layer. So I wanted to clarify this concept because this is important. So let's move forward to the next question. Which DHCP message does a client send to accept an offered IP address? And the options are option A, DHCP discover, option B, DHCP offer, option C, DHCP request, and option D, DHCP ACK. And the correct option is option C, DHCP request. And the explanation is the client sends a DHCP request message to accept the offered IP address from the server. It tells the DHCP server, I accept the IP address you offered. This step happens after the server sends the DHCP offer. Let me show the complete process. So this is how the DHCP process takes place. First of all, the client sends a DHCP discovery packet, and remember this is a UDP packet on port 67. The server responds with a DHCP offer on UDP port 68, and after this packet, the client request packet is basically the packet that accepts this offer on UDP again port 67, and at the end the server sends the acknowledgement packet. So this is how the whole DHCP process between the client and the server takes place. Question number 20, question number 3, how many usable host addresses are available in A/26 subnets? So this is also an important concept, and I will be explaining the process and the formula of how to calculate the IP addresses in a subnet. So the options are option A 32, option B 62, option C 126, and option D 254. And the correct option is option B 62. So how do we come with this number 62? Let me explain. So a /26 subnet has a total of 64 IP addresses. After reserving 2 addresses, one for the network ID and one for the broadcast address, we have 62 usable host addresses. So this makes a /26 a good choice for small network. So how do we arrive at this particular number? So the formula to calculate usable host in a subnet is 2 raised to the power number of host bits minus 2. So how do we calculate the number of host bits? So remember this formula and the next one, that is to calculate the number of hosts. So in this case, let's suppose we have a /26 subnet. It means that we have basically total of 32 bits in IPv4 address. So then a /26 means 26 bits are for the network, and total 32 minus the network bits are equal to host bits, which is 6. So now plug in this number in our formula, that is 2 raised to the power 6 minus 2. This is 64 minus 2 is equal to 62 usable host. So remember this formula. Write in the comment if you have any doubt or further clarification. Question number 4, you are configuring VLANs on a switch and want to assign VLAN 10 to a specific port. Which command would you use in interface configuration mode? And the options are option A, switch port access VLAN 10, option B, VLAN 10, option C, switch port mode trunk, and option D, IP VLAN 10. And the correct option is option A, switch port access VLAN 10. So in interface configuration mode, remember you must first enter the interface configuration mode, and then you will enter this command to assign that VLAN to this specific interface. The command switch port access VLAN 10 assigns the port to VLAN 10. This ensures that any device connected to that port becomes member of VLAN 10. It is used when setting a port as an access port for a specific VLAN. Question number 5. Which command is used to configure a static route to the network 192.168.1.0/24 via the next hop 10.1.1.1? And the options are option A, IP route 192.168.1.0 255.255.255.0, which is this subnet, and 10.1.1.1. Option B, route 192.168.1.0 255.255.255.0 and 10.1.1.1. Option C, set route 192.168.1.0/24 next hop 10.1.1.1. And option D, IP static 192.168.1.0/24 10.1.1.1. And the correct option is option A, IP route 192.168.1.0 255.255.255.0 10.1.1.1. To understand this command, IP route, these are the keyword to enter the specific route. The next is basically the destination network that you want to reach, followed by the subnet mask, and at the last we enter the next hop. So the command IP route 192.168.1.0, 255.255.255.0 and 10.1.1.1.1 creates a static route. It tells the router to reach 192.168.1.0/24 network using the next hop IP address 10.1.1.1. This is standard way to manually add routes in Cisco devices. Question number 6. Which type of ACL, that is access control list, allows filtering traffic based on both source and destination IP addresses? And the options are option A, standard ACL, option B, extended ACL, option C, named ACL, and option D, dynamic ACL. And the correct option is option B, extended ACL. So what is an extended ACL? An extended ACL can filter traffic based on both source and destination IP address. It can also filter traffic by protocol type, port number, giving more control compared to standard ACL. Extended ACLs are usually placed close to the source of the traffic. Question number 7. Which network automation tool is commonly used for configuration management and automation in Cisco devices? And the options are option A, Chef, option B, Ansible, option C, Jenkins, and option D, Docker. And the correct option is option B, Ansible. Ansible is a popular tool used for configuration management and automation in Cisco devices. It uses simple playbooks written in YAML to automate network tasks without needing complex steps. Ansible is agentless, making it easy to use across different network environments. Question number 8. A network engineer is troubleshooting a connectivity issue. The PC can ping its default gateway but cannot reach external websites. Which command should be used next to diagnose the issue? And the options are option A, show IP interface brief, option B, trace route 8.8.8.8, option C, show running config, and option D, show version. And the correct option is option B, trace route 8.8.8.8. So this IP address is basically Google public DNS server, and it can be used by anyone. DNS is basically to resolve domain name to IP addresses. So when you want to test your network or the external connectivity, you can simply ping or trace route this IP address, because this is already always available and is popular IP address of Google public DNS server. So the explanation is, since the PC can ping the default gateway but not external websites, running the trace route 8.8.8.8 helps identify where the connection is failing. Trace route shows the path packets take to the destination and where they get stuck. This makes it easier to spot problems beyond the local network. Question number 9. Which security measure is most effective in preventing a denial of service DOS attack on a network? And the options are option A, enabling port security, option B, implementing an access control list, that is ACL, option C, using intrusion prevention system IPS, and option D, configuring static IP addresses. And the correct option is using intrusion prevention system, that is IPS. And the explanation is, an IPS or intrusion prevention system is the most effective in preventing a denial of service attack because it actively monitors network traffic for suspicious patterns. An IPS can detect and block denial of service traffic in real time, mitigating the impact on the network. While ACLs can help filter unwanted traffic, an IPS is specifically designed to handle and respond to denial of service threats. Question number 10. Which wireless standard operates only on the 5 GHz frequency band and provides higher data rates compared to its predecessor? And the options are option A 802.11a, option B 802.11b, option C 802.11n, and option D 802.11ac. And the correct option is option D 802.11ac. So 802.11ac operates exclusively on the 5 GHz frequency band, unlike 802.11n, which supports both 2.4 and 5 GHz. It provides significantly higher data rates up to several gigabit per second compared to its predecessor, 802.11abgn, due to technologies like wider channel bandwidth up to 160 MHz, high order modulation 250-QAM, and multi-user MIMO, that is multi-user, multi-input and multi-output. 802.11a also operates on 5 GHz but offers much lower speeds, maximum 56 megabit per second. 802.11b operates only on 2.4 GHz and is much slower, maximum 11 Mbps. And 802.11n supports both 2.4 and 5 GHz but is slower than 802.11ac. Question number 11. Which of the following components holds the diagnostic software that is used when the router powers up? And the options are option A interface, option B ROM, option C flash, option D RAM, option E CPU, and option F NVRAM. And the correct option is option B ROM, that is read only access memory. So the ROM, read-only access memory, holds the diagnostic software, also known as the POST, that is power on self-test, used when the router powers up. This software helps ensure that the router's hardware is functioning properly before it proceeds to load the operating system from other storage devices. ROM is non-volatile, so it retains data even when the router is powered off. Question number 12. If a lightweight access point provides at least one BSS for wireless clients, which of the following modes does it use? And the options are option A local, option B normal, option C monitor, and option D client. And the correct option is option A local. So a lightweight AP uses local mode when it provides at least one BSS, that is basic service set for wireless clients. In local mode, the AP forwards data traffic between clients and the wireless controller, allowing the clients to connect to the network. This is the most common mode for lightweight APs in enterprise environments. Question number 13. Which of the following parameters are necessary when creating a new wireless LAN with the controller GUI? Choose two options, and the options are option A SSID, that is service set identifier, option B VLAN number, option C interface, option C BSSID, and option E IP subnet. And the correct options are option A SSID and option B VLAN number. So when creating a new wireless LAN on a controller GUI, the SSID, that is service set identifier, is needed to identify the wireless network, and the VLAN number specifies which VLAN the wireless LAN will be associated with. These two parameters are essential for setting up a new wireless LAN and enabling proper communication on the network. The other options like BSSID and IP subnet are typically not required in the initial setup. Question number 14. How is Telnet used to verify connectivity? Choose two options, and the options are option A, it shows you the path required to reach the end device. Option B, to determine if you have access to a particular service on a device. Option C, it uses ICMP echo request to test connectivity. And option D, to verify basic connectivity to a device. And the correct options are option B, to determine if you have access to a particular service on a device, and to verify basic connectivity to a device. So telnet is used to verify connectivity by allowing you to test access to specific services like SSH or HTTP on a remote device. It is also used for verifying basic connectivity by attempting to establish a connection to a device's specific port, for example, port 23 for telnet. However, telnet does not show the network path or use ICMP echo request, which are characteristic of tools like traceroute and ping. Question number 15. What commands should you configure globally to enable a 15-minute recovery time for the port security error disable state? And the options are option A, error disable recovery interval 15, option B, error disable recovery timer 15, option C, error disable recovery timer 900, and option D, error disable recovery interval 900. This is duplication. And the correct option is option D, error disable recovery interval 900. So to configure a 15-minute recovery time for the port security error disable state globally, you should use the command that specifies the interval in seconds. So this command takes the input in seconds. Since 15 minutes is equal to 900 seconds, that's why we will use the 900 number. So why not the other options? So the option A is having the 15, which is only 15 seconds, and we are aiming for 15 minutes. Option B is using the timer keyword, which is not the correct keyword, should be interval. And again, option C is also using timer, which is not the correct keyword. The correct keyword is basically the interval. Question number 16. What are the considerations when determining the best administrative distance of route sources? Choose two options. Option A, routers choose the routing source with the lowest administrative distance. Option B, multiple routing protocols and static routes cannot be used at the same time. Option C, multiple routing protocol and static routes can be used at the same time. And option D, routers choose the routing source with the highest administrative distance. And the correct options are option A, routers choose the routing source with the lowest administrative distance. And option C, multiple routing protocols and static routes can be used at the same time. So when determining the best administrative distance, routers always prefer the routing source with the lowest administrative distance as it represents the most trusted route. Additionally, multiple routing protocols and static routes can be used simultaneously on a router, with the router choosing the best path based on the administrative distance of each source. This allows for flexible and redundant routing configuration. Question number 17. Which quality of service feature is typically used inbound to a network to limit the amount of traffic that is allowed to flow in? And the options are option A, traffic classification, option B, traffic shaping, option C, traffic limiting, and option D, traffic policing. And the correct option is option D, traffic policing. So traffic policing is typically used in inbound to a network to limit the amount of traffic that is allowed to flow in. It works by monitoring the traffic rate and either dropping or remarking packets that exceed the defined traffic rate, helping to enforce traffic policies and prevent congestion. While traffic shaping is used to smooth out traffic flow, traffic policing is focused on enforcing limits. Question number 18. You want to verify the Cisco iOS software version, RAM version, amount of memory, type of processor, number and types of interfaces, as well as the configuration register value on your 2900 series iOS router. What command will allow you to accomplish this? Option A, show startup configuration. Option B, show running configuration. Option C, show version. And option D, show flash. And the correct option is option C, show version. So the show version command displays important information about a Cisco router, including the iOS software version, ROM version, amount of memory, processor type, number and types of interfaces, and the configuration register values. It provides a full snapshot of the device's basic system information in one place. Question number 19. Which Cisco iOS command is used to advertise a default route into an OSPF domain regardless of whether a default static route is configured? And the options are option A, default information originate, option B, default information originate always, option C, default information originate permanent, and option D, default information originate no check. And the correct option is option B, default information originate always. So the command default information originate always is used in OSPF to advertise a default route in OSPF domain, even if the router does not currently have a default static route configured. The always keyword forces the advertisement, ensuring the OSPF neighbors receive the default route under all conditions. Question number 20. Suppose you would like to select a method to protect the privacy and integrity of wireless data. Which one of the following methods should you avoid because it has been deprecated? Option A, TKIP. Option B, CCMP. Option C, GCMP. And option D, EAP. And the correct option is option A, TKIP. And the explanation is that you should avoid TKIP because it has been deprecated due to known security weaknesses. Modern wireless networks use strong methods like CCMP or GCMP for protecting the privacy and integrity of data. TKIP was originally introduced as a temporary fix for older systems but is no longer considered secure today. Question number 21. Identify advantages of link state protocol. Choose two options, and the options are option A, updates are sent when a topology change occurs. Option B, more information is communicated between routers. Option C, updates are not flooded periodically. And option D, they have reduced scalability. And the correct options are option A, updates are sent when a topology change occur, and option B, more information is communicated between routers. So link state protocols send updates only when a topology change occur, which makes the network more efficient compared to protocols that send update periodically. They also communicate more detailed information between routers, allowing each other to build a complete and accurate map of the network for better routing decisions. Question number 22. Which 802.11 frame type is association response? Option A, management. Option B, protected frame. Option C, action. And option D, control. And the correct option is option A, management. So the association response frame is a management frame in the 802.11 wireless standard. Management frames are responsible for network operations like authentication, association, and disassociation between wireless clients and access points. The association response specifically confirms whether a client's request to join the network has been accepted or denied. Question number 23. In which way does a spine and leaf architecture allow for scalability in a network when additional access ports are required? Option A, a spine switch and a leaf switch can be added with redundant connections between them. Option B, a spine switch can be added with at least 40 GB uplinks. Option B, a leaf switch can be added with connections to every spine switch. And option D, a leaf switch can be added with a single connection to a core spine switch. And the correct option is option C, a leaf switch can be added with connections to every spine switch. So in a spine and leaf architecture, when more access ports are needed, you simply add a new leaf switch and connect it to every spine switch. This keeps the network highly scalable and maintains consistent low latency, ensuring that each device can reach any other device in the network efficiently. So this is basically the leaf and spine architecture. So we have at the top the spine switches, then we have the leaf switches, and the end devices such as servers are connected directly to leaf switches. So let's suppose if we want to, our leaf switches are already populated and we have other end devices. So what we will do, we will add another leaf switch and we will connect it to all the spine switches. So now we have access ports available and we can connect other servers to this leaf switch. So this is how this works. Question number 24. Which ones are true about TCP and UDP? And the options are option A, TCP is slower than UDP. Option B, there is no error checking mechanism in UDP. Option C, TCP has 8 bits header. Option D, UDP has guaranteed transmission. And option T, TCP is a secure protocol, UDP is not secure. And the correct options are option A, TCP is slower than UDP. And option B, there is no error checking mechanism in UDP. So TCP is slower than UDP because TCP provides features like error checking, acknowledgement, and connection management, which add extra processing. UDP is faster but does not provide built-in error checking or guaranteed delivery, making it ideal for real-time applications like video streaming, where speed is more important than reliability. Question number 25, how to enable syslog on Cisco routers? And the options are option A, logging run, option B, logging on, option C, run logging, and option D, start logging, option E, logging start. And the correct option is option B, logging on. So to enable syslog on a Cisco router, you use the command logging on. This command activates the logging process so the router can start recording system messages either locally or to a remote syslog server. So this screenshot, I have taken this screenshot from the packet tracer on a Cisco router. So you can see if you type the login, the global configuration mode, you have this on option, which is enable logging to all enabled destination. So logging on is the correct option. So I have over 12 packet tracer labs for the CCNA exam, and I will give the link of these videos in the description as well as at the end of the video. So when preparing for the CCNA, you should also check these labs. I have selected the labs that will be beneficial for you in the exam. Question number 1 is that refer to the exhibit. This is the exhibit. PCA sends traffic to PCB Which network component is in charge of receiving packet from PCA, verifying the IP addresses and forwarding the packet to PCB? And the options are A. Router, B. Layer 2 switch, C. Load balancer, and D. Firewall. So if we refer to the diagram, we have PCA and the network on the PCA side is 10.10.10.100 and this is the subnet mask. So the PCA address might be, it will be, this is, keep in mind that this is not the IP address assigned to PCA. This is the network address. PCA address maybe this one, 10.10.1, and since this is the router, so here we may have the IP address 10.10.10.2. Similarly, this PCB, it will have an IP address in 10.10.100 network. Let's suppose 1 is the IP address of PCB, and this interface of the router will have IP address of 10.10.100 and it can be, let's suppose, 2. These are switches. So layer 2 switches basically work on the MAC addresses. They don't necessarily route the IP addresses or IP packet, or we can also say that they do not do routing. Routing is done by the router. So this is router. This sitting between the networks, between the two different networks. So always remember, if the PC or the clients are inside the same network, then we don't need router to move traffic between them. But if we have different networks, such as in this case, one network is 10.10.10 and the second network is 10.10.100, then we definitely need a router. So the correct answer here is router. So the network component in charge of receiving the packet from PCA, verifying the IP addresses and forwarding the packet to PCB is a router. Routers operate at layer 3, the network layer of the OSI model. They are responsible for examining the IP addresses in packets, making forwarding decisions based on routing tables, and directing the packets to their appropriate destinations across different networks. So I am taking time here. The purpose is that you understand the core and the basic concepts of the network. So your purpose should not be only to pass the CCNA, but rather also to learn the networks. So you can pass the CCNA, even you can use the dumps, but your main purpose should be to learn the networking, because when you land at the job, there you will be tested on your practical skill, and you can go ahead in your career if you know the concepts and you know the practical things going on inside the network. So let's move forward to the next question. Again, here again we have the exhibit. So refer to the exhibit R1. Router R1 has just received a packet from host A that is destined to host B. So here is R1 and it has received packet from host A which is destined for host B. Which route in the routing table is used by R1 to reach the host? And here we have multiple routes option. They same go to the, or they same route the packet to the destination host B. And the options are option A 10.10.13.0/35, 111. So these all are basically administrative distances. What are these? We will just talk about it shortly. So these are the next hops. Option B, again the same network, and this time the administrative distance is 108, and this is through the next hop 10.10.10.10. Option C, again the same network, this time the administrative distance is 110, and this is via dot 6, and last option again the same network. Again the administrative distance is 110, and this time it is through dot 2. So here we can see on the R1 we have configured some. This is a default route, and these are static routes with this specific destination network, and these next hops, and these are administrative distances. So remember the rule that the administrative distance is inversely proportional to the selection of route. What does this mean? This means that if we have two routes, one have administrative distance of 5 and the other have 10, then the route with the less administrative distance is preferred. So here we can see the least administrative distance is this one. So our answer will be this one, because this route will be preferred due to less administrative distance. So these are static routes. We have configured administrative distances of 111, 112, and 108. So this is preferred. The OSPF configured here is basically the dynamic routing protocol, while these are static routes. So this 110, this is the administrative distance of OSPF protocol, 110. But since we have configured a route with the less administrative distance 108, therefore the traffic will go through the option B route, that is with the next hop 10.10.10, that is this one, that has the least administrative distance out of all. Question number 3, which networking function occurs on the data plane? And the options are A, processing inbound SSH management traffic, option B, sending and receiving OSPF hello packets, option C, facilitates spanning tree elections, and option D, forwarding remote client server traffic. And the correct option is option D, forwarding remote client server traffic. So the data plane is responsible for the actual forwarding of packets based on the routing table information. It handles the high-speed processing and movement of data through the network. Forwarding remote client-server traffic directly involves the transfer of data between the endpoints on the network, which is a core function of the data plane. The other options involve control functions that are processing inbound SSH management traffic is a management plane function dealing with device configuration and monitoring. Sending and receiving OSPF hello packet is a control plane function involved in establishing and maintaining routing information. Facilitating spanning tree elections is also a control plane function responsible for determining the optimal path for data frames within a network. So remember this rule that route calculation is done at the control plane. But once the route is calculated, it is available in the routing table, or we can also say it forwarding table. And this forwarding table lies in the data plane. So when you first configure the static route, or when the OSPF is doing its calculations to determine the optimal path, it is done inside the control plane. But once the optimal path is calculated, it is forwarded to the data plane, and here it is used to forward the traffic and data speedily, because we don't need to go to the route control plane again and again. Once it is calculated, it is readily available inside the forwarding table and data plane for speedy forwarding of the traffic. Question number 4. What are two functions of a layer 2 switch? Choose two options. Options are A. Acts as a central point of association and authentication servers. Option B. Selects the best route between networks on a WAN. Option C. Moves packets within a VLAN. Option D. Moves packets between different VLANs. And option E. Makes forwarding decision based on the MAC address of a packet. And the correct options are option C, it moves packets within a VLAN, and option E, moves forwarding decision based on the MAC address of a packet. So we studied in a previous questions that the forwarding decision based on the IP address is done by the router, and router is a layer 3 device. While the switch, which is a layer 2 device, it does the forwarding decision based on the MAC address, and it can also move traffic within the same VLAN. When we want to move traffic between different VLANs, then again for different VLANs, we need router, and this process is known as inter-VLAN routing. When you want to route the traffic between different VLANs, it is known as inter-VLAN routing, and since routing is involved, it is done through the router. So this is the explanation of again these two specific functions that is done by the layer 2 switch. Question number 5. An engineer observes high usage on the 2.4 GHz channels and lower usage on the 5 GHz channels. What must be configured to allow clients to preferentially use 5 GHz access points? And the options are option A, client band select, option B, re-anchor roamed clients, option C, OEAP split tunnel, and option D, 11AC MU-MIMO. And the correct option is option A, client band select. So client band select helps steer dual band clients, that is clients that can operate on both 2.4 GHz and 5 GHz bands, to the 5 GHz bands by delaying responses to the 2.4 GHz association request and actively encouraging connections to the 5 GHz band, which is typically less congested and offers higher throughput. Question number 6. Under which condition is TCP preferred over UDP? And the options are A. UDP is used when low latency is optimal and TCP is used when latency is tolerable. Option B. TCP is used when dropped data is more acceptable and UDP is used when data is accepted out of order. Option C. TCP is used when data reliability is critical and UDP is used when missing packets are acceptable. And option D. UDP is used when data is highly interactive and TCP is used when data is time sensitive. And the correct option is option C. TCP is used when data reliability is critical and UDP is used when missing packets are acceptable. So in TCP we need reliability, while in UDP we can accept the loss of data, but we need real time and speedy delivery of data. So TCP transmission control protocol is designed for reliable data delivery. It guarantees that data is delivered correctly in order and without errors. This makes it suitable for applications like file transfer, email, and web browsing. So let's suppose consider if you are checking your bank balance, your bank account balance inside your browser, and you cannot accept that your account's balance, let's suppose it is $7,000. You cannot accept that during transmission 10 goes missing and it shows you $700. So that's why during browsing or email or file transfer, we don't or we cannot accept loss of any bit of data. We want absolute reliability. While UDP user datacom protocol is a connectionless protocol that prioritizes speed over reliability. It does not guarantee delivery or order of packets, making it suitable for applications like real-time streaming, video, audio, online gaming, and DNS. So if you are audio calling someone, you cannot wait for the data to arrive and then speak. You want to the conversation to be in real time so that both can talk to each other in real time and respond to each other. You may accept a little bit of jitter or noise, a little bit of noise in the voice due to packet loss, but you cannot accept that you have to wait few seconds so that the voice arrives and then you respond. Meanwhile, the other person may also be talking again. So UDP is suitable for that kind of traffic where real-time information is required without any latency and delay. Let's move forward to next question. Question number 7. What is a network appliance that checks the state of a packet to determine whether the packet is legitimate? By legitimate here we means that whether the packet is allowed by policy inside the network. And the options are A. Layer 2 switch, B. lane controller, C. load balancer, and D. firewall. And the correct option is firewall. So firewall is used to allow access or deny access to the packets depending upon the configured firewall policies. So a firewall is a network appliance that checks the state of a packet to determine whether it is legitimate. It does this through a process called packet filtering. Firewall examines packet header for information like source and destination IP addresses, ports, and protocols. By comparing this information against a set of security rules, the firewall decides whether to allow, block, or modify the packet. So that is the function of the firewall, to allow or deny the packet inside the network. Question number 8. What is the role of access point in an enterprise network? And the options are A. Integrate with SNMP in preventing DDoS attacks. Option B. Serve as a first line of defense in an enterprise network. Option C. Connect wireless devices to a wired network. And option D. Support secure user logins to devices on the network. And the correct option is option C. Connect wireless devices to a wired network. So here we can see that this is our wireless access point that we are talking about, and it is used to connect these wireless devices to the wired network. So this is our wired network, and if we have wireless devices, these can be connected to this wired network through this wireless access point. Let's suppose this PC or laptop wants to connect to the internet. It cannot do this wirelessly. It must go through the access points, and the access point will then route the traffic to the internet. Question number 9. An implementer is preparing hardware for virtualization to create virtual machines on a host. What is needed to provide communication between hardware and virtual machines? And the options are A. router, B. hypervisor, C. switch, and D. straight cable. And the correct option is hypervisor. So a hypervisor is used as an interface between hardware and the virtual machines to make this abstraction layer and allows the virtual machine to equally get access to the physical resources. So these are some popular hypervisors. These are the VMware hypervisor, VMware ESXi and VMware vSphere, while the Hyper-V is the Microsoft hypervisor, while Oracle VM is the Oracle hypervisor. So the hypervisor basically sits between the virtual machines and the hardware. You can say that the hypervisor is basically virtualization operating system, because it sits directly on the bare metal hardware. Just like your PC on which you install OS, Windows OS or Linux OS, this hypervisor is directly installed on this hardware, and upon this hypervisor then we create virtual machines, and these virtual machines can then have operating systems such as Windows or Linux. So that is the concept of the hypervisor. Question number 10. What is the maximum bandwidth of a T1 point-to-point connection? So T1 is a connection or bandwidth standard, and we have different data rates. So what is the maximum bandwidth or data rate of T1? And the options are A 1.544 megabit per second, B 2.048 Mbps, C 34.368 Mbps, and D 43.7 Mbps. And the correct option is option A 1.544 Mbps. So these are different connection standards. These are their speeds. These are number of voice circuits that they support, and these are the location that they are used in. So we have 2.408. This is basically the speed of E1 which is used in Europe, while T1 standard is used in North America, and it has a data rate of 1.544. So again, T2 is basically 4.4 times T1. If you multiply this by 4, we get T2, and we have this multiply by 4, we have this 96 voice channels, and again T3. This is again multiplied by, you can calculate, and then this is for same goes for E1, E2 and E3. Question number 11. What are two similarities between UTP Cat5e and Cat6a cabling? Choose two options. And the options are A, both support speeds up to 10 gigabit. Option B, both support speeds of at least 1 gigabit. Option C, both support runs of up to 55 meters. And option D, both support runs of up to 100 meters. And option E, both operate at a frequency of 500 megahertz. The correct options are option B, both support speeds of at least 1 gigabit. Here at least means that the Cat6a may have additional speed, but it also support a minimum speed of 1 gigabit per second. It may also support speed of 10 gigabit per second. And the second correct option is that both support runs of up to 100 meters. So both supports a distance of up to 100 meters. Question number 12. Which network action occurs within the data plane? Again, we have the options of A, reply to an incoming ICMP echo packet. Option B, make a configuration change from an incoming netconf RPC. Option C, run routing protocols OSPF, EIGRP, RIP, BGP. And option D, compare the destination IP address to the IP routing table. And the correct option is option D, compare the destination IP address to the routing table. So as I already clarified in our previous questions, that once the routing table is calculated, it is available in the data plane. And the comparison of IP address is done against this routing table inside the data plane. So the routing protocol, running of the routing protocol or their calculation is done at the control plane. So that's the difference again between data and control plane, that the routing protocol basically run or calculate the optimal paths inside control plane, and once the paths are calculated, they are populated inside the routing table that is available at the data plane. Again, this is the explanation. You can pause the video and read it. Question number 13, refer to the exhibit. The link between PC1 and the switch is up. This is the link between PC1 and switch. It is up, but it is performing poorly. Which interface condition is causing the performance problem? And the options are A, there is an issue with the fiber on the switch interface. Option B, there is a duplex mismatch on the interface. Option C, there is an interface type mismatch. And option D, there is a speed mismatch on the interface. And the correct option is that there is a duplex mismatch on the interface. Here it is why. Here we can see that on PC we have manually configured the interface setting as 100 Mbps speed and full duplex. So these settings are configured manually, while on the switch we have configured the duplex to be auto and speed to be also auto, and the speed can be 10 as well as 100 megabit per second. So these two basically creates the mismatch, because here, since the duplex is auto, this switch interface may go to half duplex, while here it is full duplex. So this mismatch causes the poor performance. So let me read the explanation. The switch interface is configured for auto duplex mode, which means it will attempt to negotiate the duplex mode with the connected device PC1. However, PC1 is manually configured for full duplex mode. This mismatch can lead to communication errors and reduced performance. Possible solutions are: to resolve the performance issue, you can either configure the switch interface FA01, this one, for full duplex mode. This will match the duplex mode of PC1 and eliminate the mismatch. And you can also configure PC1 for auto duplex mode. This allows the switch and PC1 to negotiate the duplex mode automatically, ensuring compatibility. So remember, when you configure switch and client devices, remember that both sides of the interfaces should be in the same format. If it is manually configured as, let's suppose, full duplex, you need to also configure this to full duplex. If this is auto, you need to also configure this one auto, so that they can mutually negotiate the appropriate mode. Question number 14. Why was the RFC 1918 address space defined? And options are A, conserve public IPv4 addressing. Option B, support the NET protocol. Option C, preserve public IPv6 address space. And option D, reduce instances of overlapping IP addresses. And the correct option is option A, conserve the public IPv4 addresses. So remember, what is RFC 1918? RFC stands for request for command. So this RFC basically defines the private IP address ranges that are 10.0.0/8, 172.16.0.0/12 and 192.168.0.0/16. So these are the private IP addresses defined inside the RFC 191 net, and they can be used by everyone and anyone inside their private network. So they help preserve the public IPv4 address. These are private, and besides these, all IP addresses are public. Let's suppose if I write an IP address, let's suppose 8.8.4.8. So since this one is not in this range, this is a public IP addresses. So the purpose of these private addresses was to conserve the public IPv4 addressing space. Question number 5. Which type of organization should use a collapsed core architecture? And the options are A, small and needs to reduce networking costs. Option B, large and must minimize downtime when hardware fails. Option C, large and requires a flexible, scalable network design. And option D, currently small but is expected to grow dramatically in the near future. And the correct option is option A, small and needs to reduce networking costs. So what is basically a collapsed core architecture? So this is a collapsed core architecture. This is basically three-tier architecture. And when you combine these two layers into one, this one is known as collapsed tier architecture, or we can also call it two-tier, because here we have two tiers. So this is ideal for small organizations because this is simple, management is easy, and it can fulfill the requirements of small organizations. And this is the explanation. A collapsed core architecture combines the core and distribution layer into a single layer, simplifying the network design and reducing the need for additional hardware. This is cost effective for small organizations that do not require the extensive redundancy and scalability provided by multi-layer architecture. Question number 16. What is an appropriate use for private IP version 4 addressing? And the options are A, to allow host inside to communicate in both directions with hosts outside the organization. Option B, on internal hosts that stream data solely to external resources. Option C, on the public facing interface of a firewall. And option D, on hosts that communicate only with other internal hosts. And the correct option is option D. So the IP version 4 is used on hosts that communicate only with other internal hosts. So as we already studied that our IP version 4 addresses are defined in RFC 1918, and these are 10.0.0.0/8, 172.16.0.0/12, and 192.168.0.0/16. So these three ranges of addresses can be used inside internal networks, and they can be given to the host that can communicate with other internal hosts inside a private network. Question number 17. What is again we have a question about IPv4 addressing. What is a characteristic of private IPv4 addressing? And the options are A, composed of up to 65,535 available addresses. Option B, issued by IANA in conjunction with an autonomous system number. Option C, used without tracking or registration. And option D, traverse the internet when an outbound ACL is applied. And the correct option is the IP version 4 addresses are used without tracking or registration. What does this mean? That the IP addresses are basically given and registered with IANA organization. The public IP addresses, but the private IP addresses does not require any registration or any tracking because they are used inside private network and they can be used by anyone anywhere, but they cannot be used on the internet. For the internet, we use public IP addresses, and these addresses then require tracking and registration. Question number 18. What is the function of a controller in controller-based networking? And the options are A, it serves as the centralized management point of an SDN architecture. SDN is software-defined networking. Option B, it is a pair of core routers that maintain all routing decisions for a campus. Option C, it centralizes the data plane for the network. And option D, it is the card on a core router that maintains all routing decisions for a campus. And the correct option is option A, it serves as the centralized management point of an SDN architecture. So this is basically a high-level architecture of SDN, software-defined networking. And it has basically two main planes, control plane and forwarding plane. In traditional networks, the control plane and data plane, let's suppose this is a switch. This is switch. So here we have both control plus data plane. This is a traditional switch or traditional networking. While in SDN, the control plane and the data plane, they are separated. Control is centralized inside a particular device. Let's suppose we can say this device a controller. This can be a server or a VM. And all the intelligence, all the policies, they reside inside the controller and then they are pushed to other devices that are inside the data plane. So this controller is also known as the brain. Brain or the intelligence. So all the intelligence policies and controls are centralized inside the controller, while these are simple switches, and the policies, routing, and the configuration are pushed from the controller to these switches. And the forwarding data plane basically lies below this line inside these switches. Question number 19. How do TCP and UDP fit into a query responsible model? And the options are A, TCP avoids using sequencing and UDP avoids using acknowledgements. Option B, TCP establishes a connection prior to sending data and UDP sends immediately. Option C, TCP encourages out-of-order packet delivery and UDP prevents reordering. And option D, TCP uses error detection for packets and UDP uses error recovery. And the correct option is option B, TCP establishes a connection prior to sending data and UDP sends immediately. So the TCP basically establish a three-way handshake establish a connection using three-way handshake, and this is SYN, also known as SYN, SYN-ACK, and ACK. So this is the three-way handshake that is used by TCP before data transfer for establishing a connection, while UDP does not require any connection, does not require prior connection before sending data. It sends data immediately. Question number 20. What provides centralized control of authentication and roaming in an enterprise network? And the options are A, a lightweight access point, B, a wireless LAN controller, C, a firewall, and D, a LAN switch. And the correct option is option B, a wireless LAN controller. So here is B's brief explanation of wireless LAN controller. It gives us centralized authentication, it helps us with roaming, and it gives us efficient management. You can read the explanation further by pausing the video. Question number 21. What are two characteristics of an SSID? And we have to choose two options. And the options are A, it uniquely identifies a client in a wireless LAN. Option B, it is at most 32 characters long. Option C, it uniquely identifies an access point in a wireless LAN. Option D, it provides secure access to a wireless LAN. And option E, it can be hidden or broadcasted in a wireless LAN. And the correct options are, so the SSID is basically, you must have seen the Wi-Fi broadcast name that you see on your mobile or laptop when you connect to the Wi-Fi network. So that name is known as SSID. So what are the characteristics of that SSID? Option B, it is at most 32 characters long. So it is 32 characters long. It cannot be more than 32 characters. And it can be hidden or broadcast. So by default, this is broadcasted, but there is option inside the access point where you can hide the SSID. Question number 22. When a switch receives a frame for a known destination MAC address, how is the frame handled? And the options are A, flooded to all ports except the one from which it is originated. Option B, forwarded to the first available port. Option C, sent to the port identified for the known MAC address. And option D, broadcast to all ports. And the correct option is sent to the port identified for the known MAC address. So you should be careful with this question. If the question says that the destination MAC address is known, it means that it is already available inside the MAC address table, and it is then sent to the port that is associated with that known MAC address. This option A is used when the MAC address is not known. When the switch receives unknown MAC address, then it is flooded to all ports except the one from which it originated. While for the known, this option is the correct one. So when a switch receives a frame for a known destination MAC, it consults its MAC address table, also known as CAM table. This table maps MAC addresses to specific ports on the switch. The switch then forwards the frame directly to the port associated with the destination MAC address, efficiently delivering the data to the intended recipient. And let me show a screenshot of a MAC address table. So this is a MAC address table. You can view the MAC address table by this command, show MAC address table. And here we can see that we have MAC address and the associated port. So this MAC address may be, let's suppose, of a PC. So the switch knows that this PC is connected to this port. Okay, and this one maybe, let's suppose, a printer. So the switch also knows that this printer is connected to this port. Dynamic means that the MAC address is learned dynamically through ARP, address resolution protocol. You can also statically bind the MAC addresses to the specific ports. So this type dynamic means that the MAC address is learned dynamically. And the VLAN, this is the default VLAN, VLAN 1. Question number 23, what is the collapsed layer in collapsed core architecture? And the options are A, core and distribution, option B, access and WAN, option C, distribution and access, and option D, core and WAN. And the correct option is core and distribution. So when you combine the core and distribution layer in 3-layer architecture, then this becomes the collapsed layer architecture, and this collapsed layer consists of core and distribution. As we already studied, this is the 3-tier architecture, 3-tier network architecture. When you combine the core layer and the distribution layer and form a one layer, then this layer is known as collapsed layer. Question number 24, what is a characteristic of a SOHO network? Small office, home, office, network. And options are A, includes at least 3 tiers of devices to provide load balancing and redundancy. Option B, connects each switch to every other switch in the network. Option C, enables multiple users to share a single broadband connection. And option D, provides high throughput access for 1,000 or more users. And the correct option is that the SOHO network enables multiple users to share a single broadband internet connection. And let me show a SOHO network in a diagram. So this is a SOHO network. Here we can see that we have multiple devices, a smartphone, a laptop, a PC, a tablet. And this is, let's suppose, your access point, your router, or your Wi-Fi device. And this is a single broadband internet connection. So this single connection is shared by these all devices, and this type of network is known as SOHO, simple office, home office. Small office, home office, or simple office, home office. Let's move forward to question number 25. What is the role of disaggregation in controller-based networking? Disaggregation means disintegration or separation. And the options are A, it divides control plane and data plane functions. B, it streamlines traffic handling by assigning individual devices to perform either layer 2 or layer 3 function. Option C, it summarizes the routes between the core and distribution layers of the network topology. And option D, it enables a network topology to quickly adjust from a ring network to a star network. And the correct option is that the Controller-based network are also known as SDN, software-defined networking. It divides the control plane and data plane function. The control plane function, that is policy, routing, and intelligence, is done by control plane. It is separated from the data plane function, and data plane main function is simply forwarding. So in traditional network, these two are together, they are combined, while in SDN they are disaggregated or separated. And this is the explanation. So the control plane and data plane. Control plane is responsible for making decisions about how network traffic should be forwarded, that is the policies, routing, etc. While the data plane is responsible for actually forwarding the traffic according to the data plane control plane's instructions. By separating these two functions, disaggregation allows for increased flexibility. Different hardware and software components can be mixed and matched to optimize performance and cost. Improved scalability, the control plane can handle more devices and traffic without impacting data plane performance. And faster innovation. New features and functionalities can be developed and deployed more quickly. Question number 26. What is a function performed by a web server? And the options are A. Send and receive email from client devices. Option B. Securely store files for FTP access. Option C. Authenticate and authorize a user's identity. And option D. Provide an application that is transmitted over HTTP. And the correct option is option D. Provide an application that is transmitted over HTTP. So this is the function of the web server. It has an HTTP server and files, and these files are transmitted over HTTP protocol. The client, particularly, or the most popular client, is browser. It sends an HTTP request and the server sends HTTP response. So the web server, it does the HTTP, it serves the HTTP server and sends files to the client through HTTP protocol. Let's move forward to the next question. Question number 27. What protocol uses SSL? SSL is Secure Socket Layer. So what is the function of SSL, Secure Socket Layer? And the options are which protocol uses SSL? Options are A. SSH, B. HTTPS, C. HTTP, and D. Telnet. And the correct option is option B. HTTPS. So HTTPS, the secure version of HTTP, it uses SSL, Secure Socket Layer, or its more modern successor, TLS. So the SSL is the old version, the latest version is TLS. TLS has further version 1.1, 1.2, and 1.3. TLS is transport layer security to encrypt data transmitted between a web server and a web browser. This ensures the privacy and integrity of the information exchange. Question number 28. Why is UDP more suitable than TCP for applications that requires low latency such as voice or IP? And the options are option A. UDP reliably guarantees delivery of all packets. TCP drop packets under heavy load. Option B. UDP uses sequencing data for packets to arrive in order. TCP offers the capability to receive packets in random order. Option C. TCP uses congestion control for efficient packet delivery, while UDP uses flow control mechanism for the delivery of packets. And option D, TCP sends an acknowledgement for every packets received while UDP operates without acknowledgements. And the correct option is option D, TCP sends an acknowledgement for every packet received while UDP operates without acknowledgement. So TCP is reliable but slow, while UDP is fast and has low latency because it does not require prior connection, while TCP requires three-way handshake to make a connection before sending data. UDP does not require acknowledgement. TCP sends and receives acknowledgements. And similarly, other functions such as congestion control are also included in TCP, which makes it more reliable but not suitable for real-time and low latency applications such as VoIP, real-time video conferencing, or gaming. Let's move forward to question number 29. And the question is that refer to this exhibit. The router has been configured with a supernet to accommodate the requirements for 380 users on a subnet. The requirements already consider 30% future growth. Which configuration verifies the IP subnet on router R4? So this is a router and we need to configure this network on this router, but the requirements are that it must accommodate 380 user plus 30% growth. So the 30% of 380, it is 380 multiplied by 0.3, and this is equal to 114. So the total user requirements is 380 plus 114, that is 494. So we need to accommodate 494 users in this R4 in this R4 configuration, and we need to configure this subnet. Basically, we need the value of X, and the options are, I won't just read the options. So let's go directly to the correct option, and the correct option is option D. And option D is the subnet is 10.7.54.0. Subnet mask is 255.255.254.0. Broadcast address is, this is the last address, 10.7.55.255, and usable IP address range is 10.7.54.1 up to 10.7.55.254. So basically this X value is, the network is 10.7.54.0/23, and this gives us total IP addresses of 512, and the usable addresses are, if we subtract the broadcast address and the network address, then the usable addresses are 510, which is enough for our requirement, that is 494. The other options are incorrect because the subnet masks all have some correct combination. So this option, option D, is correct because it gives us 510 IP addresses, which is just fine and required, fulfills our requirement of current as well as future growth IP addresses of 494. Let's move forward to question number 30. Sorry guys, it is taking a bit time. And the question is that which two characteristics describe the access layer in a three-tier network architecture? And we have to choose two options, and the options are: A, serves as the network aggregation point; option B, physical connection point for a lane printer; option C, designed to meet continuous redundant uptime requirements; option D, layer at which a wireless access point connects to the wired network; and option E, provides a boundary between layer 2 and layer 3 communications. And the correct options are that the access layer is basically used to physically connect printer or a lane printer, or it is a physical connection point for lane printer. And this second option, correct option, is that it is the layer at which a wireless access point connects to the wired network. So let me show this concept in the three-tier network architecture inside the diagram. So the three-tier network architecture is, it consists of three layers: the core, the distribution, and the access. So we are talking about the access layer. So this layer is used to connect the endpoint devices such as PCs. We can also connect here a printer, such as in our example, as well as we can also connect a Wi-Fi access point that can then broadcast, and wireless devices can be connected to this access point, and this access point gives wired connectivity to these wireless devices through these access switches. So that's all for today. If you like the video, please like and comment, and if you want further such videos, please write in the comment, and I will try to make further videos on the CCNA and networking. Thank you and bye. Question number 1. Refer to the exhibit. Which statement explains the configuration error message that is received? So we have this exhibit here. We can see that this configuration tries to give an IP address to this interface, and this is the IP address and the subnet mask that it tries to give and assign to this interface, but we are receiving this error message. So what is the cause of this error message? And the options are: option A, it is a broadcast IP address; option B, the router does not support /28 mask; option C, it belongs to a private IP address range; and option D, it is a network IP address. And the correct option is the option A, it is a broadcast IP address. So this IP address, the 192.168.16.143, it is a broadcast IP address. Therefore, you cannot assign this to any interface. The broadcast IP address and the network IP address are not assignable to the interfaces. So if we break down this particular network, so here we can see that this is the network address. This is the network address of this particular network. These are the usable IP addresses, and the range is from IP address 129 to IP address 142. And this is the broadcast IP address here we are talking about. So you cannot assign this address and this address to the interface, while these addresses ranging from 129 to 142, they are also known as usable IP addresses. You can assign them to host, you can assign them to the router or switch interfaces, but the broadcast and the network IP address, they cannot be assigned to either the host or the interfaces. So if we have total 16 IP addresses in the network, the usable IP addresses are less than 2. It is 14 because the first, that is the network address, and the last IP address, that is the broadcast IP address, they are not usable. It means they cannot be assigned to the host or to the interfaces. Question number 2. An organization has decided to start using cloud-based or cloud-provided services. Which cloud service allows the organizations to install its own operating system on a virtual machine? And the options are: option A, platform as a service; option B, software as a service; option C, network as a service; and option D, infrastructure as a service. And the correct option is option D, infrastructure as a service. So using infrastructure as a service, the client will be able to install and manage its own operating systems. So the correct answer is D, infrastructure as a service. Infrastructure as a service provides virtualized. Let me get back to the explanation. Infrastructure as a service provides virtualized computer resources over the internet, allowing the organization to install and manage its own operating system and applications on the virtual machine. While the platform and the software as a service, they do not have the flexibility for the client to install and configure their own operating system. So these are all the different models of the cloud services. So in the on-site, it is the traditional model in which you have to do, or the client have to do all the tasks. So this is the blue colored tasks are those that are managed by the client, and the red ones are those that are managed by the service provider. So in the on-site, it is all done by the client. In the infrastructure as a service, up to the OS, middleware, runtime, data, and application are done by the client, while the virtualization, server storage, and networking infrastructure is provided by the service provider. Similarly, in the platform as a service, only the application and data can be managed by the client, while the rest is managed by the service provider. While in the software as a service, the client only use the software, having no ability to configure or manage the underlying infrastructure, including the application, data, runtime environment as well. Question number 3. Which network allows devices to communicate without the need to access the internet? And the options are: option A, 172.9.00/16; option B, 172.28.00/16; option C, 192.000/8; and option D, 209.165.201.0/64. So here we are talking about the private IP addresses that can be used without the access to internet, or they can be used on your local LAN or on your local network. So what is this range, or what are these IP addresses in this particular question? It is the option B. So the 172.28.0.0/16 IP address range is the private IP address that can be used inside your local network. So this range falls within the private IP address space specified by the RFC 1918, which is reserved for use within private networks and does not require access to the internet for devices to communicate with each other. Here are the private IP address ranges according to RFC 1918. So 10.0.0.0 to 10.255.255.255 are 10/8, 10.0.0.0/8. The second range is 192.168.0.0 to 172.31.255.255. So in this particular example, our correct option lies in this particular range. It is /12. And the third range is 192.168.0.0 up to 192.168.255.255 or 192.168.0.0/16. So these three are the private IP address ranges. Question number 4. In which way does a spine and a leaf architecture allows for scalability in a network when additional access ports are required? And the options are: option A spine switch and a leaf switch can be added with redundant connections between them. Option B, a spine switch can be added with at least 40 GB uplinks. Option C, a leaf switch can be added with a single connection to a core spine switch. And option D, a leaf switch can be added with connections to every spine switch. And this is the correct option, the option D, that a leaf switch can be added with connections to every spine switch. So this is the architecture of the leaf and spine architecture. So in this architecture we have spine switches and we have leaf switches. Leaf switches are those to which the end devices such as switches, host, computers or printers are connected, and each leaf switch is connected to every other spine switch. So if you run out of your ports on your leaf switches, what you can do that you can add an additional leaf switch and connect it to every spine switch. So in this way, this architecture is scalable because you can add additional leaf switches when required. So this is the explanation and the correct answer of this question. Question number 5, refer to the exhibit. An engineer configured NAT translation, that is network address translation, and has verified that the configuration is correct. Which IP address is the source IP? So we have this configuration, show IP NAT translations, and here we can see that we are seeing the translations of the inside global, inside local, outside global, and outside local and outside global. So these are the inside local private IP addresses that are basically assigned to the clients. This is the one public IP address, or the public IP addresses that is used by the client to talk with the outside world, and these are the outside IP addresses that you want to communicate. So in this particular question, they are asking about what is the source IP address, and the correct option is the option D, the 172.23.104.4, this one. So this is the source IP address of traffic seen to the outside world. But in reality, this is also the source IP address. This is the original source IP address of the client, and this is a source IP address after translation. So if you see the NAT in action, here you can see these are our private IP addresses. In this case, it is 192.168, but in our case, these are 10.4.4.0 network. Let's suppose it's /24. And this is the public IP address. In our case, this address is 172.23.104.3 and .4 or .3, and this is the public IP address of the outside world. This is again 172.23.103, and let's suppose this is a complete network of /24. So here we can see that this is the source IP address to this host, because the host sees this IP address. It does not see the original source IP address, that is 10.4.4, because this is private IP address not routable on the internet, and this is changed and translated to this local global IP address. I hope this is understandable. Again, refer to the exhibit. An extended ASCL, that is access control list, has been configured and applied to the router R2 the configuration failed to work as intended. Which two changes stop outbound traffic on TCP ports 25 and 82 10.0.20.026 from the 10.0.10.0/26. So this is .0/26 subnet while still allowing all other traffic. So here what we want to do is that we want to stop specific type of traffic from this subnet to this subnet. And what is that specific traffic? That we want to traffic to port 25 and port 80 from this IP address to this IP address be blocked on this router using this configuration. But as per the configuration, the traffic is not stopped and it does not work. So what is the solution to correct this configuration and make it work? And the options are: option A, add a permit IP any statement to the beginning of ACL 101 for allowed traffic. Option B, add a permit IP any statement at the end of ACL 101 for allowed traffic. Option C, the source and destination IPs must be swapped in ACL 101. Option D, the ACL must be configured on the gigabit 0/2 interface inbound on R1. And option E, the ACL must be moved to the GI01 interface outbound on the R2. And the correct options are: the first correct option is that add a permit IP any statement and at the end of ACL 101 for allowed traffic. So we want to deny or drop only traffic to the port 25 and 80 while allowing the rest of the traffic. So you must add this statement at the end of these two statements to allow other type of traffic beside that of destined for port 25 and port 80. And the second correct option is that the source and destination IPs must be swapped in ACL 101. So here in our case, this is the source and this is the destination, while in the configuration they are incorrectly written. So in our rules, this is written as the source, while this is written 10.0.10 is written as the destination, while in fact this is our source and this is destination. So these must be flipped. Here we must write 10.0.10.0 and here we should write 10.0.20. Similarly, here we should write 10.0.10.0 and here 10.0.20.0. So changing these two configuration changes will make the configuration work. It will deny or stop the traffic to the port SMTP, that is port 25, and to www, that is port 80. And once we block these two traffic to these two ports, we will add this statement so that other traffic from this source to this destination is allowed. I hope this is understandable. If there is any question regarding this question or any other question, you can ask me in the comment section and I will happy to reply. Let's move forward to the next question. Question number 7. Which mode must be used to configure Ether channel between two switches without using a negotiation protocol? And the options are: option A, on; option B, auto; option C, active; and option D, desirable. And the correct option is option A, on. So to configure Ether channel without using a negotiation protocol like PAGP, port aggregation protocol, or LSAP, link aggregation control protocol, you need to use the on mode. This mode forces the port to join an ether channel without any negotiation. Auto and desirable modes involve negotiation protocols. Active mode is for LACP, which is also a negotiation protocol. So, a quick guide to what is ether channel. So, in ether channel, we combine two or more than two ports between two switches, and the purpose of this is to increase the bandwidth. So, if this is 10G and this is also 10G, after combining them through ether channel, our effective bandwidth will increase to 20G, and this also gives us redundancy. If one port is down due to any reason, then the connection or link is still up through the other port. You can combine more than two ports. Question number 8. When configuring a wireless LAN with WPA2 PSK in the Cisco Wireless LAN Controller GUI, which two formats are available to select? Choose two, and the options are option A ASCII, option B base 64, option C binary, option D decimal, and option E hexadecimal. And the correct options are option A ASCII and option E hexadecimal. So when configuring a wireless LAN with WPA2 PSK in Cisco Wireless LAN Controller GUI, you typically have the option to input the pre-shared key in either ASCII or hexadecimal format. ASCII is the standard character encoding for most modern computer systems. Hexadecimal is a base 16 number system often used for representing binary data in a more human-readable format. Question number 9. Which command entered on a switch configured with rapid PVST listens and learns for a specific time period? And the options are option A spanning tree VLAN 1 message 6, option B spanning tree VLAN 1 hello time 10, option C spanning tree VLAN 1 priority 4096, and option D spanning tree VLAN 1 forward time 20. And the correct option is the correct option is actually option D, spanning tree VLAN 1 forward time 20. It configures the forward time of a VLAN. The forward time value can be from 4 to 30 seconds. So this value is basically seconds. Question number 10. Let me move a little back. Which attribute does a router use to select the best path when two or more different routes to the same destination exist between two different routing protocols? And the options are option A dual algorithm, option B metric, option C administrative distance, and option D hop count. And the correct option is option C administrative distance. So administrative distance is the feature used by routers to select the best path when there are two or more different routes to the same destination from different routing protocol. Administrative distance defines the reliability of a routing protocol. What does this mean? That let's suppose this is our router and let's suppose this is internet, and let's suppose this is another router. So this router learns two paths. One is this is let's suppose static, and this one is learned through the OSPF, and they both leads to the same destination. So which one would be preferred? The one with less administrative distance. If the static administrative distance is let's suppose 10, and the OSPF administrative distance is 110, then this one will be used or selected. So that is the concept behind the administrative distance, that when you have two or more paths to the same destination that are learned through different routing protocols, then the one with the less administrative distance will be preferred. Question number 11. Which command prevents password from being stored in the configuration as plain text on a router or switch? And the options are: A. Enable secret, B. Service password encryption, C. Username Cisco password encrypt, and option D. Enable password. And the correct option is service password encryption. So what does this command do? This command encrypts all the password that are clear text inside your configuration on a particular switch or router. Service password encryption encrypts all clear text password within the configuration file using a weak form of encryption, that is Wagoneer cipher. While it's not the strongest encryption method, it is significantly better than storing passwords in plain text. Question number 12. A frame that enters a switch fails the frame check sequence. Which two interface counters are incremented? Choose two, and the options are: option A, runs, option B, joins, option C, frame, option D, CRC, and option E, input errors. And the correct options are option D, CRC, cyclic redundancy check, and option E, input errors. So CRC, cyclic redundancy check, this counter is incremented because the frame failed the CRC check, indicating that the data within the frame is corrupted. Input errors, this counter is incremented for any errors that occur when receiving frames, including CRC errors, frame errors, runs, and joins. Question number 13. Which command enables a router to become a DHCP client? And the options are: what does DHCP client mean? That the router takes an IP address from a DHCP server as a client, and the options are: option A, IP address DHCP, option B, IP helper address, option C, IP DHCP pool, and option D, IP DHCP client. And the correct option is option A, IP address DHCP. So IP address DHCP is the command used to configure an interface on a router to obtain its IP address dynamically from a DHCP server. This makes the router behave as a DHCP client for that specific interface. The other options are related to different DHCP functionalities. IP helper address is used to configure a router as a DHCP relay agent, forwarding DHCP requests from clients to a DHCP server. IP DHCP pool is used to define a DHCP pool of IP addresses for a DHCP server to assign to clients. An IP DHCP client is not a valid command in Cisco IOS. By using IP address DHCP, the router will automatically acquire an IP address, subnet mask, default gateway, and other network parameters from the DHCP server. Question number 14. Which two encoding methods are supported by REST APIs? Choose two, and the options are: option A, YAML, option B, JSON, option C, EBCDIC, option D, SGML, and option E, XML. And the correct two options are option B, JSON, and option E, XML. So JSON, that is JavaScript object notation, and XML, extensible markup language, are the two primary data formats used for exchanging data in REST APIs. They are human readable and easily parsed by machines. JSON is generally preferred for its simplicity and efficiency, while XML offers more structure and flexibility. Question number 15. Two switches are connected and using Cisco Dynamic Trunking Protocol. SW1 is set to dynamic desirable. What is the result of this configuration? And the options are: option A, the link is in a down state; option B, the link is in an error desirable state, disabled state; option C, the link becomes an access port; option D, the link becomes a trunk port. And the correct option is option B, option D, the link becomes a trunk port. So the dynamic desirable mode actively attempts to convert a link into a trunk. Since switch 1 is configured as dynamic desirable, it will actively negotiate with switch 2 to form a trunk link. If switch 2 is configured as dynamic auto or dynamic desirable, the negotiation will be successful and the link will become a trunk port. Question number 16. When configuring IPv6 on an interface, which two IPv6 multicast groups are joined? Choose two options, and the options are: option A, 2000:/3, option B, 2002:5, option C, FC00:/7, option D, FF02:1, and option E, FF02:2. And the correct options are option D, FF002:1, and option E, FF02:2. So when an interface is configured with IPv6 address, it automatically joins the all nodes, that is FF02:1, and solicited node, that is FF02:1 FFXX:XXXX multicast groups. The all node group is used to communicate with all interfaces on the local link, and the solicited nodes multicast group is required for link layer address resolution. Routers also join a third multicast group, the all routers group, that is FF02:2. Question number 17. Which MAC address is recognized as VRRP virtual address? And the options are: option A, 0000.5E00.010A, option B, 0005.3711.0975, option C, tetra0.0C07.AC99, and option D, 0007.C070/AB01. And the correct option is option A, tetra0.5E00.010A. And why is that? So the VRRP, that is Virtual Router Redundancy Protocol, uses a specific MAC address format for its virtual routers. This format is basically 0000.5E00.01XX, where the XX represents the VRRP group ID in the hexadecimal format. Therefore, among the options provided, only option A matches the VRRP virtual MAC address format. The other options are standard MAC addresses used for physical network interfaces. So, this is basically the format of VRRP RRP virtual MAC address, where the last two numbers are in hexadecimal and represent the VRRRP group ID. Question number 18. Which type of wireless encryption is used for WPA2 in pre-shared key mode? And the options are option A, TKIP with RC4, option B, RC4, option C, AES-128, and option D, AES-265. And the correct option is option D, AES Advanced Encryption Standard with 256 key length. So the type of wireless encryption used for WPA2 in pre-shared key, that is PSK mode, is AES-256. WPA2 uses Advanced Encryption Standard for encryption, and in pre-shared key mode it typically employs AES with a 256-bit key for enhanced security. Question number 19. Which two actions are performed by the weighted random early detection mechanism? Choose two options, and the options are option A, it drops lower priority packets before it drops higher priority packets. Option B, it can identify different flows with a high level of granularity. Option C, it guarantees the delivery of high priority packets. Option D, it can mitigate congestion by preventing the queue from filling up. And option E, it supports protocol discovery. And the correct options are option A, it drops lower priority packets before it drops higher priority packets. And option D, it can mitigate congestion by preventing the queue from filling up. So the weighted random early detection, that is WRAD mechanism, perform the following two options, option A and option D. So the RAD is a congestion avoidance mechanism that selectively drops packets based on their priority and queue depth, helping to manage network traffic and prevent congestion before queues become full. Question number 20. When a floating static route is configured, which action ensures that the backup route is used when the primary route fails? And the options are option A, the floating static route must have a higher administrative distance than the primary route, so it is used as a backup. Option B, the administrative distance must be higher on the primary route so that the backup route becomes secondary. Option C, the floating static route must have a lower administrative distance than the primary route, so it is used as a backup. And option D, the default information originate command must be configured for the route to be installed into the routing table. And the correct option is option A, the floating static route must have a higher administrative distance than the primary route, so it is used as a backup. So it means that the primary route will have a less administrative distance than the secondary floating static route. So the administrative distance works such that the less is the route with less administrative distance is preferred. So if you have two routes, one have 5 administrative distance and the other have 10, then the one with the 5 administrative distance is preferred and selected. So administrative distance is a metric used by routers to determine the best path to a destination. Lower administrative distance values indicate a more preferred path. A floating static route is a static route configured with a higher AD than the primary route, typically learned via dynamic routing protocol. When the primary route fails, the router will look for the next best option based on administrative distance. Since the floating static route has a higher AD, it becomes the preferred path. Question number 21. Which mode allows access points to be managed by Cisco wireless LAN controllers? And the options are option A, autonomous, option B, lightweight, option C, bridge, and option D, mobility express. And the correct option is option B, lightweight. So in lightweight mode, access points are managed by Cisco wireless LAN controllers. This mode allows the controller to handle configuration, management, and data traffic, providing a more centralized management approach for the wireless network. Question number 22. Which QoS or quality of service profile is selected in the GUI when configuring a voice over wireless LAN deployment? And the options are option A, bronze, option B, platinum, option C, silver, and option D, gold. And the correct option is option B, platinum. So in a voice over wireless LAN deployment, the platinum quality of service profile is typically selected in the GUI. This profile prioritizes voice traffic to ensure high quality and minimal latency for voice calls. Question number 23. If a notice level messaging is sent to a syslog server, which event has occurred? And the options are option A, a network device has restarted. Option B, an ARP inspection has failed. Option C, a routing instance has flagged. And option D, a debug operation is running. And the correct option is option C, a routing instance has flagged. So notice level messaging typically indicates a normal but significant condition. A routing instance flapping is considered a significant event that requires monitoring but does not necessarily require immediate action. Other options involve more critical events that would likely generate higher severity levels. For example, alert, critical, and error. Question number 24. What are two southbound APIs? Choose two, and the options are option A, OpenFlow, option B, netconf, option C, thrift, option D, Corba, and option E, DSC. And the correct options are OpenFlow and option B, the netconf. Explanation. So southbound APIs are used for communication between a network controller and network devices like switches and routers. So the OpenFlow is a widely used protocol for SDN, that is software defined networking, that provides a standardized way for controllers to program network devices. netconf is another protocol used for configuring network devices, often used in conjunction with Yang data modeling language. So this is how the northbound and the southbound APIs work. So in this direction, this is north, and this is south. So the southbound API means that data flow direction or the configuration direction is towards south. So here this is the controller, and when this controller manages or configures the devices such as the network switches or router, then the direction is towards south. That's why this is called the southbound API. While the SDN layer above the controller, the controller direction in this case is towards north. Let me get back. Such as here we have virtual services, applications, etc. that consumes this controller services. So since they are above the controller layer, so that's why these APIs are known as the northbound APIs. I hope this is clear. Question number 25. An email user has been lured into clicking a link in an email sent by their company's security organization. The web page that opens reports that it was safe, but the link could have contained malicious code. Which type of security program is in place? And the options are option A, physical access control, option B, social engineering attack, option C, brute force attack, and option D, user awareness. And the correct option is user awareness program. So this is a simulation type of user awareness program where security department of the organization sends email to their own employees such that to educate them with such type of link that may be sent from malicious actors. So this is a type of practical training. Instead of just giving lectures, they are practically sent links through to their email addresses, and this type of simulated awareness program is part of the user awareness. So the scenario described in the question is an example of a security program designed to educate and raise awareness among users about the dangers of phishing and other social engineering attacks. This type of program is typically aimed at improving user awareness and ensuring that users are vigilant about potential security threats. Question number 26. An engineer must configure a /30 subnet between two routers. Which usable IP address and subnet mask combination meets this criteria? So here we have, let's suppose, two routers, and we need to configure two IP addresses between them using a /30 subnet. So these are the four scenarios that can be used, option A, B, C, and D. So what is the correct option? So in option A we have 209.165.201.2, while the subnet mask is 255.255.255.252. In option B it is 10.2.1.3 and the subnet mask is again 252. In option C the IP address is 172.16.1.4 and the subnet mask is 248. So remember, this is /29. This is not /30. Okay, so this one, this is not the, this surely goes out of our correct option. So this cannot be the correct answer. And this one also, this has a subnet mask of 248, while we require to configure with a /30. So the correct option must be from this option A or option B. So let's see what is the correct option. And the correct option is option A, 209.165.201.2, while 252 is the subnet mask. So why this is not the correct option and this is the correct option? It is because if you break down the whole network, then we have, this is the, let's suppose, the IP address, this is the network address, this is the broadcast address. We have total 4 addresses and 2 are usable, and the usable addresses are 1 and 2. So again, as we studied in our earlier question, you cannot assign the broadcast address or network address to an interface. You can only assign the usable IP addresses. So either you can assign 1 or 2. On one router you will assign .2, and on the second router you will assign .1. So here let's suppose it is .1 and this is .2, and the rest of the IP will be this. Let's suppose this is R1 and this is R2. I hope this is clear. Question number 27. What is the default behavior of a layer 2 switch when a frame with an unknown destination MAC address is received? And the options are: option A, the layer 2 switch drops the received frame. Option B, the layer 2 switch floods packets to all ports except the receiving port in the given VLAN. Option C, the layer 2 switch sends a copy of a packet to CPU for destination MAC address learning. And option D, the layer 2 switch forwards the packet and adds the destination MAC address to its MAC address table. And the correct option is option B, the layer 2 switch floods packets to all ports except the receiving port in the given VLAN. So the default behavior of a layer 2 switch when it receives a frame with an unknown destination MAC address is to flood the frame to all ports except the one on which it was received within the same VLAN. This ensures that the frame reaches its intended destination, and when the destination device responds, the switch can learn and record the MAC address in its MAC address table for future use. Question number 28. An engineer is asked to protect unused ports that are configured in the default VLAN on a switch. Which two steps will fulfill the request? Choose two options. And the options are: option A, configure the port in an ether channel. Option B, administratively shut down the port. Option C, configure the port type as access and place in VLAN 99. Option D, configure the port as trunk ports. And option E, enable the Cisco discovery protocol. And the correct option is that the unused ports should be administratively shut down and they should be configured in the port type as access and placed in a VLAN such as VLAN 99. These two options are the most effective way to protect unused port on a switch. Administratively shutting down the port physically disables the port, preventing any traffic from being sent or received. Configuring the port type as access and placing it in the VLAN 99 isolates the port from the default VLAN and places it in a dedicated unused VLAN. This prevents unauthorized access through the port. Question number 29. Which command is used to specify the delay time in seconds for LLDP to initialize on any interface? And the options are: option A, LLDP timer. Option B, LLDP hold time T. Option C, LLDP reinit. And option D, LLDP TLV select. And the correct option is option C, LLDP reinit. So the command to specify the delay time in seconds for LLDP to initialize on any interface is LLDP reinit. This command sets the delay time before LLDP reinitialization occurs. Question number 30. A network engineer must backup 20 network router configurations globally within a customer environment. Which protocol allows the engineer to perform this function using Cisco IOS MEB? And the options are: option A, CDP, option B, SNMP, option C, SMTP, and option D, ARP. And the correct option is option B, SNMP, Simple Network Management Protocol. So the SNMP Simple Network Management Protocol is the correct choice. It allows network devices to be managed and monitored remotely, including retrieving configuration data like router configurations. SNMP uses management information bases, that is MIPS, to define the structure and content of network management information. The Cisco IOS MIB provides specific information about Cisco routers, including configuration data. Question number 1. Which type of address is the public IP address of a net device? Network address translation device, and the options are option A, outside global, option B, outside local, option C, inside global, and option D, inside local. And the correct option is the inside global. So these are the different type of IP addresses that are used inside and outside and on the net device or the net router. So these are the inside local IP addresses, including this. This is the inside global, that is the public IP address, or we can also call it the net inside global IP address. And then this is the outside global. And let's suppose if we have a LAN over here and we have private IP addresses such as 192.168, then this can be known as the outside local. So this is the concept of these different type of IP addresses when we use NAT. This is inside local, this is inside global, this is outside global, and this is outside local. So in this particular case, this inside global IP address is the public IP address of the net devices. These all devices have the private IP address, and they use this public IP address to communicate with the outside world or the outside host over the internet. Question number 2. Which IP is used in controller-based architectures to interact with edge devices? And the options are option A, overlay, option B, northbound, option C, underlay, and option D, southbound. And the correct option is option D, southbound. So this is basically the SDN controller, and these are the edge devices that we are talking about, the network switches. So the controller talks with the network switches using the southbound APIs, while on the other hand, it talks through the northbound APIs with the virtual services such as applications. So this, in this direction we have north, in this downward direction we have south. So the APIs that are having the direction towards south and talks with the edge devices are known as the southbound APIs, while the API that are in the direction of the north and that interacts with the virtual services of the SDN layer are basically the northbound APIs. Question number 3. Which statement identifies the functionality of virtual machines? And the options are option A, virtualized server run most efficiently when they are physically connected to a switch that is separate from the hypervisor. Option B, the hypervisor can virtualize physical components including CPU, memory, and storage. Option C, each hypervisor can support a single virtual machine and a single software switch. Option D, the hypervisor communicates on layer 3 without the need for additional resources. And the correct option is option B, the hypervisor can virtualize physical components including CPU, memory, and storage. So how does this work? So this is a representation of the virtualization platform. We have hardware at the lowest layer. Above the hardware, we have the hypervisor, and above the hypervisor, we can install different guest operating systems, and upon these guest operating system, we have the application. So this our hardware is basically virtualized, and each VM is given its own chunk of the hardware. So we can say that the hardware is virtualized by the hypervisor and presented to the VMs or the guest operating systems. Question number 4, refer to the exhibit. So this is the exhibit. How does the router manage traffic to the 192.168.12.16 IP address? And we have three routes and three routing protocol: EIGRP, RIP, and OSPF. And the options are: option A, it chooses the EIGRP route because it has the lowest administrative distance. Option B, it load balances traffic between all three routes. Option C, it chooses the OSPF route because it has the longest prefix inclusive of the destination address. And option D, it selects the RIP route because it has the longest prefix inclusive of the destination address. And the correct option is option D, it selects the RIP route because it has the longest prefix inclusive of the destination address. So that is, destination address is basically 192.168.12.16. This destination address is included in this route. It is also included in this route, while it is not included in this route because this route range is from 0 to 15. These IP addresses are included in this route, so .16 is not included. So the RIP is selected because it has the most specific prefix, or we can also say that a longer prefix means a more specific network definition. So since this is more specific, that's why this route is selected. And since this is a broad route, it includes more IP addresses and it is a big network. This is why it is less specific, and this is why this is not selected, while the route with a more specific destination addresses that also includes the destination address is the selected route. Question number 5, what is the primary effect of the spanning tree port fast command? And the options are: option A, it enables BPDU messages. Option B, it minimizes spanning tree convergence time. Option C, it immediately puts the port into forwarding state when the switch is reloaded. And option D, it immediately enables the port in the listening state. And the correct option is option B, it minimizes spanning tree convergence time. So the primary effect of the spanning tree port fast command is to significantly reduce the time it takes for a port to enter the forwarding state, thus minimizing the spanning tree convergence time. Here is a brief explanation of why the other options are incorrect. Option A, it enables BPDU messages. Port fast actually disables BPDU reception on the port, which is essential for its functionality. Option C, it immediately puts the port into forwarding state when the switch is reloaded. This is not entirely accurate. While port fast speeds up the process, it does not guarantee immediate forwarding upon reload. And option D, it immediately enables the port in listening state. Port fast bypasses the listening and learning states altogether, going directly to the forwarding. Question number 6, what is an advantage of Cisco DNA Center versus traditional campus device management? And the options are: option A, it supports numerous extensibility options, including cross-domain adapters and third-party SDKs. Option B, it supports high availability for management functions when operating in cluster mode. Option C, it enables easy auto discovery of network elements on a brownfield deployment. And option D, it is designed primarily to provide network assurance. And the correct option is option A. It supports numerous extensibility options, including cross-domain adapters and third-party SDKs. So Cisco DNA Center is designed with a robust platform that supports extensibility through cross-domain adapters, APIs, and third-party software development kits. This allows for greater flexibility in integrating with various network and IT management systems, enabling more comprehensive and customizable network management solutions. Question number 7. What event has occurred if a router sends a notice level message to a syslog server? And the options are option A TCP connection has been turned down. Option B, an ICMP connection has been built. Option C, an interface line has changed status. And option D, a certificate has expired. And the correct option is option C, an interface status has changed. So in syslog levels, notice is used for normal but significant conditions that require attention. This level is typically used to report events like changes in the status of an interface or other noteworthy but not critical conditions. Here is a quick breakdown of all syslog levels. The debug, detailed information for debugging, informational, regular operational messages, notice level, normal but significant conditions such as interface status changes, warning messages indicating potential issues, errors that require attention, critical conditions requiring immediate attention, alert, conditions that must be fixed immediately, and emergency system is unusable and immediate action is needed. Let's move forward to question number 8. What are two fundamentals of virtualization? Choose two options, and the options are option A. The environment must be configured with one hypervisor that serves solely as a network manager to monitor SNMP traffic. Option B. It allows logical network devices to move traffic between virtual machines and the rest of the physical network. Option C, it allows multiple operating systems and applications to run independently on one physical server. Option D, it allows physical router to directly connect NICs from each virtual machine into the network. And option E, it requires that some servers, virtual machines, and network gear reside on the internet. And the correct two options are option B, it allows logical network devices to move traffic between virtual machines and the rest of the physical network. And the second correct option is option C, it allows multiple operating systems and applications to run independently on one physical server. So these are the two fundamental properties of virtualization. And the explanation of both these properties is that in virtualization, virtual switches and logical network devices handle traffic between virtual machines and the physical network. This allows VMs to communicate with each other and with the outside network through virtualized network interfaces. Multiple operating systems on one physical server. Virtualization enables multiple VMs, each with its own operating system, to run concurrently on a single physical server. This is a core principle of virtualization, providing resource efficiency and flexibility. So these are the core principle of virtualization. Question number 9. How does Cisco DNA Center gather data from the network? And the options are option A. Network devices use different services like SNMP, syslog, and streaming telemetry to send data to the controller. Option B, devices establish an IPsec tunnel to exchange data with the controller. Option C, devices use the call home protocol to periodically send data to the controller. And option D, the CISCO CU analyzer tool gathers data from each licensed network device and streams it to the controller. And the correct option is option A, network devices use different services like SNMP, syslog, and streaming telemetry to send data to the controller. So this is the correct answer. Cisco DNA Center gathers data from network devices using a variety of protocol and mechanisms to ensure comprehensive network visibilities. These include SNMP, Simple Network Management Protocol, for collecting device information like hardware, software, and configuration details. Syslog, for capturing system and application messages, including error messages and security events. Streaming telemetry, for real-time data collection, enabling faster troubleshooting and performance monitoring. Let's move forward to question number 10. Refer to the exhibit. This is the exhibit. The network administrator wants VLAN 67 traffic to be untagged between switch 1 and switch 2 while all other VLANs are to remain tagged. Which command accomplishes this task? So here we have two switches, switch 1 and switch 2, and we have two PCs, PCA and PCB, and we want that, let's suppose these two ports are trunk, we want that VLAN 67 traffic is untagged between them while rest of the VLAN's traffic is tagged. So what is the command to accomplish this task? And the options are option A, switch port access VLAN 67. Option B, switch port trunk allowed VLAN 67. Option C, switch port private VLAN association host 67. And option D, switch port trunk native VLAN 67. And the correct option and the correct command is switch port trunk native VLAN 67. So this command sets VLAN 67 as the native VLAN on the trunk link, ensuring that traffic for VLAN 67 is sent untagged across the trunk, while traffic for all other VLANs remains tagged. Question number 11. What are two roles of the dynamic host configuration protocol DHCP? Choose two options, and the options are option A. The DHCP server offers the ability to exclude specific IP addresses from a pool of IP addresses. Option B. The DHCP client can request up to 4 DNS server addresses. Option C. The DHCP server assigns IP addresses without requiring the client to renew them. Option D. The DHCP server leases client IP address dynamically. And option E. The DHCP client maintains a pool of IP addresses it can assign. And the correct options are option A, the DHCP servers offers the ability to exclude specific IP addresses from a pool of IP addresses, and the DHCP server leases client IP addresses dynamically. So these are the two correct options and roles of the DHCP server. Question number 12. Which two minimum parameters must be configured on an active interface to enable OSPF version 2 to operate? Choose two options, and the options are option A, OSPF area, option B, OSPF MD5 authentication key, option C, IP version 6 address, option D, OSPF process ID, and option E, OSPF stub flag. And the correct options are OSPF area and OSPF process ID. So these two parameters are essential for OSPF v2 to function correctly, as they define the area in which the OSPF process will operate and the specific OSPF instance process running on the router. Question number 13. Which purpose does a northbound API serve in a controller-based networking architecture? The options are: option A, communicates between the controller and physical network hardware. Option B, reports device errors to a controller. Option C, generates statistics for network hardware and traffic. And option D, facilitates communication between the controller and the application. So we already answered a similar question in this session, and the correct option is that the northbound API is used to facilitate communication between the controller and the application, while the southbound API is used to facilitate communication between the controller and the edge devices or the network switches. And again, this is visible by this diagram. So the northbound API facilitates communication between virtual services or applications, while the southbound API facilitate communication between the controller and the network switches or the edge devices. Question number 14, refer to the exhibit. If the network environment is operating normally, which type of device must be connected to the interface fast Ethernet 01? And this is the exhibit. So we have IP ARP inspection VLAN 2 to 10, interface fast Ethernet 01, IP ARP inspection trust. And the options are: option A, DHCP client, option B, access point, option C, router, and option D, PC. And the correct option is option C, router. And why is that? It is because the configuration shown in the exhibit enables dynamic ARP inspection on VLAN 2 to 10 and makes interface fast Ethernet 01 as trusted. In a normal operating network environment, a trusted interface typically connects to devices that need to forward large amount of ARP traffic without inspection, such as switches, router, or other network infrastructure devices that are not likely to send malicious ARP messages. Based on this, the correct answer is router. A router connected to fast Ethernet 01 would be trusted to send ARP traffic without being inspected, as routers are considered reliable devices in terms of ARP traffic. Question number 15. What is the primary purpose of first hop redundancy protocol? And the options are: option A, it allows directly connected neighbors to share configuration information. Option B, it allows a router to use bridge priorities to create multiple loop-free paths to a single destination. Option C, it reduces routing failures by allowing layer 3 load balancing between OSPF neighbors that have the same link metric. And option D, it reduces routine failures by allowing more than one router to represent itself as the default gateway. And this is the correct option, that the first hop redundancy protocol reduces routing failures by allowing more than one router to represent itself as the default gateway of a network. Question number 16. In which two ways does a password manager reduces the chance of a hacker stealing a user password? Choose two options. And the options are: option A, it automatically provides a second authentication factor that is unknown to the original user. Option B, it uses an internal firewall to protect the password repository from unauthorized access. Option C, it protects against keystroke logging on a compromised device or website. Option D, it stores the password repository on the local workstation with built-in antivirus and anti-malware functionality. And option E, it encourages user to create stronger passwords. And the correct options are that it protects against keystroke logging on a compromised device or a website, since the user don't have to manually enter the password. Therefore, the keystroke logging hacking is prevented. And the second correct option is that it encourages user to create strong passwords, since the user has no longer to remember or memorize the password. That's why the user can create stronger passwords. Let's move forward to the next question. Question number 17. Which technology is used to improve web traffic performance by proxy caching? And the options are option A, WSA, option B, firepower, option C, ASA, and option D, FireSite. And the correct option is option A, WSA. So what is WSA? The WSA, or Web Security Appliance, is specifically designed to improve web traffic performance through proxy caching. It stores frequently accessed web content locally, reducing latency and bandwidth usage. Firepower, ASA, and FireSite are primarily focused on security functions like firewalling, intrusion prevention, and threat detection rather than performance optimization through caching. So WSA Web Security Appliance is the correct answer, and this is how the WSA, or the Cisco WSA, is deployed. So it is the user when accesses web content from the internet. So the most frequently accessed web content are stored here in the WSA, and the next time when the user accesses the same content, it is accessible or retrieved through WSA, which reduces the latency as well as the bandwidth consumption. Question number 18. Which type of attack can be mitigated by dynamic ARP inspections? And the options are option A, worm, option B, malware, option C, DDoS, and option D, man in the middle. And the correct option is option D, man in the middle attack. The man in the middle attack rely on ARP poisoning, whereas an attacker sends false ARP messages to manipulate network traffic. Dynamic ARP inspection inspects ARP packets and verifies their authenticity, preventing these forged messages. Question number 19. What are two roles of domain name services? That is DNS. Choose two options, and the options are option A, builds a flat structure of DNS names for more efficient IP operations. Option B, encrypts network traffic as it travels across a WAN by default. Option C, improves security by protecting IP addresses under fully qualified domain names. Option D, enables application to identify resources by name instead of IP addresses. And option E, allows a single host name to be shared across more than one IP addresses. And the correct options are option D, it enables application to identify resources by name instead of IP addresses. And it allows a single host name to be shared across more than one IP addresses. So DNS basically translates human readable domain names into machine readable IP addresses, making it easier for users to access websites and other online resources. DNS supports load balancing and fault tolerance by allowing multiple IP addresses to be associated with a single host name. Let's move to the next question. Question number 20. What mechanism carries multicast traffic between remote sites and supports encryption? And the options are option A, ISATAP, option B, GRE or IPsec, option C, IPsec or ISATAP, and option D, GRE. And the correct option is option B, GRE or IPsec. Explanation. So GRE, generic routing protocol, is a tunneling protocol that can encapsulate various network layers protocol including multicast. IPsec provides encryption, authentication, and integrity for IP packets. By combining GRE and IPsec, we can securely transport multicast traffic between remote sites. Let's move to question number 21. Refer to the exhibit. What mechanism carries multicast traffic between remote sites and supports encryption? I think this question is misrepresented. This question is basically from the previous question, and the question, so this is the same question. It is again repeated. This question is basically repeated in question number 21. Anyway, let's refer to this exhibit, and the source and destination address remains the same. So the question was basically, it's not written here, but the question was, when a PCA sends traffic to PCB on the same VLAN, this is the same VLAN 200. So what does the switch does with the traffic? And the correct option is that the source and destination MAC address remains the same. Since we are in the same VLAN, so the MAC address of both PCA and PCA remain the same. And the explanation for this is, in this scenario, both PCA and PCB are on the same VLAN 200. When PCA sends a frame to PCB, the switch will act as a transparent bridge. This means it will forward the frame directly to PCB without modifying the source or destination MAC addresses. The MAC addresses are used to identify devices on the same network segment, and in this case, both PCs are on the same VLAN segment. Question number 22. How will link aggregation be implemented on a Cisco wireless LAN controller? And the options are option A, one functional physical port is needed to pass client traffic. Option B, the Ethernet channel must be configured in mode active. Option C, when enabled, the WLC bandwidth drops to 500 Mbps. And option D, to pass client traffic, two or more ports must be configured. And the correct option is option A, one functional physical port is needed to pass client traffic. And this is explanation. Sorry, this is again the incorrect explanation. So we will only go with the correct answer since we don't have explanation for this question. Again, we have question number 23, and we have an exhibit. Refer to this exhibit. Which switch in this configuration will be elected as the root bridge? So we have 4 switches: switch 1, switch 2, switch 3, switch 4, and we have MAC addresses of all the 4 switches. So which switch will be selected as the root bridge considering these MAC addresses? So the criteria is that for selection of the root bridge, we consider 2 things. First is the priority, and second is the MAC address. So the lower the priority, the more chances are of the switch to be selected as the root bridge. If the priority is the same, here since we are not given the priority, it means that all the switches have the default priority than the decision for the root bridge is selected based on the lower or the lowest MAC address. So in these four MAC addresses, switch 3 has the lowest MAC address. And how is that? So this is explained here. To determine the root bridge, we need to compare the bridge IDs of each switch. The bridge ID is composed of the, let me clear this clutter. So the bridge ID is composed of the priority set by the administrator and the MAC address of the switch. The switch with the lowest BID or bridge ID becomes the root bridge. Since we don't have information about the priority configured on each switch, we will assume the default priority of 32768. So this is the default priority of the switches. In this case, the root bridge will be the switch with the lowest MAC address. Comparing the MAC addresses, we can see that switch 3 has the lowest MAC address, and this is the MAC address of switch 3. So how this is the lowest MAC address? First we will compare the first octet. All switches have the same first octet, that is 0C. So these numbers are hexadecimal. The second octet, so switch 1, switch 4 has the second octet of E0, which is equal to 224 in decimal. Switch 2 and switch 3 has the MAC address of 0E, which is a value of 14. So the switch 2 and switch 3 has lower MAC address. So the switch 1 and switch 4 will be discarded, and now we have competition between switch 2 and switch 3. So we will again compare the third octet of switch 2 and switch 3, and we have same octet of 15. Here we can see that switch 2 and switch 3 both have the same 15. Fourth octet, switch 2 has 22 and switch 3 has 1A. So 22 is equal to 34 and 1A is basically equal to 26 in hexadecimal. Since 26 is less than 34, therefore switch 3 has a lower fourth octet, and overall, since switch 3 has a lower value in the fourth octet compared to switch 2, it has the overall lowest MAC address among the all switches, and that's why switch 3 is the root bridge. Question number 4 is that which device performs stateful inspection of traffic, and the options are option A firewall, option B switch, option C access point, and option D wireless controller. And the correct option is option A firewall. Stateful inspection involves examining network traffic based on the context of previous packets, such as source and destination IP addresses, port numbers, and protocol information. This allows the firewall to make intelligent decisions about which packet to allow or block, enhancing the security. Let's move to question number 25. Which configuration ensures that switch is always the root for VLAN 750? And the commands are option A, spanning tree VLAN 70 priority 38003685. Option B, spanning tree VLAN 750 root primary. Option C, spanning tree VLAN 750 priority 61440. And option D, spanning tree VLAN 750 priority 0. And the correct option is option D, spanning tree VLAN 750 priority 0. And here is the explanation. So spanning tree elects a root bridge for each VLAN to prevent loops. The switch with the lowest bridge ID becomes the root bridge. Bridge ID is composed of priority and MAC address. The minimum priority value is 0. So the lowest priority that you can set is 0. By setting the priority for VLAN 750 to 0, you ensure that this switch will have the lowest BID possible, making it the root bridge for VLAN 750. Question number 26. Refer the exhibit. Which switch becomes the root bridge? So here we have 4 switches, switch 1, switch 2, switch 3 and switch 4. And the question is asking about that which switch will become the root bridge, and against each switch we have been given the switch or the bridge priority and its MAC address. So for the switch to become root bridge, it must has the lowest bridge ID, and the bridge ID, this is the bridge ID consists of first the priority and then the MAC address. So the lower priority and lower MAC address is the criteria for the selection as the root bridge. So in this case, we have the bridge priority of 32,768, 32,768 and 30,000. So automatically these two will be discarded because their priority are higher, while these two have the same priority. So here we have a tie, and when the priorities are same, then we decide the decision of the root bridge based on the lower MAC address. So the switch 3 has the MAC address of CCC. We have all the C, while the switch 2 has the MAC address of BB. So the BB is lower than the CC. That's why our root bridge will be S2. So the correct option is switch 2. Question number 27. Which two WAN architecture options help a business scalability and reliability for the network? Choose two options, and the options are option A, asynchronous routing, option B, single homed branches, option C, dual homed branches, option D, static routing, and option E, dynamic routing. And the correct options are option C, dual homed branches, and option E, dynamic routing. So why are these two correct options? The dual home branches, this option involves connecting branches to the WAN through two independent connections. This setup provides redundancy, ensuring that if one connection fails, the other can take over, thereby enhancing both reliability and scalability. While the dynamic routing protocols such as OSPF or BGP automatically adjust the routes based on current network conditions, this adaptability improves scalability by efficiently managing traffic loads and paths, and thus enhances reliability by quickly rerouting traffic in case of a link failure. Question number 28. What criteria is used first during root port selection process? And the options are option A, local port ID, option B, lowest path cost to the root bridge, option C, lowest neighbors bridge ID, and option D, lowest neighbors port ID. And the correct option is option B, lowest path cost to the root bridge. So the primary selection used during the root port selection process in spanning tree protocol is lowest path cost to the root bridge. The root port is the port with the lowest path cost to the root bridge. If multiple paths have the same cost, additional tiebreakers such as the lowest bridge ID of the neighbor and the lowest port ID of the neighbor are used in subsequent steps. Question number 29. Which type of information resides on a DHCP server? And the options are option A, a list of the available IP addresses in a pool. Option B, a list of public IP addresses and their corresponding names. Option C, usernames and passwords for the end users in a domain. And option D, a list of statically assigned MAC addresses. And the correct option is option A. The DHCP server contains a list of available IP addresses in a pool. So a DHCP server maintains a pool of IP addresses and leases them to the clients dynamically as they connect to the network. It also keeps track of which addresses are currently leased out and which are available. Let's move forward to question number 30. A manager asks a network engineer to advise which cloud service models are used so employees do not have to waste their time installing, managing, and updating software which is only used occasionally. Which cloud service model does the engineer recommend? And the options are: option A, infrastructure as a service; option B, platform as a service; option C, business process as service to support different types of service; and option D, software as a service. And the correct option is option D, software as a service. So software as a service is the ideal cloud service model for the manager's requirement. So the SaaS or the software as a service provides application directly to end users over the internet. User don't need to install, manage or update software on their devices. It's ideal for software used occasionally as there is no upfront investment or ongoing maintenance. Example of SaaS applications include email, such as Microsoft Email 365, CRM software, and Office productivity suites. So this is Office productivity suite, the Microsoft Office 365, while the email can be any SaaS provided email solution. By recommending SaaS, the network engineer helps the manager save time and resources while providing employees with easy access to the necessary software. Question number 31. A port security violation has occurred on a switch port due to the maximum MAC address count being exceeded. Which command must be configured to increment the security violation count and forward an SNMP trap? And the options are: option A, switch port security violation access; option B, switch port security violation protect; option C, switch port security violation restrict; and option D, switch port security violation shutdown. And the correct option is option C, switch port security violation restrict. So what does this command do? Let me a little bit explain it further. So let's suppose here we have a switch and we have ports on this switch, and let's suppose you have implemented security on the switch that only one MAC address can be learned against this port on all these ports. So let's suppose if a user, let's suppose, installs a hub and connect multiple devices over here. Let's suppose this is device 1, this is device 2. So since we have configured the security mechanism that only one MAC address can be learned, so anytime a new device is connected, the security violation count will be incremented, and this command is used to do this security violation increment. An SNMP trap will be sent to the central management service each time a new device is connected, and the count will be incremented. Question number 32. Which CRUD or CRUD operation modifies an existing table or view? So this table, we are talking about the database table or DB table, and these CRUD are basically DB operations. So which CRUD operation modifies an existing table or view? And the options are: read operation, option B, create operation, option C, replace, and option D, update. And the correct option is, option D, update. So the update is the CRUD operation responsible for modifying existing data within a table or view. It allows you to change specific values or attributes of records without deleting and recreating them entirely. The other operations represent different operations. The other options represent different operations. The other options include create, creates a new table or view. The read operation retrieves data from an existing table or view. And the replace typically refers to replacing an entire source, not modifying specific parts. Let's move forward to question number 33. An engineer must configure inter-switch VLAN communication between a CISCO switch and a third-party switch. Which action should be taken? And the options are option A, configure IEEE 802.1p. Option B, configure IEEE 802.1q. Option C, configure ISL. And option D, configure DSCP. And the correct option is option B, configure IEEE 802.1q. So the IEEE 802.1q is the standard protocol for VLAN tagging. It allows multiple VLANs to coexist on a single physical link, which is essential for inter-switch VLAN communication. By configuring VLAN tagging on both this CISCO switch and the third-party switch, you can ensure that VLAN information is carried across the link, enabling communication between VLANs or different switches. So let me explain it further. So let's suppose here we have two switches. This is a CISCO switch, and we have another switch. Let's suppose a third party. Let's suppose a Juniper switch. So here we have, let's suppose, VLAN 110 and another VLAN 220. Similarly, we also have two VLAN over here, 110 and VLAN 220, and we have different devices connected to these VLANs. Let's suppose this device is connected to 220 VLAN and this is connected to 110. Similarly, on this switch again we have devices connected to different VLANs. This is 220. So how to route or communicate between these devices on these different switches? So we must have a physical link between them, and we will tag the VLAN on this link. We will configure this link as a trunk, and we will tag the VLAN 110 and 220 on both sides. We will tag the VLAN over here on this switch as well as over there, and this will enable the inter-VLAN communication between devices on different on switches of different vendor, or even on switches of the same vendor. And the IEEE 802.1q is the VLAN tagging protocol. Question number 34. What is a function of a remote access VPN? And the options are option A, used cryptographic tunneling to protect the privacy of data for multiple users simultaneously. Option B, used exclusively when a user is connected to a company's internal network. Option C, establishes a secure tunnel between two branch sites. And option D, allows the users to access company internal network resources through a secure tunnel. And the correct option is option D. The remote access VPN allows the user to access company internal network resources through a secure tunnel. So remote access VPNs enable individual users to connect to a company's internal network securely over the internet, ensuring that data is encrypted and protected while accessing network resources from remote location. Let's suppose this is a company headquarters. Sorry for my drawing. Let's suppose this is a building, and here we have, let's suppose, a remote user with a laptop. So how will this user connect? And this is the internet. He is in some other country or in another city and he want to connect to headquarter resources over the internet. So he will use a remote access VPN, and this will create a type of secure tunnel between his laptop and his remote headquarters. Question number 35. What is a DHCP client? And the options are: option A, a workstation that requests a domain name associated with its IP address. Option B, a host that is configured to request an IP address automatically. Option C, a server that dynamically assigns IP addresses to hosts. And option D, a router that statically assigns IP addresses to hosts. And the correct option is option B, a host that is configured to request an IP address automatically. So a DHCP client is a device or host on a network that requests an IP address and other configuration information from a DHCP server automatically, rather than having a static IP address assigned manually. Let's move forward to question number 36. And the question is, what is a practice that protects a network from VLAN hopping attacks? And the options are: option A, enable dynamic ARP inspection. Option B, configure an ACL access control list to prevent traffic from changing VLANs. Option C, change native VLAN to an unused VLAN ID. And option D, implement port security on internet-facing VLANs. And the correct option is option C, change native VLAN to an unused VLAN ID. So why is that the correct option? It is because changing the native VLAN to an unused VLAN ID can prevent VLAN hopping attacks, which often exploits the default VLAN configuration. By using an unused VLAN for the native VLAN, you reduce the risk of such attacks exploiting the VLAN trunks. Question number 37. Refer the exhibit. This is the exhibit. If OSPF is running on this network, how does router 2 handle traffic from site B? This is site B to 10.10.13.128/25 at site A. So here we have a network at site A, that is this 10.10.13.128/25, and we have OSPF running over here. This stands for OSPF. So this OSPF has basically learned two routes. Basically one route, and we have where two next hop where two redundant links, and the route learned is 10.10.13.0/25. So this is not the same route as this one. Other are the directly connected links. So what would be the correct option when we have this routing table? And here another hint is that gateway of last resort is not set. And this is the routing table, or these are the routes that are available on this router 2. So the options are: option A, it loads balances traffic out of FA01 and FA02. Option B, it is unreachable and discards the traffic. Option C, it sends packets out of the interface FA02. And option D, it sends traffic out of the interface FA01. So these interfaces, one is FA01, one is FA02. And the correct option is option B, it is unreachable and discards the traffic. And why is that? Because we have no route available for this network. This route is available, but this route does not include this particular network or subnet. And the other option is that we also don't have the gateway of the last resort. That's why it is unreachable, and the traffic for this network is discarded. If the gateway of the last resort was set as this one, such as that 10.10.10.9 or 10.10.10.13, that we would have been able to reach this particular network because the traffic would have been sent through the gateway of the last resort. But since we haven't set the gateway of the last resort, the traffic would be discarded. I hope this is understandable. If there is any question regarding any comment or any question regarding any question in this video, you can comment and I will be happy to reply and remove your confusion. Question number 38. What is the purpose of traffic shaping? And the options are option A, to mitigate delay over slow links. Option B, to provide fair queuing for buffered flows. Option C, to limit the bandwidth that a flow can use. And option D, be a marking mechanism that identifies different flows. And the correct option is the purpose of traffic shaping is to limit the bandwidth that a flow can use. So traffic shaping is used to limit the bandwidth of a flow. And how is that done? The traffic shaping controls the amount of data transmitted into a network over a specified period, smoothing out bursts of traffic and ensuring that the flow adheres to a defined rate. This helps in managing congestion and ensuring that no single flow monopolizes the available bandwidth. Question number 39. Where does the configuration reside when a helper address is configured to support DHCP? And the options are option A, on the router closest to the server. Option B, on the router closest to the client. Option C, on every router along the path. And option D, on the switch trunk interface. And the correct option is on the router closest to the client. So a helper address is configured on the router closest to the DHCP client to forward DHCP broadcast traffic to the DHCP server. This is because DHCP clients typically broadcast their requests, and the router nearest to the client will receive these broadcasts. By configuring a helper address, the router knows where to forward these requests to reach the DHCP server. Question number 40. What facilitates a telnet connection between devices by entering the device name? So typically when we use telnet, we enter the IP address. So if instead of IP address, let's suppose this is the IP address of a server, we use the server, let's suppose the server name such as, let's suppose host 1. So what facilitates the entering of the host name instead of IP address? And the options are option A, SNMP, option B, DNS lookup, option C, syslog, and option D, NTP. And the correct option is option B, DNS lookup. So DNS, domain name system lookup, resolve device names to IP addresses, allowing users to initiate a telnet connection by using the device name instead of its IP addresses. So if you use host name, you will need the DNS lookup to resolve this host name to the IP address, because the devices eventually understand and communicate over the IP addresses. Question number 41. When implementing a router as a DHCP server, which two features must be configured? And we have to choose two options, and the options are option A, relay agent information, option B, database agent, option C, address pool, option D, smart relay, and option E, manual bindings. And the correct options are option C, address pool, and option E, manual bindings. So the address pool defines the range of IP addresses that the DHCP server can assign to the clients, and manual bindings are used to assign specific IP addresses to specific devices based on their MAC addresses, ensuring that particular devices always receive the same IP addresses. Question number 42. How do servers connect to the network in a virtual environment? And the options are option A, wireless to an access point that is physically connected to the network. Option B, a cable connected to a physical switch on the network. Option C, a virtual switch that links to an access point that is physically connected to the network. And option D, a software switch on a hypervisor that is physically connected to the network. And the correct option is option D, a software switch on a hypervisor that is physically connected to the network. So in a virtual environment, servers or virtual machines connect to the network through a virtual switch managed by the hypervisor. This virtual switch is linked to the physical network through the hypervisor, which is connected to the physical switch or other network infrastructure. And this is a diagram of this virtualized environment. So let's suppose here we have a host, and on this host we have the virtual switch made possible by the hypervisor, and this virtual switch is connected to the physical NIC, and the VMs are basically connected to this virtual switch, and the physical NIC of the server is then connected to the physical switches. These are the physical switches of the underlying network or underlying network. And again, on the other hand, again we have a physical host, physical NIC, and physical NIC is connected to the virtual switch through hypervisor, and the VM on the physical host are basically connected to the virtual switch through virtual NICs. Here we have virtual NICs. Question number 43, refer the exhibit. Which switch becomes the root of the spanning tree for the VLAN 110? So here we have 4 switches, switch 1, switch 2, switch 3, switch 4, and we are given the MAC addresses of all these switches for the same VLAN 110. So which switch will become the root switch? And again, remember the criteria for the root switch, for the switch to become a root is first priority, and if the priority is same, then the second is MAC address. The lower the priority and the lower MAC address of a switch qualify it for becoming the root switch. So here we have the priorities. These are the priorities. So the lowest priority is basically this one, 2, 4, 5, 6, 5, 8, 6. All others have greater priorities. That's why the switch 2 will qualify to become the root switch or root bridge. If 2 switches have the same priority, then we will go to the next criteria, that is the MAC address, and the lower MAC address of the switch will decide will make the decision of for a switch to become the root switch or root bridge. Again, this is the same thing explained over here, that first we look at the bridge priority, and if we have 2 switches or more switches with the same priority, then we use the MAC address as the tie breaker. Question number 44, which device tracks the state of active connections in order to make a decision to forward a packet through? And the options are option A, wireless access point, option B, firewall, option C, wireless LAN controller, and option D, router. And the correct option is option B, firewall. So a firewall tracks the state of active connections using a feature called stateful inspection or stateful packet inspection. This allows the firewall to make decisions about whether to forward or block packets based on the state of the connection. For example, whether the connection is new, established, or related to an existing connection. Question number 45. How does a switch process a frame received on port FA01 with the destination MAC address? This when the table is missing the address. And the options are: option A, it drops the frame immediately. Option B, it forwards the frame back out of the interface FA01. Option C, it floods the frame to all interfaces except FA01. And option D, it holds the frame until the MAC address timer expires and then drops the frame. And the correct option is option C, it floods the frame to all interfaces except the FA01. So we have studied this concept, the learning of the MAC address again and again. So when the MAC address is non-known to the switch, it is flooded over all the ports except on the port on which it was received to learn the MAC address, and this is done through the ARP or address resolution protocol. You can study this explanation if you like by pausing the video. So question number 1 is refer to the exhibit. This is the exhibit. PC1 is trying to ping PC3 for the first time. So the keyword here is for the first time and sends out an ARP to S1. Which action is taken by S1? So S1 here is switch 1. And the options are: option A, it forwards it out G03 only. Option B, it is flooded out every port except G00. Option C, it drops the frame. And option D, it forwards it out interface G02 only. So the question is talking about that PC1 is trying to ping PC3, but for the first time. For the first time means that switch has no MAC address information of PC3. So what will be done in this case? And the correct option is that the packet is flooded out every port except G00. It means that when S1 packet received from the port G00, it will be flooded over this port as well as this port, and if there is some client or switch connected to this port, so it will be flooded to this port as well. So this is the packet is not for PC2, so it will be dropped by PC2. S2 will receive the packet. Again, the S2 will flood the packet out this port as well as this port, while it will not flood the packet over the port on which it is received. So seeing the IP address, the PC3 will reply with its own MAC address, and so it will be received by S1, and S1 will send the MAC address to PC1, and in this way PC1 will learn the MAC address of PC3, and the next time the ping will be the ping packet will contain the destination MAC of PC3 and the communication will be successful. So when the MAC address is not known of the destination and only IP address is known, then this MAC address is determined using the ARP. And how this is done, that the packet of the ARP, it contains the source MAC address. Let's suppose it contains the source MAC address of PC1, source MAC, while the destination MAC address, it is all FF. All FF means that it is a broadcast address. That's why the packet is broadcasted out the all ports. And the PC that it also contains the source and destination IP address. So the packet will contain the destination IP address of PC3, and only PC3 will reply with its own MAC address. So this is how the MAC address is known. Let's move forward to question number 2. What is the benefit of VRRP? And the options are: option A, it provides traffic load balancing to destinations that are more than 2 hops from the source. Option B, it provides the default gateway redundancy on a lane using 2 or more routers. Option C, it allows neighbors to share routing table information between each other. And option D, it prevents loops in a layer 2 lane by forwarding all traffic to a root bridge, which then makes the final forwarding decision. And the correct option is already underlined. It provides the default gateway redundancy on a lane using 2 or more routers. And how this is done? So the virtual router redundancy protocol allows multiple routers to work together to provide redundancy for a virtual gateway on a lane. If the primary router fails, one of the backup router will take over, ensuring continuous availability of the default gateway for the network host. So this is how the VRRP works. So these are two routers and VRRP is configured between them. So these switches are the routers, they have the default gateway of this virtual IP 150.1.1.245. This router, this also has the, or this switch also has the virtual IP over 150.1.1.254. So this is the master VRRP. It means that it is currently active while this one is in passive mode. And these switches have the default gateway of this 254. So if this router or this switch, the active switch, fails or is shut down, or this connectivity is lost due to any reason, the traffic and sessions are seamlessly shifted to the backup VRRP router, and the client over here, they don't feel any packet loss or any loss of connectivity because the default gateway is the same, only the sessions are shifted to the backup router. So this is how the VRRP works. Question number 3, what is the similarity between OM3 and OM4 fiber optic cable? So these are the different standards of fiber optic cable. What is the similarity between OM3 and OM4? And the options are: option A, both have a 50 micron core diameter. Option B, both have a 9 micron core diameter. Option C, both have a 62.5 micron core diameter. And option D, both have a 100 micron core diameter. And the correct option is, so we are talking about the core diameter of the actual cable, and the correct option is that both OM3 and OM4 has a 50 micron core diameter. So both OM3 and OM4 fiber optic cables are multi-mode fibers with a core diameter of 50 microns. This is one of their key similarities. So the second point to remember is that they are multi-mode fiber, and here is the different standards: OM1, OM2, OM3, OM4, and OM5. These are the colors. You can recognize them by their color. OM1 and OM2 are of orange colors. OM3 and OM4 are usually of the aqua color, and OM5 is of yellow color. So this, the first number, this is basically the diameter of the core, while the second, the 1 to 5, this is the diameter of the cladding, the protective cladding that is outside the main core, such as, let's suppose this, we can say that this is cladding and this is the main fiber, or there may be cladding outside these individual fibers as well as core inside each of these. So the cladding has obviously larger diameter because it covers the main core. Let's move forward to question number 4. A network administrator must enable DHCP services between two sites. What must be configured for the router to pass DHCP discover messages on to the server? And the options are: option A, a DHCP relay agent; option B, DHCP binding; option C, a DHCP pool; and option D, DHCP snooping. And the correct option is a DHCP agent. Question number 5, refer to the exhibit. So this is the exhibit. What is the result of gigabit 1/11, if gigabit 1/11 receives an STP BPDU. So we have some configuration done on this port gigabit 1/11. This is the configuration. It is in access mode. Spanning tree port path is configured and the BPDU guard is enabled. So what will be the result if this port receives the STP BPDU? And the options are: option A, the port transitions to the STP blocking; option B, the port transitions to the root port; option C, the port immediately transitions to STP forwarding; and option D, the port goes into error disable state. And the correct option is that the port goes into error disable state because we have the BPDU guard enabled on the port. So given the configuration of BPDU guard on the port gigabit 1/11, if the port receives a STP and STP BPDU, it will go into an error disable state. That is option D. This is because BPDU guard is designed to prevent accidental loops by shutting down the port when it detects a BPDU on an access port, which is not expected in a properly configured network. Question number 6. Which two protocols are supported on service port interfaces? Choose two options. And the options are: option A, radius; option B, TechX Plus; option C, SCP; option D, Telnet; and option E, SSH. So, which protocol are supported on the service port interfaces of a switch or a router? And the correct options are the Telnet and SSH. So these are the two protocols typically supported on service port interfaces. They are used for remote access and management of network devices. So here we can see that these are the ports for the service connection or remote management. So this is console port. Console port is also for the management, but this management is not done typically remotely. It is done through the directly connecting laptop through this console port. While these service ports enable us to remotely manage the device. You can give an IP address to this port and then you can configure the device over the network using your laptop, your server, or your PC. Let's suppose this is a network. While this is a console port, this is usually connected through serial to USB cable, and directly it is connected directly by directly connecting the laptop through the serial port. So that's the difference between the service port and the console port. Question number 7. What does a switch use to build its MAC address table? And the options are: option A, VTP; option B, DTP; option C, egress traffic; and option D, ingress traffic. The correct option is ingress traffic. So when a switch receives traffic on a port, then it records the source MAC address, because let's suppose this is a switch and this is a, let's suppose, port. Here we have, let's suppose, PC1, and here we have PC2. So if this PC1 wants to connect with PC2 and this switch does not know the MAC address of this PC1, when PC1 try to ping this or send an ARP request, it must have its own source MAC address. So this is ingress traffic from PC1, and seeing the source address of PC1, it will save it inside the MAC address table. So the MAC address table is populated through the ingress traffic. A switch builds its MAC address table by observing the source MAC address of the incoming or ingress frames on its ports. When a frame enters a switch port, the switch records the MAC address of the device that sent the frame and associates it with the port on which the frame was received. This information is then stored in the MAC address table. Question number 8. Which type of security program is violated when a group of employees enters a building using the ID badge of only one person? And the options are: option A, intrusion detection; option B, user awareness; option C, physical access control; and option D, network authorization. And the correct option is physical access control. So physical access control is designed to regulate who can enter and exit a building or specific areas within it. By using one ID badge for multiple people, the integrity of the physical access control system is compromised, allowing unauthorized individuals to enter the building. So this is straightforward. Physical access to the building is the physical access control. Question number 9. Which device controls the forwarding of authentication request for users when connecting to the network using a lightweight access point? And the options are: option A, TechX server; option B, wireless access point; option C, radius server; and option D, wireless LAN controller. And the correct option is option D, wireless LAN controller. So a wireless LAN controller (WLC) manages the forwarding of authentication requests from users connecting to the network via lightweight access points. The wireless LAN controller communicates with the authentication servers such as radius server to authenticate users and enforce network policies. Question number 10. Aside from discarding, which two states does the switch port transition through while using the RSTP 802.1W? Choose two options. And the options are: option A, listening; option B, blocking; option C, forwarding; option D, learning; and option E, speaking. And the correct options are option C, forwarding, and option D, learning. So the 5 STP states, disabled, blocking, listening, learning, and forwarding, are reduced to 3 phases in the RSTP, and these 3 phases are the discarding, learning, and forwarding. The discarding state combines the disabled, blocking, and listening states of the STP. Learning, the port learns MAC address but does not forward frames, and forwarding, the port forwards data frames. So the STP has 5 states while the RSTP has 3 states: discarding, learning, and forwarding. Question number 11. What is the maximum bandwidth of a T1 point-to-point connection? And the options are: option A, 1.544 Mbps; option B, 2.048 Mbps; option C, 34.368 Mbps; and option D, 43.7 Mbps. And the correct option is option A, 1.544 Mbps. So a T1 point-to-point connection provides a maximum bandwidth of 1.544 Mbps. This is a common digital transmission service used in North America for transmitting voice, and the maximum bandwidth of an E1 point-to-point connection is 2.048 Mbps. E1 is the European counterpart of the T1 system and is used primarily outside of the North America. So this T1 and E1 both are very popular WAN connection standards. Question number 12. Refer to the exhibit. A network engineer must configure communication between PCA and the file server. So this is PCA and this is the file server, and they are connected through switch A and switch B. To prevent interruption for any other communication, which command must be configured? And the commands are: option A, switch trunk allowed VLAN 12; option B, switch port trunk allowed VLAN none; option C, switch port trunk allowed VLAN add 13; and option D, switch port trunk allowed VLAN remove 10, 11. And the correct option is switch port trunk allowed VLAN add 13. And why is that? It is because if we look at the switch A, so this is the PCA is connected to port 04, while the switch A and switch B are connected to gigabit port 01. So if we look at the configuration of the switch 4 on which PC3 is connected, it is in VLAN 13. Similarly, on this side, the PC is connected, or the file server is connected to port 3, and the port 3 is again in the VLAN 13. So we must enable or add VLAN 3 to this port, which is configured as trunk. So here on both switches, this port is configured as trunk, and we must add VLAN 13 to this trunk port so that both this PCA and file server can communicate with each other. Let's move forward to question number 13. Which implementation provides the strongest encryption combination for the wireless environment? And the options are option A, WPA2 plus AES, option B, WPA plus AES, option C, WEP, and option D, WPA plus TKIP. And the correct option is WPA2 plus AES. So this is the oldest standard, and it's vulnerable and weak. WPA came after WEP. It is stronger than WEP, but still it has vulnerabilities and weaknesses, and WPA2 is the strongest of all these. And again, the AES is the strongest encryption algorithm. So why this is why this pair is the correct option. So this combination offers the strongest encryption for a wireless environment because WPA2 is the most secure wireless security protocol currently available, although WPA3 is also now available. While the AES Advanced Encryption Standard is a robust encryption algorithm that provides strong data protection. Together, WPA2 and AES offers a high level of security for wireless networks. Question number 14. Which resource is able to be shared among virtual machines deployed on the same physical server? And the options are option A, disk, option B, application, option C, VM configuration file, and option D, operating system. And the correct option is that the storage or the disk can be shared among the virtual machines. This is the explanation. You can pause the video and read the explanation if you want. I will move forward to question number 15. When DHCP is configured on a router, which command must be entered to the default gate so the default gateway is automatically distributed? And the options are A, default router, B, default gateway, C, IP helper address, and D, DNS server. The correct option is that you should configure default router on the switch when configuring DHCP so that the switch is configured as the default gateway on the clients. So when configuring DHCP on a router, the default router command is used to specify the default gateway that should be distributed to the DHCP clients. This command sets the IP address of the default gateway that the clients will use to reach other networks. Question number 16. What is the purpose of a southbound API in a control-based networking architecture? And the options are option A, facilitates communication between the controller and the applications. Option B, facilitates communication between the controller and the networking hardware. Option C, allows application developers to interact with the network. And option D, integrates a controller with other automation and orchestration tools. And the correct option is that the southbound API facilitates communication between the controller and the networking hardware. So this is the southbound API in this direction, and this facilitate the communication between the controller and the networking hardware such as network switches. Question number 17. Which technology is appropriate for communication between an SDN controller and applications running over the network? And the options are option A, OpenFlow, option B REST API, option C netconf, and option D southbound API. And the correct option is option B REST API. And this is the explanation of this particular question and the correct option. You can pause the video and read the explanation if you like. We'll move forward to question number 18. What is the benefit of using FHRP? And the options are option A reduced management overhead on network routers, option B balancing traffic across multiple gateways in proportion to their loads, option C higher degree of availability, and option D reduced R traffic on the network. And the correct option is option C higher degree of availability. So FHRP, that is first hop redundancy protocol, provides a higher degree of availability by allowing multiple routers to act as a single default gateway, ensuring network availability even if one router fails. So again, this is exactly same concept like the VRRP that we already studied. So how does this work? Again, these two are, let's suppose, connected and they are configured through FHRP. So again, they have this virtual IP or this virtual gateway, and these clients, they will have the virtual gateway of this 1.100, that is 1.100. The switches or routers also have their physical addresses. So in any time one router is active, so let's suppose this is the active router R1 and this is the standby router. So it gives the high availability such that if that one router fails or if this link fails, then the traffic will be routed through this link and the clients won't face any disconnectivity or unavailability of the services. So that's how the FHRP works. Question number 19, refer to the exhibit. This is the exhibit. How must router A be configured so that it only sends Cisco discovery protocol information to router C? So the question is talking about that how the router A should be configured so that it sends only the Cisco discovery protocol information to router C via this link, not to the router B. And these are the 4 configuration options. So which option is correct? This is, let's suppose, A, this is B, this is C, and this is D. And the correct option is option D. And why is that? It is because we have enabled so the no CDP run means that overall on the router it is not globally enabled. Then it is only enabled on this gigabit 001 that is connected with router C. So that's why the router A will send the CDP or the discovery protocol information to router C only because we have enabled it on this interface only. We have not enabled it on this or globally on the router. And again, this is the explanation of the Cisco discovery protocol. You can pause the video and read the explanation if you want. Question number 20, what uses HTTP messages to transfer data to applications residing on different hosts? And the options are A, OpenFlow, B, OpenStack, C, OpFlex, and D, REST. And the correct option is option D, REST. So the REST uses HTTP messages to transfer data between applications residing on different hosts. It is a common architecture style for designing network applications where resources are identified by URLs and operations are performed using standard HTTP methods like get, post, put, and delete. Question number 21. What are 2 characteristics of the distribution layer in a 3-tier network architecture? Choose 2 options and the options are option A serves as the network aggregation point, Option B, provides a boundary between layer 2 and layer 3 communications. Option C, designed to meet continuous redundant uptime requirements. Option D is the backbone for the network topology. And option E, physical connection point for lane printer. And the correct options are that the distribution layer in 3-tier architecture provides boundary between layer 2 and layer 3 network communication, and it is designed to meet continuous redundant uptime requirements. So this is the explanation of these two correct options. You can read the explanation. So this is the distribution layer. So first, the first correct option that it provides the boundary between layer 2 and layer 3. So this is basically layer 2, and above here it is layer 3. So this is the distribution layer, basically provides a boundary between this layer 2 and layer 3. And it is also designed to meet the high availability requirements. How? So these access layer switches, they are connected to two or the distribution layer switches. So if this one switch fails, the client communication will still be uninterrupted because this switch is also connected to this one. Okay, so that's why they provides the high availability in case of switches failure. Question number 22. Which access layer threat mitigation technique provides security based on identity? And the options are option A, dynamic ARP inspection. Option B, using a non-default native VLAN. Option C, 802.1x, and option D, DHCP snooping. And the correct option is option C, 802.1x. So what is 802.1x? 802.1x provides security based on identity by requiring users to authenticate before gaining access to the network. So this is also known as the NAC, network access control. This authentication can be through various methods like passwords, certificates, or smart cards. Here is a brief overview of other options. So dynamic ARP inspection protects against ARP spoofing attacks but does not provide identity-based security. Using a non-default native VLAN helps prevent VLAN hopping but does not focus on user identity. And DHCP snooping prevents unauthorized DHCP servers but does not involve user authentication. And this diagram shows that how 802.1x works. So this is, let's suppose, a client. This is called a supplicant. The switch that relays the client information to the authentication server is known as authenticator, and we have the authentication server. So let's suppose this client wants to access the internet or local LAN. So first of all, the client goes to the authenticator. The authenticator then consults the authentication server that whether to allow this client or not based on the certificate, password, or other methods. And if the client successfully authenticates to the authentication server using certificate or any other methods, then it is allowed to access the resources or the network. Question number 23. When a site-to-site VPN is configured, which IPsec modes provide encapsulation and encryption of the entire original IP packet? This is IP. So options are option A, IPsec tunnel mode with AH authentication header. B, IPsec transport mode with AH. Option C, IPsec tunnel mode with ESP encapsulation security payload. And option D, IPsec transport mode with ESP. And the correct option is option C, IPsec tunnel mode with ESP. So the tunnel mode basically encapsulates the entire original packet within a new IP packet, providing protection for the entire packet, while the ESP encapsulation security payload provides both encryption and authentication for the encapsulated data. The AH, it only provides authentication, it does not provide encryption. So this combination ensures that the entire original IP packet, including its header, is encrypted and protected when sent over VPN channel. Question number 24. What does physical access control regulate? And the options are option A, access to specific networks based on business function. So this is specific. Sorry for the misspelling. Option B, access to servers to prevent malicious activity. Option C, access to computer networks and file systems. And option D, access to networking equipment and facilities. And the correct option is that the physical access control basically regulate access to network equipment and facilities such as the server rooms, the data center physical building, etc. So these all comes in the physical access control, the building rooms, network closets, server rooms, and other physical assets. Question number 25. On workstations running Microsoft Windows, which protocol provides the default gateway for the device? And the options are option A, DHCP, option B, STP, option C, SNMP, and option D, DNS. And the correct option is option A, DHCP. So besides providing the IP address, the DHCP protocols also provides the default gateway to the device. It can also provide the DNS server as well. Question number 26. What is the role of a firewall in an enterprise network? And the options are option A, forwards packets based on stateless packet inspection. Option B, processes unauthorized packets and allows passage to less secure segments of the network. Option C, determines which packets are allowed to cross from unsecured to secured networks. And option D, explicitly denies all packets from entering an administrative domain. And the correct option is, we are talking about the role of firewall in an enterprise network. So the firewall determines which packets are allowed to cross from unsecured network to the secured network. And so the firewall basically acts as a gatekeeper for network traffic, controlling the flow of data between secure and untrusted networks. It examines incoming and outgoing packets and decides whether to allow or block them based on the predefined rules. So here, let's suppose we have this firewall, and let's suppose this is our LAN, this is our trusted network, and this is, let's suppose, our untrust network. So you can configure firewall to allow traffic from trust to untrust and block traffic from untrust to trust. So this is a very typical definition of the firewall. The firewall can also be used to control traffic within your own trust network. So let's suppose this is your HR department, and the HR department has its own application, HR application, let's suppose, and this is your security team. Let's suppose this is your SOC or NOC team. So you can also control traffic. You can say that the HR communication from HR to the SOC application should be blocked. So the typical definition is from untrust to trust, but firewall can be used to control and block traffic within the same environment and same organization and within the so-called trust network. Question number 27. A network analyst is tasked with configuring the date and time on a router using executive mode. The date must be set to 12 a.m. Which command should be used? And the options are A, clock time zone, option B, clock summertime recurring, option C, clock summertime date, and option D, clock set. And the correct option is Option D, clock set. So the clock set commands allows you to manually set the date and time on the router. For example, to set the time to 12 a.m., you would use the command clock set 0000 August 12, 2024. So it will be such that you will write the time, then the month, the date, and then the year. So this is the format. So here it is talking about how to set the time set manually. The other method is through automatically using the NTP, Network Time Protocol Server. So you configure the NTP servers on your router, and then the router automatically updates its time from the NTP server using the protocol NTP. Let's suppose this is your router. Question number 28. Why was the RFC 191 address space defined? So this is the private IP address space such as 192.168/16 10.0/8 and 172.16/12. RFC 191 is talking about this address space. So why was this defined? And the options are: option A, to conserve public IP address IPv4 addressing. Option B, preserve public IPv6 address space. Option C, reduce instances of overlapping IP addresses. And option D, support the NAT or the network address translation protocol. And the correct option is that this address space was defined to conserve the public IPv4 addressing, because these can be used by everyone inside their local network, and they don't conflict with each other because they are not routable over the internet. So in this way, instead of using the public IP addresses for every client inside your private LAN, you can use these addresses, and these can be used by everyone all over the world. Question number 29. Which HTTP status code is returned after a successful REST API request? And the options are: option A 200, option B 301, option C 404, and option D 500. And the correct option is option A 200. So a successful REST API request is typically indicated by a 200 OK HTTP status code. This signifies that the request was understood and successfully completed. Question number 30. Which two events occur automatically when a device is added to Cisco DNA Center? Choose two options, and the options are: option A, the device is assigned to global site. Option B, the device is placed into unmanaged state. Option C, the device is placed into provisioned state. Option D, the device is placed into the managed state. And option E, the device is assigned to the local site. And the correct options are: option A, the device is assigned to the global site, and the device is placed into the unmanaged state. So by default, new devices are initially placed into unmanaged state until they are properly configured and onboarded. Additionally, they are assigned to the global site until they are specifically moved to a different site within the Cisco DNA Center. Question number 31. In software-defined architecture, which place handles switching for traffic through a Cisco router? And the options are: option A, control, option B, management, option C, data, and option D, application. And correct option is the data. So the data plane basically handle switching for traffic through Cisco router. So this is the explanation. So again, this is the diagram of the typical SDN architecture. We have the control layer or the control plane and the infrastructure layer, which is also known as the data plane, as well as the application layer. So these are the switches. The movement of traffic or data to these switches is taken care in the infrastructure layer or in the data plane. Question number 32. When a switch receives a frame for known destination MAC address, how is the frame handled? So we have already studied this question time and again, and the correct option is option A, that it is sent to the port identified for the known MAC address when when the destination MAC address is known. Here we are talking about the known destination MAC address. If the destination MAC address is not known, then the packet is broadcasted out all ports except the port on which it was received. For example, let's suppose here we have, let's suppose this is PC1 and this is, sorry, let me get back to the question, and this is, let's suppose, PC2. Sorry. So if switch has already recorded the MAC addresses of the PC1, which is AA, and PC2, which is BB, so the switch knows that my PC1 is connected to port 1 and PC2 is connected to port 27. So when PC1 sends a packet for PC2, the switch will send it out this port only on the port 27, and it will be sent to the PC2. And if this MAC address was not known, then the switch would have flooded this packet out the all interfaces. Let's suppose if we had other client over here, it would have been sent to these clients as well. Question number 33. How does QoS or quality of service optimize voice traffic? And the options are option A, reducing bandwidth usage, option B, by reducing packet loss, option C, by differentiating voice and video traffic, and option D, by increasing jitter. And the correct option is option C, by differentiating voice and data traffic. So quality of service achieves this differentiation through traffic prioritization, ensuring that voice traffic receives preferential treatment over other type of data. This prioritization helps guarantee the quality of voice communication even in the conditions of network congestion. So this is how it is done. If you have the quality of service enabled, the audio is given priority because we don't want to delay our audio or voice communication. Video is given higher bandwidth because it requires maximum bandwidth, while the other web, email, and file transfer application are given best effort delivery queue. So this is how quality of service is implemented. Question number 34. How are the switches in a spine and leaf topology interconnected? And the options are option A, each leaf switch is connected to one of the spine switches. Option B, each leaf switch is connected to two spine switches making a loop. Option C, each leaf switch is connected to each spine switch. And option D, each leaf switch is connected to a central leaf switch then uplinked to a core spine switch. And the correct option is option C, that each leaf switch is basically connected to each of the spine switch. So this is the architecture of the leaf spine switch. So here we can see that each leaf switch is connected to each of the spine switches. So this gives us a high level of redundancy, that if one link fails, let's suppose if this link fails, and let's suppose if this, let's suppose here we have a client, if we want to communicate from this to this, and if any two of the link fails, let's suppose this one also fail, we'll still have connectivity, let's suppose from this and to this, which is connected to this link to this, or if we want to communicate with this through this. So that's how the leaf and spine architecture is built, that each leaf switch is connected to each of the spine switch. And this is the explanation, that the design ensures that there is a direct path between any two endpoints in the network, providing predictable and consistent latency and bandwidth across the network. This architecture is scalable and commonly used in data centers to manage large volumes of east-west traffic efficiently. Question number 35. In quality of service, which prioritization method is appropriate for interactive voice and video? And the options are: option A, expedited forwarding; option B, traffic policing; option C, round robin scheduling; and option D, low latency queuing. And the correct option is the low latency queuing. So the low latency queuing, or LLQ, is specifically designed to provide strict priority to delay sensitive traffic like voice and data, ensuring minimal delay and jitter, which is crucial for maintaining quality in real-time communications. Question number 36. Which two values or settings must be entered when configuring a new wireless LAN in the Cisco Wireless LAN Controller GUI? Choose two options, and the options are: option A, management interface settings; option B, QoS settings; option C, IP address of one or more access points; option D, SSID; and option E, profile name. And the correct options are the option D, SSID name, and option E, profile name. Question number 37, refer to the exhibit. So this is the exhibit, this is the configuration. A network engineer must block access for all computers on VLAN 20 to the web server via HTTP. All other computers must be able to access the web server. Which configuration, when applied to switch A communicate, accomplishes this task? So here we are talking about that all computers in VLAN 20 must be blocked from accessing this web server on this IP address, while other computers such as those on VLAN 10 should be able to access the web server. And these are the different configuration options: A, B, C, and D. So what is the correct option? So the correct option is B, and let's discuss why. So here we have configured the access list ACL and named it as www block, and we have configured the rule to deny TCP traffic from any host, from any IP address or any host to the IP address 10.30.0.100, which is this, on port 80, which is HTTP, and permit IP any. Besides this, permit all other traffic. And then we have gone into the interface VLAN 20 and we have applied this rule on the VLAN 20. So what does this mean? That we have first configured this ACL and thus we have applied it only on the VLAN 20. It means that only users or PC in the VLAN 20 will be blocked from accessing the web server, this web server, over the port 80. Question number 30. An engineer must configure a wireless LAN using the strongest encryption type for WPA2-PSK. Which cipher fulfills the configuration requirement? And the options are: option A, WEP. WEP is wired equivalence privacy or protection. Option B, RC4. Option C, AES, and option D, TKIP. And the correct option is AES, Advanced Encryption Standard. So it is the most secure and modern encryption method used in WPA2, providing strong protection for wireless networks. WEP and RC4 are outdated and insecure. TKIP is also considered less secure than AES and was primarily used in WPA, not WPA2. Question number 39. What is the difference between the radius and TechX? So these both are the authentication, or we can say simply that they both are AAA protocol. While AAA is for authentication, authorization, and accounting. So the options are: option A, radius is most appropriate for dial authentication, but TechX Plus can be used for multiple types of authentication. Option B, TechX encrypts only password information and radius encrypts the entire payload. Option C, TechX Plus separates authentication and authorization and radius merges them. And option D, radius logs all commands that are entered by the administration, but TechX Plus logs only start, stop, and interim commands. And the correct option is option C, that the TechX Plus separates authentication and authorization while the radius merges them. So the TechX Plus basically separates the authentication, authorization, and accounting, that is AAA function, providing more granular control over access, while the radius combines authentication and authorization, which can be less flexible in some scenarios compared to TechX Plus. Question number 40. What is the syslog facility? And the options are: option A, host that is configured for the system to send log messages. Option B, password that authenticates a network management system to receive log messages. Option C, group of log messages associated with the configured severity level. And option D, set of values that represent the process that can generate a log message. And this is the correct option, that it is the set of values that represent the processes that can generate a log message. So a syslog facility is a category or group that identifies the source or origin of a log message. It helps to classify log messages based on the system component or application that generated them. This classification aids in filtering, analyzing, and troubleshooting system issues. For example, common syslog facilities include kern, that is kernel messages, user level messages, mail system, daemon, system daemons, and auth, system security / authorization messages. Question number 41. What role does a hypervisor provide for each virtual machine in server virtualization? And the options are: option A, infrastructure as a service. Option B, software as a service. Option C, control and distribution of physical resources. And option D, services as a hardware controller. So the hypervisor is basically responsible for the control and distribution of physical resources. So these are the physical, let's suppose, resources, and above the physical resources we have the hypervisor, and above the hypervisor we have virtual machines. So hypervisor is basically responsible for distribution and control of these physical resources to the virtual machines. And this is the explanation. Question number 42. What is the function of a server? So this is a very basic question, and the options are: option A, it transmits packets between hosts in the same broadcast domain. Option B, it provides shared application to end users. Option C, it routes traffic between layer 3 devices. And option D, it creates a security zone between trusted and untrusted networks. And the correct option is that the server basically provides shared application to end users. Sorry, this is not the explanation of the server. So this is the server. What does why the server is different from a traditional PC? It is because the server gives shared. Let's suppose we have application over here on the server, and this application can be shared by multiple users or clients at the same time. While on PC, typically a single user can use the application at a time. So this is the difference between the server and a PC, a personal computer. Question number 43. A network administrator needs to aggregate 4 ports into a single logical link which must negotiate layer 2 connectivity to ports on another switch. What must be configured when using active mode on both sides of the connection? And the options are option A 802.1q trunks, option B CISCO VPC, option C LLDP, and option D LACP. And the correct option is option D LACP, link aggregation control protocol. So this is how it is done. Let's suppose if these switches are connected through 4 ports, they can be combined into a single logical ports using the LACP protocol, and the bandwidth of all these ports, let's suppose if they are 1G, is also combined, and this single logical links then have the capacity of 4 gigabit. Besides the higher bandwidth, this also gives us the redundancy. So let's suppose if one port fails in this logical group, this traffic can be sent on the other port. Similarly, we have the redundancy of over 3 ports. So LACP is specifically designed to aggregate multiple physical links into a single logical link, providing increased bandwidth, fault tolerance, and load balancing. Active mode on both sides ensure that both switches actively participate in the LACP negotiation process, leading to a stable and reliable aggregated link. Question number 44. What are two differences between optical fiber cabling and copper cabling? Copper and optical fiber, choose two options, and the options are option A, light is transmitted through the core of the fiber. Option B, a BNC connector is used for fiber connections. Option C, the glass core component is encased in a cladding. Option D, fiber connects to physical interfaces using RJ45 connections. And option E, the data can pass through the cladding. And the correct options are option A, that the light is transmitted through the core of the fiber, and option C, the glass core component is encased in a cladding. So these two are the correct option, and this is the explanation of the correct option. You can pause the video and read the explanation if you want further explanation. Question number 45. How does WPA3 improve security? So WPA3 is the improved version of WPA2. So how does this improve security? And the options are option A, it uses SAE for authentication. Option B, it uses a 4-way handshake for authentication. Option C, it uses RC4 for encryption. And option D, it uses TKIP for encryption. And the correct option is option A, it uses SAE for authentication. So WPA3 improves security primarily through the implementation of simultaneous authentication of equals. SAE stands for simultaneous authentication of equals. This replaces the traditional 4-way handshake used in WPA2, making it significantly more resilient to brute force attacks and dictionary attacks. Question number 46. A user configured OSPF in a single area between two routers. A serial interface connecting R1 and R2 is running encapsulation PPP by default. Which OSPF network type is seen on this interface? When the user types show IP OSPF interface on R1 or on 2. So we have, let's suppose, two router R1 or R2. They are connected through point-to-point serial link through WAN protocol PPP. So if OSPF is run on these two routers, so what will be shown by running the command show IP OSPF interface? And the options are option A, point to multi-point, option B, broadcast, option C, point to point, and option D, non-broadcast. And the correct option is option C, point to point. So a serial interface connecting R1 and R2 running encapsulation PPP will be seen as a point-to-point network type by default in OSPF. This is because a PPP link is a direct connection between two endpoints, which is the characteristics of a point-to-point network in OSPF. Other network types like broadcast, non-broadcast, multi-access, and point-to-multipoint are used for different types of network topologies. Question number 47. How do AAA operations, that is authentication, authorization, and accounting operation, compare regarding user identification, user services, and access control? And the options are option A, authorization provides access control and authentication takes user services. Option B, authentication identifies users and accounting tracks user services. Option C, authentication tracks user services and accounting tracks user services and authentication provides access control. Option D, authorization identifies users and authentication provides access control. And the correct option is option B, authentication provides users, identifies user and accounting tracks user services. And here is the breakdown. So authentication determines who the user is by verifying their credentials such as username and password. Authorization determines what the user is allowed to do based on their identity and roles. And accounting records user activities such as login, logout time, resource usage, and other relevant data for billing, auditing, and troubleshooting purposes. Question number 48. With REST API, which standard HTTP header tells a server which media type is expected by the client? And these are the four options. And the correct option is option D, accept application / JSON. So the accept header is used to specify the media types that the client is capable of understanding. By including this header in the request, the client informs the server about the preferred format for the response. Let's move forward to question number 49. Which network plane is centralized and manages routing decisions? And the options are A, policy plane, B, management plane, C, control plane, and D, data plane. And the correct option is the control plane. So control plane is basically the centralized plane and is responsible for managing the routing decisions. This is the explanation. You can pause the video or read the explanation. Question number 51. R1 has learned route 10.10.10.0/24 via numerous routing protocols. Which route is installed? So it means that we have multiple routes for the same destination. So which route will be selected? And the options are A, route with the lowest cost. Option B, route with the next hop that has the highest IP. Option C, route with the shortest prefix length. And option D, route with the lowest administrative distance. And the correct option is that if you have multiple routes to the same destination, then the route with the lowest administrative distance will be selected and chosen as the active route. So administrative distance is used to determine the trustworthiness of a route learned via different routing protocols. Routes with the lowest administrative distance are preferred and installed into the routing table. This metric helps the router decide which route to use when multiple routes to the same destination are learned from different protocols. Question number 1. What is the path for traffic sent from one user workstation to another workstation on a separate switch in a three-tier architecture model? And the options are option A, access core distribution access, option B, access distribution access, option C, access core access, and option D, access distribution core distribution access. So in a three-tier network architecture, we have three tiers. The first one is access, then distribution, and then core. So in this question, we have been asked that how the traffic moves from one workstation to another when both the workstation are on different switches. So the correct answer is answer D, access distribution core distribution access. So let me explain it with the help of this diagram that how this is the correct answer. So let's suppose we have a workstation A and another workstation, let's suppose this one B. So the traffic will move such that, so these are basically the access switches, these are the distribution, and these are the core switches. So the traffic will first move to this access switch, then to this distribution switch, okay, and then to this core switch, then to this distribution, and then to this access. So we have the path access, distribution, core, distribution, and access. I hope this is clear. So let's move forward to the next question. Question number 2. Which configuration management mechanism uses TCP port 22 by default when communicating with managed nodes? And the options are option A, Ansible, option B, Python, option C, Puppet, and option D, Chef. So we are talking about that which configuration management solution or mechanism uses the TCP port 22. So remember, the port 22 is basically used by SSH. In other words, which management mechanism uses the SSH protocol when communicating with the management nodes? And the correct option is option A, Ansible. So this is the diagram that shows that how Ansible communicates with the managed node. So the managed node means that the managed host. Let's suppose these are different hosts. This is host 1. Let's suppose this is placed in group A, host B, host 2, and host, and you can have any number of hosts, and all these are managed using the SSH protocol that uses port number 22. This is the explanation. So Ansible communicates with managed nodes over SSH, which typically operates on TCP port 22. Python is a programming language, while Puppet and Chef use other communication methods such as HTTPS on different ports. So the default port for HTTPS is 443. So the Python is basically, you all know that it is a programming language. These all Puppet and Chef are also configuration management mechanism, but they use HTTPS, not SSH. Question number 3. Which two must be met before SSH can operate normally on a Cisco IOS switch? Choose two options. So the question is that how to configure or what are the conditions for SSH to work on a Cisco IOS switch? And the options are option A, the switch must be running a K9, that is crypto IOS image. Option B, the IP domain name command must be configured on the switch. Option C, IP routing must be enabled on the switch. Option D, a console password must be configured on the switch. And option E, telnet must be disabled on the switch. And the correct options are, in order for SSH to work or operate on the Cisco IOS switch, we must have The first option is that the switch must be running a K9 crypto iOS image that supports SSH. And the second correct option is that the IP domain name command must be configured on the switch. So the option A is correct because A is required since only the K9, that is crypto version of the Cisco iOS, supports SSH encryption. And option B is necessary because the IP domain name command is used to generate the RSA key pair, which is needed for SSH to function. And this is how this SSH is then configured. So if your Cisco iOS has not the K9 OS, you cannot use this command. So the two conditions are that you must configure this command, and then the OS must be K9, that is crypto, so that this command can be run. And these are other commands that are then used to configure the SSH. Question number 4. Which 802.11 frame type is indicated by a probe response after a client sends a probe request? And the options are option A, action, option B, management, option C, control, and option D, data. And the correct option is option B, management. So the explanation is that in 802.11 standard, management frames are used for the processes of discovering and joining networks. A probe request and probe response are part of this process, where the client device probes to discover available wireless networks and the access point responds with network information. So 802.11 is basically the Wi-Fi standard. So we are talking about that which type of frames are exchanged between the client and the access point when the AP responds to a client request. So the correct option is management frame type. Question number 5. Refer the exhibit below. This is the exhibit. Which action do the switches take on the trunk link? So we have these two switches, and this is the configuration done on both the switches. This is switch 1 and this is switch 2. So we have the interface fast Ethernet 01, and then switch port trunk encapsulation 8021Q, and then switch port trunk native VLAN 999, and switch port mode trunk. Again, on the switch 2, we have the same commands, except that here the native VLAN is used as 999 instead of 999. Rest the configuration is the same. So when you configure two different native VLAN IDs on the trunk port, what will occur? And the options are: the trunk does not form and the ports go into an error disabled status. Option B, the trunk forms but the mismatched native VLANs are merged into a single broadcast domain. Option C, the trunk does not form but VLAN 99 and VLAN 999 are allowed to traverse the link. And option D, the trunk forms but VLAN 99 and VLAN 999 are in a shutdown state. So what will be the result of this configuration on these two switches? And the correct option is that the trunk forms but the mismatched native VLANs are merged into a single broadcast domain. So the trunk port will be configured, it will form, but it will have, due to mismatch VLAN IDs, it will have some issues, and these are explained here. When there is a mismatch in the native VLAN configuration, the trunk will still form, but it can cause unexpected behavior such as traffic being sent to the wrong VLAN. Cisco devices will not block the trunk link due to a native VLAN mismatch, but it will trigger a warning message in the logs. Therefore, it is necessary that native VLAN IDs on both ends of the trunk mesh for it to work properly. Question number 6, refer to the exhibit below, and this is the exhibit. Which two prefixes are included in this routing table entry? Choose two. So we have this routing table entry, we have this route, it is C, it is basically directly connected on port fast Ethernet 01. So which two IP addresses are included in this entry? And the options are option A, 192.168.1.70, option B, 192.168.1.61, option C, 1.64, option D, 192.168.1.127, and option E, 192.168.1.254. So always remember that the subnetting is very, very important and necessary for network administrator as well as for the network exam such as CCNA to pass, because you will encounter the subnetting in many questions and in your professional field as well. So here if you analyze this entry and you basically expanded the range, this entry shows the network range from 0 to 192.168.1 dot. It is basically 2 raised to the power 6. So 2 raised to the power 6 is basically 64. So we have a range of 64 from 0 to 63. Remember, you don't mistakenly write 64 as here, because the total IP addresses are 64 and the 0 is included in this range. So we will have a range from 0 to 63, and then it is straightforward. You can see that 17 is included in this range. 61 is also included in this range, while the rest 64, 1 to 7, and these all are out of range. So these two prefixes or these two IP addresses are included in this entry. So the correct answers are option A and option B. And this is the explanation I already explained. So the routing table entry in the exhibit is for the prefix 192.168.1.0/26, which means the subnet range covers addresses from range 192.168.1.0 up to 63. The two valid prefixes included in this range are 17 and 61. Question number 7. What are two recommendations for protecting network ports from being exploited when located in an office space outside of an IP closure? Choose two options. We are talking about protecting network ports from being exploited. And the options are option A, enable the port fast feature on the ports. Option B, implement port-based authentication. Option C, configure static ARP entries. Option D, configure ports to a fixed speed. And option E, shut down unused ports. And the correct options are option B, implement port-based authentication, and option E, shut down unused ports. So port-based authentication is also known as the NAC, Network Access Control. It is basically port-based authentication, and the standard for this is 802.1x. It works such that only authenticate whenever a device wants to connect to the network, to the switch, it is first authenticated with a centralized server, and then it is allowed on the network. So this is a security feature. And the second is a common security feature to disable or shut down the unused ports. Usually the switches are of 24 ports or 48 ports or 16 ports, and usually few ports are used and rest are unused. Let's suppose in this case, if we have these ports used and these ports are unused, they are open, then you must disable these ports through configuration so that no one can plug their devices to these ports and access the network. So port-based authentication, that is 802.1x, helps ensure that only authorized devices can connect to the network, while shutting down unused ports prevents unauthorized access by disabling any ports that are not actively being used, as I already explained. Question number 8, refer to the exhibit. This is the exhibit. Which route type does the routing protocol code D represent in the output? So these are basically the routing entries. CCD. One is this. The C is basically for directly connected. This means that this network is configured directly on this interface, and the second, this network is configured on this fast Ethernet 00. So what does the D stands for? Okay, so the options are option A, internal BGP route, option B, /24 route of a locally configured IP, option C, statically assigned route, and option D, route learned through EIGRP. And the correct option is that the D is this entry means that this route is learned through EIGRP. So in Cisco devices, the code D stands for routes that are dynamically learned via EIGRP. The numbers in the brackets, that is this, we are talking about this number, represents the administrative distance and the metric for this EIGRP learn route. Another code for this, if we have O, then O means that this route is learned through OSPF. Question number 9, which type of IP version 6 address is publicly routable in the same way as IPv4 public addresses? And the options are option A, global unicast, option B, link local, option C, unique local, and option D, multicast. And the correct option is option A, global unicast. This is the explanation. The global unicast address in IP version 6 are similar to public IPv4 addresses, as they are globally unique and routable on the internet. The other options are not publicly routable. Link local addresses are used only within a local network segment. Unique local addresses are used for private networks similar to IPv4 private addresses. So IPv4 private addresses are basically RFC 1918 addresses that include 10.10/8, 192.168/16, and 172.16/12. So multicast addresses are used for one-to-many communication within a defined scope. Question number 10, refer to the exhibit. Which change to the configuration of switch allows the two switches to establish an ether channel? So we have these two switches, switch 1 and switch 2, and both the switches have the configuration to form an ether channel. So what is an ether channel? When you configure multiple links between two switches, you configure them, and through configuration you combine them into a single logical unit. This has many benefits, including the redundancy, that if one link fails, the traffic still flows. Increased bandwidth, if this is 10G and this is 10G, you have the benefit of 20G. And easy management, you manage this multiple interfaces as a single interface. So this configuration has some issue, although the configuration is done on both the switches, but the ether channel is not up and it is down. So what changes must be done so that the ether channel is formed and the configuration is corrected? So the options are: option A, change the protocol to ether channel mode on; option B, change the LSAP mode to active; option C, change the LSAP mode to desirable; and option D, change the protocol PAQP and use auto mode. And the correct option is that change the LSAP mode to active. Here we can see that we have the mode as passive on both the switches, so changing the mode to active will do the trick. So LSAP mode, this determines how aggressively a switch negotiates to form an ether channel. So LSAP have two modes. Passive, the switch will only form an ether channel if the other switch initiates. So since both are passive, no one will initiate. Active, the switch will actively initiate ether channel formation. The current configuration shows both switches in passive mode. This prevents them from forming an ether channel. Changing LSAP mode to active on both switches will allow them to actively negotiate and establish an ether channel. Question number 11. A packet is destined for 10.10.1.22. Which static route does the router choose to forward the packet? So we want to reach to this destination, that is 10.10.1.22, and we have these multiple routes. So which route will be selected by the router to reach this destination? Option A, IP route 10.10.1.0 and subnet mask is 240, and this is the gateway is same for all 10.10.255.1. Or option B, we have 10.10.1.16 and 255.255.255.252, and the gateway is 10.10.255.1. Again, in option C, we have the route 10.10.1.20 and the subnet mask is 255.255.255.252. Gateway is the same. Gateway, you can say this is the next hop. In option D, we have the IP route 10.10.1.20 and the subnet mask is 255.255.255.252, and its next hop is 10.10.255.1. And the correct answer is option C, IP route 10.10.1.20 255.255.255.252, and the next hop is 10.10.255.1. So why this option is selected? Let's break down each entry and you will understand the concept. So in option A, we have the IP route this. So here we have the subnet /28 and this has the range from 0 to 15. So since this has the range from 0 to 15, it does not include 22. In option B, we have the subnet 30 and the range is from 16 to 19. Again, this does not include the IP address 22. In option C, we have the route 10.10.1.20/30. Subnet mask is 30. 252 refer to 30, as is this case. 28 refer to 240. And range here is 10.10.120 to 10.10.123. So this option includes 22. That's why this is the correct answer. In option D, we have /31 or 254/31 and the range here is from 20 to 21. This also does not include 22. So that's why the correct answer is option C, which include our destination IP address of 10.10.1.22. Question number 12. An office has 8 floors with approximately 30 to 40 users per floor. What command must be configured on the router switched virtual interface to use address space efficiently? So we have that 8 number of floors, and each floor must have maximum of 40 users. So basically the question is about how many IP addresses would you require and which command would suffice the IP addresses, and the options are option A, IP address 192.168.0.0 and subnet mask 255.255.0.0. Option B, IP address 192.168.0.0 and subnet mask 255.255.254.0. Option C, IP address 192.168.0.0 and subnet mask 255.255.255.128. And option D, IP address 192.168.0.0 and subnet mask 255.255.250.224. And the correct option is option B, 192.168.0.0 and 255.255.254.0. Why this is correct answer? Let me break down each options one by one. So total number of IPs or total number of users are, since we have 8 floors and each floor have a maximum of 40 users, so we have total number of 320 users. So we would require 320 IP addresses. So we need to do subnetting to accommodate up to 320 user. We need to choose a subnet mask that provides enough IP addresses. So in option A, we have the IP address 192.168.0.0 and this is the subnet mask. So the subnet is /16. So the number of usable IP addresses are 2 to the power 16 minus 2, 2 raised to the power 16 minus 2, and this is 65,534. So this is sufficient, but these are a lot of IP addresses. We only need 320. So we won't like to use this address because it will waste a lot of IP addresses. 65,000 is too much as compared to 320. In option B, we have 192.168.0.0, 255.255.254.0. This is /23. So here we have total number of IP addresses, usable IP addresses 2 to the power 9. Remember, 32 minus 23, 9. So 2 to the power 9 minus 2, 5, 10. This is also sufficient, but it also has more addresses. We will see if we can have sufficient addresses but less than this. So in option C, again we have the this subnet mask which corresponds to /24, and the usable addresses are 2 to the power 7, 2 raised to the power 7 minus 2, which is 1 to 6. So these are not sufficient since we need 320. And in option D, again we have the subnet of 27 corresponding to 2 to 4, and here we have the usable addresses 2 raised to the power 5 minus 2, only 30. So these two are not sufficient because they have less IP addresses compared to 320. The option B, so these are crossed, C and D. Option B, the option B have 510 addresses and option A has 65,000. So obviously we will choose the option B because it has sufficient addresses and we won't be wasting as many addresses as in option A. So the option B is the correct answer. So again, as I emphasized earlier, the subnetting, you must be expert in the subnetting and you must practice the subnetting so that in your profession, in your practical field, you can do these type of works. You can configure networks, you can calculate the required IP addresses, as well as for your exam you will also encounter question where you will need to know the subnetting. Question number 13, which command must be entered when a device is configured as NTP, an NTP server, network time protocol server? And the options are option A, NTP authenticate, option B, NTP server, option C, NTP peer, and option D, NTP master. And the correct option is option D, NTP master. So this is the explanation for all the options. The NTP authenticate, option A, this command is used to enable NTP authentication but does not configure the device as a master server. Option B, the NTP server, this command is used to configure the device to synchronize its time with another NTP server, not to make it an NTP master. NTP pair, this command establishes a peer relationship with another NTP device, allowing them to synchronize time with each other, while the NTP master, this command configures the device as an NTP master server. It specifies the stratum level, indicating that this device will provide time services to other NTP client. Question number 14. Which technology must be implemented to configure network device monitoring with the highest security? So we are talking about device monitoring but with highest security, and the options are option A, IP SLA, option B, syslog, option C, NetFlow, and option D, SNMP version 3. And the correct option is option D, SNMP version 3. We can implement this to configure and manage our network devices, monitor our network devices with highest security. So this is the explanation for all the options. IPSLA technology is used for active monitoring of network performance, but it does not provide specific security feature for monitoring data. Option B, syslog, while useful for logging devices events, syslog does not encrypt the message is sent, making it less secure for monitoring sensitive information. NetFlow, this is a protocol for collecting IP traffic information, but like syslog, it does not provide built-in security measures such as encryption. And option D, SNMP version 3. This version of the simple network management protocol includes robust security features including authentication and encryption. It is designed specifically to provide secure monitoring and management of network devices. Remember, the earlier version of SNMP does not provide these security features such as SNMP version 1 and 2. Question number 15. Which two primary drivers support the need for network automation? Choose two options, and the options are option A, eliminating training needs, option B, increasing reliance on self-diagnostic and self-healing, option C, policy-driven provisioning of resources, option D, providing a ship entry point for resource provisioning, and option E, reducing hardware footprint. And the correct options are, we have to choose two options, that the primary drivers for network automation is increasing reliance on self-diagnostic and self-healing, and the policy-derived provisioning of resources. And this is explanation for both the correct option. Increasing reliance on self-diagnostic and self-healing, network automation enables devices to automatically detect and diagnose issues and take corrective actions without human intervention. This reduces downtime and improves network reliability. Option C, a policy-driven provisioning of resources. Network automation can be used to automate the provisioning of network resources based on predefined policies. This ensures that resources are allowed efficiently and consistently and reduces the risk of human error. Question number 16. Using direct sequence spread spectrum, which three 2.4 GHz channels are used to limit collisions? And the options are option A, 1, 6, and 11, option B, 1, 5, 10, option C, 1, 2, 3, and option D, 5, 6, 7. And the correct option is option A, 1, 6, and 11. And this is the explanation. So in 2.4 GHz frequency range, there are a total of 14 channels. that are channels 1 through 14, but only channels 1, 6, and 11 are non-overlapping in the United States and many other regions. Each channel in the 2.4 GHz band is 20 MHz wide, and since the channels overlap, using channels 1, 6, and 11 helps to minimize the interference and collisions, allowing for better performance in wireless networks. Question number 17. Which port type supports the spanning tree port fast command without additional configuration? And the options are option A, access ports, option B, layer 3 main interfaces, option C, layer 3 sub-interfaces, and option D, trunk ports. And the correct option is option A, access ports. So this is the explanation for all the options. So the access ports, these ports are designed for connecting end user devices like workstations or servers. By default, access ports are configured to automatically go into the forwarding state when they are connected to a device without requiring additional spanning tree configuration. This is because access ports are typically not part of a loopback or redundant topology. Layer 3 main interfaces and Layer 3 sub-interfaces, these ports are used for routing and are not directly involved in spanning tree calculations. They don't support the port fast command. Trunk ports are used to carry multiple VLANs between switches. They require specific configuration to enable the port fast command, as they are more likely to be part of redundant topologies. Question number 18. Refer to the exhibit. Which route type is configured to reach the internet? So this is the exhibit. We have this switch 1. This is another switch. This is the router. So we have been asked that which route is configured on this router R1. This is the routing table of R1 to reach this internet. What is the route type that is configured here to reach this internet? Let's suppose this client wants to read the internet via this router. How it will reach the internet? Through which route? The options are option A, host route, option B, default route, option C, floating static route, and option D, network route. And the correct option is option B, default route. So we are basically talking about this route where the next hop is this 10.10.10.18, and this is basically the denotion of a default route. Default route contains all the destination, and it is used when the entry or the route to destination is not available in other entries, then the default route is used. So whenever any device wants to access internet, or for that case anywhere, first of all the configure routes are checked. If the destination is not available through in these routes, then the default route, since the default route contains all the destination. Let me bring up the explanation. So a default route is a static route that specifies the next hop to be used for packets that do not match any other specific route in the routing table. It is typically used to reach the internet or other external networks. Another thing to remember is that internet, if you want to access internet, you cannot configure manually each route towards the internet, since we have here thousands and millions of destinations. You have hundred and thousand of websites, applications, each have different IPs, so you cannot configure all these manually. So that's why when we have a huge external network such as the internet, we normally use the default route. Question number 19. What benefit does controller based networking provide versus traditional networking? So the controller-based networking is basically the software-defined networking where a centralized control plane and controller is used as compared to traditional networking. So what are the benefits of SDN? And the options are: option A, it moves from a 2-tier to 3-tier network architecture to provide maximum redundancy. Option B, provides an added layer of security to protect from DDoS attacks. Option C, allows configuration and monitoring of the network from one centralized port. And option D, combines control and data plane functionality on a single device to minimize latency. And the correct option is that the control-based networking allows configuration and monitoring of the network from one centralized port or from one centralized device or location. So this is how the control-based networking looks like. In control-based networking, we have distinct layer. This is the, let's suppose, control plane, or you can say that it is the control layer. You can also call it a control plane. This is the data plane. So in traditional network, the control plane and data plane, they are on the same device. It means that if you have a switch, both the control plane and data plane resides over here, while in SDN or in the controller based networking, the control plane is separated from the data plane and they reside on different devices. So using this control plane or the controller based networking, you can manage and configure the devices from a centralized controller. So that is the main benefit. Question number 20. What are the two benefits of HRPs? And the FHRP, first hop redundant protocol. FHRPs are first hop redundant protocol. We have to choose two options. Option A, they prevent loops. This is basically loops in the layer 2 network. Option B, they allow encrypted traffic. Option C, they are able to bundle multiple ports to increase bandwidth. Option D, they enable automatic failover of the default gateway. And option D, they allow multiple devices to serve as a single virtual gateway for clients in the network. And the correct options are, the first correct option is that the first hop redundancy protocol enable automatic failover of the default gateway. I will explain these in a bit. And the second correct option is that they allow multiple devices to serve as a single virtual gateway for clients in the networks. So how this is done? Let me bring this diagram. So the first hop redundancy protocol works such that you have two routers here, let's suppose R1 and R2. So they are configured such that they both are basically directly connected. They are configured using this protocol and they worked as in tandem with each other. One device works as an active, that is actively configuring forwarding traffic, while other work as a passive. And a virtual IP or gateway is configured on these devices, such as this 20.1. On the client device, let's suppose this is a client, you configure the gateway as this virtual gateway. Although both the devices has physical IP addresses, this is the virtual IP addresses. So what is the benefit of this? That for this client, you do not need to configure both the gateway here, only you configure this virtual gateway as shown here. And the other benefit is that, let's suppose now the traffic is being routed through these devices. If this device fails due to any reason, the traffic is handed over or traffic is processed by this device, and now the traffic goes through this. The client does not see any break or any disruption in the services. So that is the benefit of first hop redundancy protocol. So the benefits: automatic failover, First half redundancy protocol provide high availability by automatically switching to a backup gateway if the primary gateway fails, such as in this case. This ensures that network traffic continues to flow without interruption. Virtual gateway first half redundancy protocol allows multiple devices to act as a single virtual gateway, providing redundancy and load balancing. This means that clients can use a single IP address to access the network, regardless of which device is currently acting as the active gateway, as I already explained. Question number 21. Where does wireless authentication happen? And the options are option A, SSID, option B, radio, option C, band, and option D, layer 2. And the correct option is option D, the wireless authentication occur at layer 2. So wireless authentication such as WPA, Wi-Fi protected access, and WPA2 occurs at layer 2 of the OSI model. This is where MAC addresses are used, and protocols such as EAP, Extensible Authentication Protocol, may be utilized to authenticate devices attempting to connect to the wireless network. So this protocol again is used by 802.1x standard, also known as NAC, Network Access Control, that is used whenever a device wants to connect to a network. When this NAC is used, the device is first authenticated from a centralized server and then it is allowed. And this authentication most of the time occurs through the MAC addresses and other mechanism. That's why this authentication occurs at layer 2. Question number 22. Which WPA3 enhancement protects against hackers viewing traffic on the Wi-Fi network? So this is the latest Wi-Fi protection standard. So how does this standard protect the traffic from hackers in Wi-Fi network? And the options are option A, TKIP encryption, option B, AES encryption, option C, scrambled encryption key, and option D, SAE encryption. And the correct option is option D, SAE encryption. So the SAE, that is simultaneous authentication of equals, is a new encryption protocol introduced in WPA3. It provides stronger protection against attacks like dictionary attacks and brute force password cracking. SAE also uses a more secure key exchange process, making it harder for hackers to intercept and decrypt traffic. Question number 23. Which statement about link aggregation when implemented on a Cisco wireless LAN controller is true? And the options are option A, to pass client traffic, 2 or more ports must be configured. Option B, the Ether channel must be configured in mode active. Option C, when enabled, the wireless LAN controller bandwidth drops to 500 Mbps. And option D, one functional physical port is needed to pass client traffic. And the correct option is option D, one functional physical port is needed to pass the client traffic. So a Cisco wireless LAN controller can pass client traffic with just one active port, even if link aggregation is configured. So this is a diagram just to show you the concept. We have here a Cisco wireless LAN controller. It is connected with the distributed switches through link aggregation using multiple links. This is how it works. But the question here suggests that even if you use one link and configure the link aggregation, it will still work. It will pass the client traffic. You do not necessarily, it is recommended that you have multiple physical ports, but if you do not have multiple ports, even a single port will still pass the traffic and the configuration will still work. Question number 24. Which two outcomes are predictable behavior of HSRP? Choose two options. And the options are option A, the two routers share a virtual IP address. So this is similar to FHRP, first hop redundancy protocol. Further, it will be explained in the explanation. Option A, the two routers share a virtual IP address that is used as a default gateway for devices on the LAN. Option B, the two routers negotiate one router as the active router and the other as the standby router. Option C, each router has a different IP address. Both routers act as a default gateway on the LAN and traffic is load balanced between them. Option D, the two routers synchronize configuration to provide consistent packet forwarding. And option E, the two routers share the same IP address and default gateway traffic is load balanced between them. And the correct options are that the two routers share a virtual IP address that is used as the default gateway for devices on the LAN, as I already explained in a question a while ago. And the second correct option is that the two routers negotiate one router as the active router and the other as the standby router. So this is the explanation for both the option. The virtual IP address, this is for option A. HSRP, that is hard standby router protocol, uses a virtual IP address that is configured on both routers. This virtual IP address is advertised as the default gateway to devices on the LAN. Active and standby routers, HSRP elects one router as the active router and the other router as the standby router. The active router handles all traffic while the standby router remains in a standby state, ready to take over if the active router fails. Again, as I already explained in the previous question, the two routers shares a virtual gateway or a virtual IP, and the clients on the LAN, they use this virtual gateway. They do not use the physical IP addresses of the individual routers, and these are configured as active and passive. One router is active at a time. Let's suppose this is R1 and the other is passive. So at a specific point in time, the traffic is handled by this active router, and if this router fails, then the traffic is routed to the secondary router, which becomes then active. Question number 25. What are two reasons for an engineer to configure a floating state route? I think this is a static route. Floating static route. Let me get back a bit. Choose two options, and the options are option A, to automatically route traffic on a secondary path when the primary path goes down. Option B, to route traffic differently based on the source IP of the packet. Option C, to enable fallback static routing when dynamic routing protocol fails. Option D, to support load balancing via static routing. And option D, to control the return path of traffic that is sent from the router. And the correct options are that the floating static route is configured to automatically route traffic on a secondary path when the primary path goes down, and to enable fallback static routing when the dynamic routing protocol fails. So option A is correct, because a floating static route is a static route that has a higher administrative distance than the primary route, allowing it to take effect only when the primary route becomes unavailable. Option C, floating static routes can serve as a backup to dynamically learned routes, providing a way to maintain connectivity if the dynamic routing protocol loses its path. Let's move forward to question number 26. So the service password encryption command is entered on a router. What is the effect of this configuration? Option A restricts unauthorized user from viewing clear text password in the running configuration. Option B encrypts the password exchange when a VPN tunnel is established. Option C prevents network administrators from configuring clear text passwords. And option D protects the VLAN database from unauthorized PC connections on the switch. And the correct option is option A. It restricts unauthorized users from viewing clear text passwords in the running configuration. So when you use the service password encryption, this command is used to encrypt passwords stored in the running configuration of a Cisco router. This prevents unauthorized user from viewing clear text password if they gain access to the router's configuration. What does this mean? That if you see the configuration of the router, the password will not be shown in clear text, rather it will be shown as garbage entry. Question number 27. What does an SDN controller use as a communication protocol to relay forwarding changes to a southbound API? So which protocol is used by SDN controller to communicate through southbound API? And the options are option A OpenFlow, option B Java, option C REST, and option D XML. And the correct option is option A OpenFlow. Let me get back a bit. So this is an SDN controller, and this controller talks with the network devices. This is basically, the controller is in the control plane, and these devices, the network switches, basically are in the data plane. This is what we call the southbound API. So this controller talks with the network devices, that is switches, through OpenFlow protocol. This is a standard protocol used for communication between an SDN controller and network devices like switches and routers. The controller uses OpenFlow to relay forwarding changes to the devices, enabling it to dynamically control the network's behavior. Question number 28. Which statement correctly compares traditional networks and controller-based network? Traditional or legacy network and controller-based network are basically referring the SDN, software-defined networking. And the options are option A, only traditional network offers a centralized control plane. Option B, only traditional network natively supports centralized management. Option C, traditional and controller-based network abstract policies from device configuration. And option D, only controller-based networks decouple the control plane and the data plane. And the correct option is option D, that only controller-based networks decouple the control plane and the data plane. So what does this mean? In the SDN, this is basically an architecture of SDN or controller-based network. The data plane and the control plane, they are decoupled or they are separated. They physically exist on different devices. So the controller here is the brain of the network that lies inside the control plane, while in the data plane we have the network switches that are configured or controlled through the controller. While in traditional network, both the control plane and data plane, they resides inside the same device, such as the traditional network switches. They both lies inside the same device and they are not decoupled. In the controller-based network, they are decoupled. Question number 29, refer to the exhibit Which route does R1 select for traffic that is destined to 192.168.16.2? And the options are option A 192.168.16.0/21, 16.0/24, 26.0/26, and 16.0/27. So we want a route that can be used to reach this destination 16.2, and we have multiple routes as shown here in this routing table. So which route will be selected by the router inside the routing table? And the correct option is option D, the 192.168.16.0/16. Although this destination also exists in this as well as in this network, you can also reach to this destination through this route as well as through this route. So why this route is selected? It is because this is destination IP addresses matches all four. If you want to say all four, then this means this is also 16. All four entries in the routing table, but the 192.168.16 are 0 has the longest prefix, so it will be chosen. This is called the longest prefix match rules. So you can say that, you can remember this, that the smaller or more specific is the route, the more chances of it is that it will be selected. Or for the longest, you can see that here we can see that 27 is the longest prefix, or it is the biggest prefix here in all these, so that's why this is selected. Question number 30. Which technology can prevent client devices from arbitrarily connecting to the network without state remediation? And the options are option A 802.1x, option B IP source guard, option C MAC authentication bypass, and option D 802.11n. And the correct option is option A 802.1x, which is also known as NAC network access control. That is a port-based authentication that allows network devices to connect to network after necessary authentication and state remediation. So this is a port-based authentication protocol that requires client devices to authenticate with a central authentication server before being granted access to the network. This prevents unauthorized devices from connecting to the network without proper authorization. So this is how the IEEE 802.1x work. So this is the switch, or this is the device with which this client wants to connect, and this basically wants to access this internet or LAN. So when the device wants to connect, this here we have a centralized authentication server. The authenticator asks this authentication server whether to allow or deny access, and based on the configured policies and the state of the device, it will either be allowed to access the internet or LAN, or either it will be blocked. So this is the concept of 802.1x, or also known as NAC network access control. Question number 1. What is the role of access points in an enterprise network? And the options are option A, connect wireless devices to a wired network. Option B, support secure user logins to devices or the network. Option C, integrate with SNMP in preventing DDoS attacks. And option D, serve as a first line of defense in an enterprise network.
So we are talking about the access point role in a wireless network. So let's suppose this is access points and we have different wireless clients. Let's suppose laptop, smartphones that are connected to this access point. So what is the role of this access point? And the correct option is that the access point connect wireless devices to a wired network. So this is the basic role, and this is how an access point is placed. So here we have an access point, and the wireless clients, they connect to the access point through this wireless LAN, and then the access point is used to connect these clients to the wired network. So this is basically the wired network. Some clients may want to connect to the internet. Some clients may want to use the local server. So the bridge between the wired and the wireless network is this access point. Question number two, what is the same for both copper and fiber interfaces when using SFP modules? And the options are option A, they support an inline optical attenuator to enhance signal strength. Option B, they provide minimal interruption to services by being hot swappable. Option C, they offer reliable bandwidth up to 100 Mbps in half duplex mode. And option D, they accommodate single mode and multi-mode in single module. And the correct option is that both the copper and fiber SFPs provide minimal interruption to services by being hot swappable. So these are basically the SFPs. This is the fiber SFP, optical fiber cable SFP, you can call it. And this is the copper SFP with which you can plug the Cat6, Cat7 cables using RJ45 connector. While for the fiber here we use basically these connector. These are basically the fiber connector. They are known as basically LC connector. So they both have in common that you can plug in these SFPs into the devices while the device is in the running state, and it won't interrupt any services. Hot swappable means that you don't need to shut down this device, this switch or router to plug in the device. You can unplug and plug the device while the device is running without interrupting any services. Question number three, what are two descriptions of three-tier network topology? Choose two options. And the options are option A, the core and distribution layers perform the same functions. Option B, the access layer manages routing between devices in different domains. Option C, the network core is designed to maintain continuous connectivity when devices fail. Option D, the core layer maintains wired connections for each host. And option E, the distribution layer runs layer 2 and layer 3 technologies. So the two descriptions of the three-tier network architectures are, the first one is that the network core is designed to maintain continuous connectivity when devices fail. And the second description is that this distribution layer runs layer 2 and layer 3 technologies. So let me first go through the explanation. The explanation for option C is that the network core is designed to maintain continuous connectivity when devices fail. This is key characteristic of three-tier network topologies. The core layer is designed to be highly redundant and resilient, ensuring that the network can continue to function even if individual devices fail. And the second description, option E, the distribution layer runs layer 2 and layer 3 technology. The distribution layer is responsible for routing traffic between the core and the access layer. It typically runs both layer 2, that is VLANs, MAC addressing, and layer 3, that is IP routing protocols, to perform its functions effectively. And this is the diagram of the three-tier network architecture. So we have the access layer, the distribution layer, and the core layer. So as we said that the core layer is designed to maintain continuous continuity of services even if individual devices fail or individual link fail. So what does this mean? That this device is connected to both the core devices. So let's suppose if this link fails and this device wants to communicate, so let me go back, communicate with this device, this one, it can still utilize this link and the communication won't be interrupted. So the core layer is thus designed to withstand the individual link or device's failure. And the second is that the distribution layer runs both layer 2 and layer 3 technology. So below this line, you can say that this is layer 2 technology where these devices are connected through VLANs, and you can further say that this is a trunk port that carries multiple VLAN. And above this, you can say that here the distribution layer is connected to the core through layer 3. So this way we can say that the distribution layer runs both the layer 2 and layer 3 technology. Question number 4. An engineer observes high usage on the 2.4 GHz channels and low usage on the 5 GHz channels. What must be configured to allow clients to preferably use 5 GHz access points? In the options are option A, 3 anchor round clients, option B, 11 ACMU MIMO, option C, OEAP split tunnel, and option D, client based select. And the correct option is the option D, client based select. So what is client based select? To optimize wireless network performance, enabling client based select encourages dual band capable clients to favor the less crowded 5 GHz frequency over the 2.4 GHz band. This helps balance traffic between both frequency ranges, improving overall efficiency and reducing congestion on the 2.4 GHz channels. Question number 5. Refer to the exhibit. This is the exhibit. Which command must be executed for interface gigabit 1/1 on switch 1 to become a trunk port if gigabit 1/1 on switch 2 is configured in desirable or trunk mode? So the question is that this link is configured as desirable or in trunk mode. So what must be configured on switch 1 for this link so that the Ethernet link is configured so that this link becomes trunk? And the options are option A, switch mode port trunk, option B, switch port mode dot one dash tunnel, option C, switch port mode dynamic auto, and option D, switch port mode dynamic desirable. And the correct option is that for the interface gigabit 1/1 on switch 1 to become trunk, we should configure the command switch port mode dynamic auto. And why is that? The explanation is that when a port is configured with dynamic auto, it will passively wait for the other side to initiate the trunking process. So the port on switch 1 will wait passively for the switch 2 to initiate the trunking process. So since switch 2 is set to be either desirable or trunk mode, switch 1's port in auto mode will agree to form a trunk link. So since we know that the port on switch 2 is already configured to be in desirable or trunk mode, so this port will initiate the process, and the port on switch 1 is in dynamic auto mode, it will accept the process and thus this port will become trunk. Question number 6. What is the function of TFTP in network operations? And the options are: option A transfers a backup configuration file from a server to a switch using a username and password. Option B transfers files between file systems on a router. Option C transfers the configuration files from a server to a router on a congested link. And option D transfer iOS images from a server to a router for firmware upgrades. And the correct option is option D transfers iOS images from a server to a router for firmware upgrades. So this is a screenshot of a TFTP application, or you can say server application. This is how you can see that here this may be a router IP, and this is the file transfer in progress to this server, and this is the status of the file being transferred. This is the server IP from where the file is being transferred, and this is the directory. You can change the directory to the file where it is located. So this is very single application and simple setup used to transfer the firmware images from your laptop or from your server to the switches or to the routers. Question number 7. A network engineer must create a diagram of a multi-vendor network. Which command must be configured on the Cisco devices so that the topology of the network can be mapped? And the option are: option A, Cisco config LLDP run. Option B, the command is CDP run. Option C, CDP enable. And option D, flow sampler map topology. And the correct command to map the network topology on the Cisco device is LLDP run. So these are the some of the commands that you can run on the Cisco switch regarding the LLDP protocol. You can run the command LLDP run. You can disable or remove this command. You can also disable the transmission or reception of the LLDP packets. And once you configure it, you can check the status of LLDP through these commands. Through these commands, you can show the LLDP configuration. You can show the neighbors that are being discovered through LLDP, and you can see the details of the neighbors that are discovered through this LLDP protocol. Question number 8. When a wireless LAN with WPA2 PSK is configured in the wireless LAN controller GUI, what format is supported? And the options are: option A, Unicode, option B, base 64, option C, decimal, and option D, ASCII. And the correct option is the option D, ASCII format. And this is a screenshot from a wireless LAN GUI. You can see that we are using WPA2 and we have selected the PSK, and in the PSK format we can see the ASCII, and these are the ASCII characters that are typed. So in wireless LAN WPA2 using PSK mode, the ASCII format is supported. Question number 9. When deploying syslog, which severity level logs informational messages? So these are different severity levels of logs. So what is the informational messages severity? And the options are: option A 0, option B 2, option C 4, and option D 6. And the correct option is option D 6. So here is the quick reference for syslog severity level. So 0 is for emergency, 1 is critical, 1 is alert, 2 critical, 3 for errors, 4 is for warning, 5 is for notice, and 6 is for information as in this case, and 7 is for debug. Question number 10. Which protocol does an access point use to draw power from a connected switch? And the options are option A, Internet Group Management Protocol, option B, Adaptive Wireless Path Protocol, option C, Cisco Discovery Protocol, and option D, Neighbor Discovery Protocol. And the correct option is option C, CDP or Cisco Discovery Protocol. So the Cisco Discovery Protocol, CDP, is a proprietary protocol used by Cisco devices to discover neighboring devices on a network. It also provides information about the capabilities of these devices, including the power capabilities of switches. Access points can use CDP to request power from a connected switch. 7. Refer to the exhibit. To which device does router 1 second send packets that are destined to host 10.10.13.165? And the options are option A router 2, option B router 3, option C router 4, and option D router 4. We have the router R1 over here, and this is the routing table of R1. So in order to reach this host, that is 10.10.13.165, where would router 1 send the packets? To which router will R1 send the packets, to R2 or 3 or 4? Or first look at the routes, and we will try to find out the routes that contains this host address. So this 10.10.13.0/25, now this range is from 0 to up to 1 to 7. So this route is excluded. Again, this route is also excluded because this range is up to 144 or 143. Again, this is again excluded. It is up to 159. This route actually contains the host address 165 10.10.13.25, and the route is 10.10.13.160/29, and it is accessible via the hop 10.10.10.5, and the interface is gigabit Ethernet 0/1. So where is the 10.10.10.5? We need to find this hop, and this hop is basically this one, 10.10.10.4/30, means that we have .5 address over here. That's why the router R1 will send the packet to R3 in order to reach this host, that is 165. So the correct option is router R3, and this is the again the explanation that this route is 160/29 is accessible with via this hop 10.10.10.5. This the subnet of this hop is /29, and the range is from 160 up to 167. So this definitely include the host 165. So that's why the router R1 will send the packet to R3 in order to reach 165. Question number 12. Which networking function occurs at the data plane? And the options are option A, forwarding remote client server traffic, option B, facilitates spanning tree elections, option C, processing inbound SSH management traffic, and option D, sending and receiving OSPF hello packets. And the correct option is that the function that occurs at the data plane in these options is the forwarding remote client and server traffic. So the data plane is responsible for forwarding packets or frames based on decision made by the control plane. It means that decision or the routing protocol calculations are made at the control plane, and then these decisions are basically installed inside the forwarding or data plane where the packets are readily forwarded. So the other options relate to control plane functions. So the like the management of management traffic and protocol exchanges, these are control plane functions. Question number 13. Which two tasks must be performed to configure an NTP to a trusted server in client mode on a single network device? We are talking about network time protocol, and the options are, you have to choose two options. Option A, enable NTP authentication. Option B, verify the time zone. Option C, disable NTP broadcast. Option C, specify the IP address of the NTP server. And option E, set the NTP server private key. And the correct options are option A, enable the NTP network time protocol authentication. And the second correct option is that specify the IP address of the NTP server. So to configure NTP in client mode to a trusted server or a network device, the following two tasks must be performed. Number one, enable NTP authentication. This ensures that the NTP client only accepts time updates from a trusted server by using authentication keys. And the second option is that specify the IP address of the NTP server. The client needs to know the specific NTP server's IP address to synchronize its time with it. Question number 14. Where does a switch maintain DHCP snooping information? And the options are option A, in the MAC address table, option B, in the CAM table, option C, in the binding database, and option D, in the frame forwarding database. And the correct option is option C, in the binding database. So a switch maintains DHCP snooping information in the binding database. This database contains details about IP address and MAC address bindings, as well as the associated VLAN and interface information. Question number 15. Refer the exhibit. This is the exhibit. Here we have a configuration on switch 1. That is the configuration of Ethernet gigabit 01. So we have interface gigabit 01. It is switch port access VLAN 11, and we have switch port trunk allowed VLAN 1 to 10. So these VLAN are allowed on the interface 01 in trunk mode. Switch port trunk encapsulation .1 queue and switch port trunk native VLAN 5. So we have configured native VLAN as VLAN 5, and switch port mode trunk speed 1000 Mbps, and it is in full duplex mode. The question is that what action is expected from switch 1 when the untagged frame is received on the gigabit Ethernet 0/1 interface. We are talking about this interface that contains this configuration. When this interface receives an untagged frame, what would be the behavior of the switch and the interface? And the options are option A, the frame is processed in VLAN 5. Option B, the frame is processed in VLAN 11. Option C, the frame is processed in VLAN 1. And option D, the frame is dropped. And the correct option is, since we are talking about the untagged frame, and untagged frame is always processed in the native VLAN, and native VLAN is VLAN 5, so the frame is processed in VLAN 5. So based on this configuration, when an untagged frame is received on the gigabit Ethernet 01 interface, it will be processed in the native VLAN, which is VLAN 5. Question number 16, refer the exhibit. Again, this is the exhibit. A network administrator assumes a task to complete the connectivity between PC A and the file server. So here, like this is PCA and this is file server, and we want to ensure connectivity between them, and there is PCA is connected to switch A while PCB is connected to switch B. Server switch A and switch B have been partially configured with VLAN 10, 11, 12 and 13. What is the next step in the configuration? We have this configuration on switch A. We have VLAN 10, 11, 12, 13 and interface gigabit 01. This interface is configured as trunk, and VLAN 10 to 12 are allowed on this trunk port. This is switch A. And on the interface gigabit 04, we are talking about this interface here. The PCA is connected. This interface is in switch port access VLAN 13 switch port mode access. So this interface is in VLAN 13. It means that this PC is connected to VLAN 13. And on the switch B, again we have interface gigabit Ethernet 01 switch mode port trunk. Again, this port is in trunk mode. Interface gigabit Ethernet 03. This is 03 interface to which the file server is connected. And again, the file server is placed in VLAN 13 in the same manner as the PCA. So this is the configuration. In order for PCA to communicate with the file server, both are in VLAN 13. What configuration must be done on these two switches so that PCA can communicate with file server? And the options are: option A, add PCA to VLAN 10 and the file server to VLAN 11. Option B, add VLAN 13 to the trunk links on switch A and switch B for VLAN propagation. Option C, add a router on a stick between switch A and switch B, allowing for inter-VLAN routing. And option D, add PCA to the same subnet as the file server, allowing for intra-VLAN communication. And the correct option is option B, add VLAN 13 to the trunk links on switch A and switch B for VLAN propagation. So since these both devices, the file server and PC are in VLAN 13, we need to propagate VLAN 13 on this trunk link, that is gigabit 0/1. So VLAN 13 must be added to this trunk link. Here we can see that we have added only VLAN 10, 11, 12. We'll also need to add VLAN 13 here, as well as we need to add VLAN 13 to this link as well, and this will do the job. Question number 17. Which goal is achieved by the implementation of private IP version 4 addressing on a network? And the options are: sorry, let me rephrase the question. So, which goal is achieved by implementation of private IP version 4 addressing on a network? The private IPv4 addresses are RFC 191 addresses that we have studied already. These are 10/8, 192.168/16, and 172.16/12. These are the private IPv4 address scheme. And what is the purpose of these using these addresses? And the options are: option A, provides an added level of protection against internet exposure. Option B, provides a reduction in size of the forwarding table on network router. Option C, allows communication across the internet to other private networks. And option D, allows servers and workstations to communicate across public network boundaries. And the correct option is that they are basically able to provide an added level of protection against internet exposure. So let me explain how does this work. So let's suppose this is a router, and one link of this is connected to basically ISP and the internet. So this is the internet, while on the other link we have, let's suppose, this switch, and to this switch we have client that are connected over here. This is basically LAN, and these clients have, let's suppose, IP addresses 192.168.1.10. Let's suppose this client and this client have IP address of 192.168.1.1. Let's suppose 1.20. Okay, let me get back a bit. So these IP addresses basically are not routable over the internet. This router will have a public IP address, let's suppose 8.10.9.11. Okay, so whenever the private IP addresses want to access the internet, the traffic will come to this router, and the private IP addresses will basically be translated to this 8.10.9.11. When a packet moves to the internet, the source address will be this one. The destination may be any internet destination such as YouTube, Google. That's why we say that these addresses are private, they are not exposed over the internet, and this gives us an added security. Explanation is that the private IP version 4 addresses defined in RFC 1918 are not routable on the internet. This means devices using private addresses are not directly exposed to external threats from the internet, providing a layer of security. While there are secondary benefits such as the conservation of public IP addresses and reduction of forwarding table size, the main purpose is to enhance security by preventing direct access from external networks. Question number 18, refer to the exhibit. This is the exhibit. Router R1 is running three different routing protocols. Which route characteristic is used by the router to forward the packets when it receives for destination 172.16.32.1? In the option are option A longest prefix, option B metric, option C cost, and option D administrative distance. So this is R1. This is the routing table of R1, and the routing table contains routes from three different routing protocols, and the routes are 32.0/27/19/24. So basically this host is accessible through all these three routes. So which route will be selected and why? These are the different criteria on which you can select route: the longest prefix, metric, cost, and administration distance. And the correct option is that the first most criteria to select a best route is the longest prefix. So in this case, which route will be selected? This one. Since this route has this longest prefix, that's why this route will be selected. Let me get to the explanation and explain further this concept. So this is very important. You may expect multiple questions on the route selection in your exam. So please pay close attention. So look at the prefix length first. So when selecting a route, first of all, look at the prefix length. If you have one that is longer than the rest, choose that as an answer, such as in this case. If there is more than one with the same longest prefix, if you have two routes with the similar prefix length, then you should go to the next criteria, move over to the AD, that is administrative distance, and pick the route with the lowest administrative distance. Once again, if you have duplicate administrative distances in the routes, then you should move to the next criteria, that is the metric. So in this example provided, the routes have the following administrative distances. So this route has this 90, and this the second is 110, and the third one is 120. So each routing protocol has a Certain administrative decisions such as 90 is for EIGRP, 110 is for OSPF, and 120 is for BGP. A quick question, what is the administrative distance for static route? I think it is 10. And in the example provided, the routers have the following matrix. So these are the matrix. So let me get back. So these first numbers, these basically shows the administrative distances, while the second number they are the matrix. So in our case, we chose the route at the first criteria, that is the longest prefix, since this route is the longest prefix with no other competitor. So if we had two routes, let's suppose if we had 27 over here as well, then we would have moved to the administrative distance, and again we would have selected the same routes because the AD of this route, that is 90, is less than 110. And the third criteria would have been the metric. The route with the lowest metric would be selected first. So I hope you people get the concept. Question number 19. What are two benefits of network automation? Choose two. And the options are option A, reduced operational costs, option B, reduced hardware footprint, option C, faster changes with more reliable results, option D, fewer network failures, and option E, increased network security. And the correct options are option A, reduced operational costs, and the second correct option is option C, faster changes with more reliable results. The explanation is that the two benefits of network automations are: number one, reduced operational costs. Automating network tasks can decrease the need for manual intervention, leading to lower labor costs and more efficient use of resources. The second correct option is the faster changes with more reliable results. So network automation allows for quicker deployment of changes and configuration, reducing the potential for human error and increasing the reliability of the results. Question number 20. When a site-to-site VPN is used, which protocol is responsible for the transport of user data? And the options are option A, IKE version 2, option B, IKE version 1, option C, IPsec, and option D, MD5. And the correct option is option C, IPsec, that is IP security. So IPsec, that is Internet Protocol Security, is used to secure Internet protocol communication by authenticating and encrypting each IP packet in a communication session. It provides the necessary framework to protect user data over the VPN. iKey version 1 and iKey version 2, that is Internet Key Exchange version 1 and version 2, are protocols used to set up the secure communication channels and manage the encryption keys, but they do not directly transport user data. MD5 is a hashing algorithm used for integrity checks but is not responsible for data transport. Question number 21. What is the primary function of a layer 3 device? And the options are option A, to analyze traffic and drop unauthorized traffic from the internet. Option B, to transmit wireless traffic between hosts. Option C, to pass traffic between different networks. And option D, forward traffic within the same broadcast domain. And the correct option is that the layer 3 device is basically used to pass traffic between different networks, and this is performed through routing. When you have different networks, you need a router or routing to exchange packets between these two different networks. By different networks, we means networks having different IP subnets, such as 192.168.1.0/24 and 10.10.10.0/24. These are two different networks. In order to make communication between these networks, you need routing or a layer 3 device. So layer 3 devices operate at the network layer of the OSI model where they manage routing of packets between different IP networks. They use IP addressing to determine the best path for forwarding traffic across various networks. While layer 3 devices can analyze and filter traffic related to option A and may interact with wireless traffic that is related to option B, their main purpose is routing between different networks. Option D refers to functions that are typical of layer 2 devices, like switches that operate within the same broadcast domain. Question number 22. Router A learns the same route from two different neighbors. One of the neighbor routers is an OSPF neighbor and the other is an EIGRP neighbor. What is the administrative distance of the route that will be installed in the routing table? And the options are option A 20, option B 90, option C 110, and option D 115. So we studied the administrative distance of OSPF and EIGRP a while ago. So the uh, protocol with the lowest administrative distance will be selected. That's why the correct option is 90, and 90 is the administrative distance from EIGRP, while 110 is the administrative distance of OSPF. So in this scenario, router A learns the same route from two different neighbors using different routing protocols that are OSPF and EIGRP. Each routing protocol has a predefined administrative distance that determines its trustworthiness compared to two other protocols. The administrative distance for the relevant protocols are for OSPF, that is Open Short Test Path First, it is 110, and for EIGRP Enhanced Interior Gateway Routing Protocol, it is 90. Since EIGRP has a lower administrative distance of 90 compared to OSPF of 110, the route learned from the EIGRP neighbor will be preferred and installed in the routing table. Question number 22. When the active router in an HSRP group fails, what router assumes the role and the forwarding and forwards the packets? And the options are option A backup, option B standby, option C listening, and option D forwarding. And the correct option is option B standby. The standby router is the one designated to take over the forwarding role in case the active router fails. It monitors the active router and will take over as the active router if it detects a failure. The backup terminology is not used in HSRP. The standby router is the correct term. The listening state refers to a router that is aware of the HSRP group but is not currently the active or standby router. Forwarding is not a specific state in HSRP terminology but refers to the action of sending packets when a router is active. Question number 24. Which two protocols must be disabled to increase security for management connection to a wireless LAN controller? Choose two options. And the options are option A Telnet, option B SSH, option C HTTP, and option D HTTPS, while option E is TFTP. So we are talking about disabling two of the protocols over here to increase the security, and the correct options are option A Telnet. It is because the traffic sent through Telnet is in plain text, it is not encrypted, and again in the same manner the traffic of HTTP is also not encrypted, it is in the plain text. The secure version of Telnet is basically SSH. In SSH, the traffic is encrypted, while the secure alternative of HTTP is HTTPS. Question number 25. When a client and server are not on the same physical network, which device is used to forward requests and replies between client and server for DHCP? That is Dynamic Host Configuration Protocol. And the options are option A, DHCP Relay Agent, option B, DHCP Server, option C, DHCP Discover, and option D, DHCP Hopper. And the correct option is option A, DHCP Relay Agent. So when a client and server are not on the same physical network, a DHCP relay agent is used to forward DHCP requests and replies between the client and the DHCP server. The relay agent acts as an intermediary, translating the DHCP messages between the client and server and ensuring that they are properly routed. So this is how the DHCP relay agent works. So we have a client which is on a network 192.168.2.0 while the DHCP server is on a different network 192.168.1.0 and they are also physically separated. So a DHCP relay agent between them is needed so that the request and responses between the client and the server are propagated. Question number 26. Protocol requires authentication to transfer a backup configuration file from a router to a remote server. The options are option A DTP, option B FTP, C SMTP, and option D TFTP. And the correct option is option B FTP file transfer protocol. And the explanation is that the file transfer protocol requires authentication, that is username and password, to transfer files such as backup configuration files between a router and a remote server. DTP, that is Dynamic Trunking Protocol, is used to negotiate trunking between switches. SMTP, that is Simple Mail Transfer Protocol, is used for sending emails. And TFTP, that is Trivial File Transfer Protocol, does not require authentication but is less secure. Question number 27. An engineer must configure traffic for a VLAN that is untagged by the switch as it crosses a trunk link. Which command should be used? And the options are option A switch port trunk allowed VLAN 10, B switch port trunk native VLAN 10, option C switch port mode trunk, and option D switch port trunk encapsulation .1 Q. And the correct option is option B switch port trunk native VLAN 10. So the command switch port trunk native VLAN 10 is used to configure the native VLAN for a trunk link. The native VLAN is untagged as it crosses a trunk link while other VLANs are tagged. This command ensures that traffic for VLAN 10 is sent untagged across the trunk. Option A, that is switch port trunk allowed VLAN 10, specifies which VLANs are allowed on the trunk but does not affect whether the VLAN is tagged or untagged. Option C, switch port mode trunk, simply sets the port to trunk mode. And option D, switch port trunk encapsulation.q sets the encapsulation type but does not address native VLAN configuration. Question number 28. Why does a switch flood a frame to all ports? And the options are option A, the frame has zero destination MAC addresses. Option B, the source MAC address of the frame is unknown. Option C, the source and destination MAC addresses of the frame are the same. And option D, the destination MAC address of the frame is unknown. And the correct option is that a switch floods a frame to all ports when the destination MAC address of the frame is unknown. So the explanation is that a switch floods a frame to all ports when the destination MAC address is not present in its MAC address table. This is because the switch does not know which port to forward the frame to, so it sends the frame to all ports except the one it was received on. Once the switch learns the destination MAC address by observing the response, it will update its MAC address table and forward future frames to the correct port. Question number 29. A network administrator enabled port security on a switch interface connected to a printer. What is the next configuration action in order to allow the port to learn the MAC address of the printer and insert it into the table automatically? And the options are option A, enable dynamic MAC address learning. Option B, implement static MAC addressing. Option C, enable sticky MAC addressing. And option D, implement auto MAC address learning. And the correct option is option C, enable sticky MAC addressing. And the explanation for this option is that enabling sticky MAC addressing allows the switch port to dynamically learn the MAC address of the connected device, in this case the printer, and automatically add it to the running configuration as a secure MAC address. This way the MAC address is learned dynamically, but once it is learned, it is stuck in the configuration to ensure the device's MAC address is secure. A and D are incorrect because there are no specific commands for dynamic or auto MAC address learning in this context. Sticky MAC address serve this purpose. Option B is incorrect because static MAC addressing would require manually entering the MAC address into the configuration, not learning it dynamically. Question number 30. Where is the interface between the control plane and the data plane within the software-defined architecture? And the options are option A, control layer and the infrastructure layer. Option B, application layer and the infrastructure layer. Option C, application layer and the management layer. And option D, control layer and the application layer. So the interface between control and data plane is at the control layer and the infrastructure layer. So in a software-defined architecture, the control plane is responsible for managing the network's routing, forwarding, decision, and policies, while the data plane handles the actual forwarding of packets. The interface between the control plane and the data plane is found between the control layer, which contains the control logic, and the infrastructure layer, which includes the networking hardware that forwards the data. This separation allows for centralized management of network devices while distributing the data forwarding across multiple devices. And this is how the SDN architecture looks like. So we have this infrastructure layer, and data plane basically lies over here. And this control layer where the control plane lies. So the interface between the control plane and data plane is actually it is the between the control layer and the infrastructure layer. Question number 1. Which type of organization should use a collapsed core architecture? And the options are option A, large and requires a flexible, scalable network design. Option B, large and must minimize downtime when hardware fails. Option C, small and needs to reduce networking costs currently. and option D, small but is expected to grow dramatically in the near future. And the correct option is that the collapse architecture is required to be used by small that needs to reduce networking costs currently. And this is how the collapse architecture looked like. So basically we have a three-tier network architecture in which we have three tiers of access, distribution, and core. And in the collapsed core, we combine the core and distribution into a one layer, that is core. So basically, we reduce the hardware footprint. Here we can see that in this case, we have two routers in the distribution and two in the core, while in the collapsed, we have only two router in the collapsed core. So in this way, this architecture is suitable for small organization because it reduces the hardware footprint as well as the management and operational as well as upfront costs. Question number 2, which plane is centralized by an SDN controller? We are talking about software defined networking controller. Which plane is centralized by the SDN controller? And the options are option A, management plane, option B, control plane, option C, data plane, and option D, services plane. And the correct option is option B, control plane. So this is the explanation. So in software defined networking, SDN, the control plane is centralized and managed by the SDN controller. The controller makes decisions about how packets should be handled and then sends instructions to the network devices, which act upon those instructions in the data plane. The data plane, also known as the forwarding plane, is decentralized and exists in network devices like switches and routers, where the actual packet forwarding happens based on the rules provided by the control plane. The management plane handles device management and monitoring, which is typically still decentralized, so an SDN controller can provide insights into it. The services plane refers to the higher level services in the network, but it is not directly managed by the SDN controller in terms of packet forwarding and routing decisions. So this is how the SDN architecture looks like. Here we can see that the control plane is basically centralized by the controller. Traditionally, a network device such as switch contained both the control plane as well as the data plane. While in SDN, the control plane is centralized in one plane inside the controller, while the data plane is distributed. So each of these switches, they contain basically data plane, while the control plane is only available centralized inside the controller. Question number 3, an implementer is preparing hardware for virtualization to create virtual machines on a host. What is needed to provide communication between hardware and virtual machines? And the options are option A, hypervisor, option B, router, option C, straight cable, and option D, switch. And the correct option is hypervisor. This is what this is how hypervisor looks like. So we have the hardware, and in order to do virtualization and install virtual machine on this hardware, we need the hypervisor. So basically, hypervisor is an operating system. You can call it the virtualization operating system or virtualization OS. And when you install this hypervisor on the bare metal hardware, it enables you then to install virtual machines over the hypervisor, and it gives you the capability to provide the hardware to these virtual machines as per the requirements. And then, unlike the traditional hardware where you only installed one operating system on a server, you can then install multiple virtual machines, and each machine can have different operating systems. So that's the beauty of virtualization, and this is made possible through the hypervisor. Question number 4. Which quality of service tool is used to optimize voice traffic on a network that is primarily intended for data traffic? And the options are option A FIFO, option B WFQ, option C PQ, and option D WRED. And the correct option is that the PQQS tool is used to optimize the voice traffic over the network that is optimized or intended for data traffic. So PQR priority queuing is a quality of service tool that gives higher priority to certain type of traffic, such as voice, ensuring that this traffic is processed before other types of traffic. This is especially useful in networks that are primarily intended for data but need to optimize the performance of voice traffic, which is sensitive to delay and jitter. So the voice traffic is prioritized because the voice conversation is required in real time. The data such as the email or other type of data may be delayed, but the voice must receive in real time. Otherwise, the conversation or voice communication doesn't make sense. Question number 5. What are two characteristics of a controller-based network? So again, we are talking about software-defined networking, and we have to choose two options of the SDN, two characteristics of the SDN, and the options are option A. The administrator can make configuration updates from the CLI. Option B, it uses northbound and southbound APIs to communicate between architectural layers. Option C, it moves the control plane to a central point. Option D, it decentralizes the control plane, which allows each device to make its own forwarding decision. And option E, it uses telnet to report system issues. And the correct options are that the controller-based network or SDN uses northbound and southbound APIs to communicate between architectural layers, and it moves the control plane to a central point. So this is how the controller-based network or SDN architecture looks like. So the two characteristics or two properties of this network architecture is that it uses northbound and southbound APIs. So the southbound API is used by controller to talk with the architecture or data layer, or used by the controller to talk with these network devices that are basically, which is our layer 3 devices or router. And the southbound API is used by the controller to talk with the applications that are in application layer. And the second characteristic of this is that the control plane is centralized by the controller. So the data plane is decentralized, as we already discussed in the previous question. The data plane is available in all these switches. So it is in fact not centralized at a central device but is decentralized, while the control plane, it is centralized and available inside this controller. So that are the two main characteristics of the controller-based network or software-defined network. Question number 6. What is the benefit of configuring port fast on an interface? And the options are option A. After the cable is connected, the interface uses the fastest speed setting available for that cable type. Option B. After the cable is connected, the interface is available faster to send and receive user data. Option C. The frames entering the interface are marked with higher priority and then processed faster by a switch. And option D. Real-time voice and video frames entering the interface are processed faster. And the correct option is that when port fast is configured on an interface, it has the effect that after the cable is connected, the interface is available faster to send and receive user data. And how this is done? So basically, the port fault is a Cisco feature that allows an interface to bypass the standard spanning tree protocol states, including the listening and learning, and transition immediately to the forwarding state when a device is connected. This reduces the time the port takes to become active and able to send and receive user data. It's commonly used for end-user devices like PCs or servers to ensure quick connectivity after a cable is plugged in or a device is rebooted. Question number 7. A router R1 has learned route 192.168.12.0/24 via ISIS, OSPF, and RIP routing protocols and internal EIGRP under normal operating conditions. Which routing protocol is installed in the routing table? So a route that is 192.168.12.0 is learned through 4 routing protocols, including ISIS, OSPF, RIP, and internal EIGRP. So which routing protocol route will be actually installed in the routing table? And the options are again the 4 routing protocol. Option A, ISIS, option B, RIP, option C, internal EIGRP, and option D, OSPF. And the correct option is option C, internal EIGRP. And why this routing protocol will be selected? So this is the explanation. When a router learns the same route from multiple routing protocols, it selects the route with the lowest administrative distance for the routing table. Here's the default administrative distance for the mentioned protocol. So for the internal EIGRP, it is 90. For OSPF, it is 110. For ISIS, it is 115, and for RIP, it is 120. Since internal EIGRP has the lowest administrative distance, it will be used for installing the route inside the routing table. So since internal EIGRP has the lowest administrative distance, it is the protocol that will install the route onto the routing table under normal operating conditions. Question number 8. What is the capability of FTP, File Transfer Protocol, in network management operations? And the options are option A, it encrypts data before sending between resources. Option B, devices are directly connected and use UDP to pass file information. Option C, uses separate control and data connections to move files between server and client. And option D, offers proprietary support at the session layer when transferring data. And the correct option is that the FTP uses separate control and data connections to move files between server and client. So the FTP file transfer protocol uses 2 separate connections. One is control connection that is used to send commands and responses on port 21, and the other is data connection that is used to transfer the actual files on port 20. This separation allows FTP to manage the control flow independently from the actual data transfer. And this is how the FTP looks, FTP connection looks like between an FTP client and an FTP server. So it basically maintains 2 connections. One is for, as we studied, for data, and the other is for control. So the data, let me get that. Yes, the data link or the data connection uses port 20 on the server, while the control connection, it uses port 21 on the server. Question number 9. Which type of API allows SDN controller to dynamically make changes to the network? We already studied about the northbound and southbound APIs. So the question is that which of those APIs actually allows SDN controller to make changes to the network? And the options are option A, northbound API, option B, REST API, option C, SOAP API, and option D, southbound API. And the correct option is Option D, southbound API, and this is how it's look like. This is the southbound API that is used by the controller to make changes to these network devices inside the infrastructure or data plane layer. Question number 10, refer to the exhibit. So this is the exhibit. Which next hop IP address does router, it is basically router use for packets destined to the host 10.10.13.158. So we have a destination host of this 158. So which next hop is used to reach this destination? And we have these next hops 10.10.10.5 in option B, 10.10.11.2 in option C, 10.10.12.2 in option D, 10.10.10.9. So if we look at these routes, we will first need to determine that where this uh, uh, data, where this host is reachable, that this host is reachable through which route. And if we see it is not reachable through this because this route ranges from 0 up to 1 to 7. It is also not reachable through this because it ranges from 1 to 8 up to 143. It is actually reachable through this because this route ranges from 144 up to I think 159, and the next hop is basically this dot 9. The correct option is basically that this host is reachable through the next hop 10.10.9 because the route that make this host reachable is through this next hop. So this is the explanation that this subnet 10.10.13.144, this one, it has this 144 broadcast address, 15 network address, and 159 is broadcast address, and the range is from 145. Usable host range is from 145 up to 158. So 158 is the actual host IV that is available in this route, and that why this host is available through this next hop that is dot 9. Question number 11, which WLC, that is wireless LAN controller management connection type, is vulnerable to man-in-the-middle attacks? And the options are option A, SSH, option B, HTTPS, option C, Telnet, and option D, console. We are talking about these are all basically, this protocol can be used for management, remote management. SSH traffic is basically encrypted. HTTPS traffic is also encrypted. Telnet sends traffic in plain text. It is not encrypted. Console traffic is basically not sent over the network. Console is when you connect to the device directly through the console port. So the basically the telnet is susceptible or vulnerable to man-in-the-middle attack because it sends traffic in clear text. As we can see in this, if this user or administrator is using telnet and configuring this device, when the user, let's suppose he or she enable the password, let's suppose Cisco on this device, this password can be eavesdropped or can be seen by the man in the middle because the text is sent in clear. Question number 12, which action is taken by the data plane within a network device? And the options are option A, forwards traffic to the next hop. Option B, constructs a routing table based on a routing protocol. Option C, produces CLI access to the network device. And option D, looks up an egress interface in the forwarding information base. And the correct option is that the data plane basically forwards traffic to the next How? So the data plane, also known as the forwarding plane, is responsible for the actual forwarding of packets to their destination based on the information contained in the forwarding table or forwarding information base. It processes the incoming packets and decides where to send them next. Question number 13. Which characteristic differentiates the concept of authentication from authorization and accounting? And the options are option A, user activity logging, option B, service limitations, option C, consumption based billing, and option D, identity verification. And the correct option is that the authentication is different from authorization and accounting because authentication is used for identity verification. So authentication is the process of verifying the identity of a user, device, or system, ensuring that the entity requesting access is who it claims to be. This is distinct from authorization, which determines what an authenticated user is allowed to do, service limitation, and accounting, which involves tracking user activities such as user activity logging and often includes aspects like consumption-based billing. Question number 14. Which value is the unique identifier that an access point uses to establish and maintain wireless connectivity to wireless network devices? The options are option A, VLAN ID, option B, SSID, option C, RFID, option D, wireless LAN ID. And the correct option is option B, SSID. So the SSID, that is service set identifier, is the unique identifier or name used by an access point to establish and maintain wireless connectivity with wireless network devices. It is essentially the network name that clients see when they search for available Wi-Fi networks. Question number 15. Refer the exhibit. This is the exhibit. We have these routing protocol and they have installed the routes or learned these routes via these interfaces. Each routing protocol has learned their corresponding routes to respective interfaces. So the question is, packets received by the router from BGP enter via serial interface at 209.165.21.1. Each route is present within the routing table, which interface is used to forward traffic with a destination IP of 10.1.1.19. So the question is that which interface is used, these are the interfaces, to forward the traffic to this destination. And if we see that this destination 1.19 is available in this route, it is also available in this route, it is not available in this route, and it is also available in this route. So the uh, route that will be used to forward or to reach this host or the interface that will be used is basically this one, and the reason is that this route contains the longest prefix. So that's why the correct option is basically the interface F0/0, and the reason is the longest prefix. Remember, the first criteria to select a route is to select the route with the longest prefix. The second criteria is, let me list them down. The first one is longest prefix. This is very important and you may encounter multiple questions inside your exam. This is also important in your practical networking. The second is smallest AD or smallest administrative distance. So In this case, the EIGRP has the smallest administrative distance. If all the routes were having the same prefix, then we would have selected the EIGRP route because it has the shortest or smallest administrative distance. And the third one is the third criteria. If there is a tie between these two, then the third one is smallest metric. So this number is basically the metric. So in this case, if all the routes were having the same prefixes, and let's suppose if they were from the same routing protocol and their AD were the same, then we would have selected this route because it has the smallest metric. So I hope this is clear. This concept is very important, and you people should remember this priority criteria for selecting the route. Question number 16. Which protocol uses the SSL? SSL is Secure Socket Layer. In the options are option A, HTTP, option B, SSH, option C, HTTPS, and option D, Telnet. And the correct option is option C, HTTPS. So the HTTPS, Hypertext Transfer Protocol Secure, is a secure version of HTTP that uses SSL Secure Sockets Layer to encrypt and decrypt data transmitted between a web server and a web browser. This ensures that data is protected from eavesdropping and tampering. Question number 17. Which two spanning tree states are bypassed on an interface running port fast command? And we have to choose two options. We already studied this type of question. The options are option A, disabled, option B, listening, option C, forwarding, option D, learning, and option E, blocking. And the correct option is option B, listening, and option D, learning. So when a port or an interface is configured as port fast, these two states are kept by the interface when it is connected to the device, and the interface directly changes its state to the forwarding states without first going into these two states. So that's why it is called fast. Remember, it transitions fast because it skips these two states. So when port fast is enabled on an interface, it allows the port to skip the listening and learning states of the spanning tree protocol and immediately transition to the forwarding state. This is particularly useful for ports connected to end devices such as computers or printers to allow them to access the network more quickly. Question number 18. Refer to the exhibit. This is the exhibit. The link between PC1 and the switch is up. We are talking about this link, but it is performing poorly. Which interface condition is causing the performance problem? And the options are option A, there is a duplex mismatch on the interface. Option B, there is an issue with the fiber on the switch interface. Option C, there is a speed mismatch on the interface. And option D, there is an interface type mismatch. And the correct option is option A, there is a duplex mismatch on the interface. We can see that on the PC side, the interface is in full duplex mode, while on the switch, the interface is configured as auto. So how this creates a problem? So a duplex mismatch occurs when two connected devices are configured in different duplex modes. This may happen, for example, if one is configured for auto negotiation while the other one has a fixed mode of operation that is full duplex. No auto negotiation. In such conditions, the auto negotiation device correctly detects the speed of operation but is unable to correctly detect the duplex mode. As a result, it sets the correct speed but assumes half duplex mode When a device is operating in full duplex while the other one operates in half duplex, the connection works reliably only at a very low throughput. Question number 19. Which PoE mode, that is power over Ethernet mode, enables powered devices detection and guarantees power when the device is detected? The options are option A dynamic, option B static, option C active, and option D auto. And the correct option is option B static. Question number 20. What is an expected outcome when network management automation is deployed? And the options are option A distributed management plane must be used. Option B, software upgrades are performed from a central controller. Option C, complexity increases when new device configurations are added. And option D, custom applications are needed to configure network devices. And the correct option is that in network management automation, software upgrades are performed from a central controller. So when network management automation is deployed, one of the expected outcomes is that software upgrades and other management tasks can be performed from a central controller. This centralization streamlines operations, enhances consistency, and reduces the time and effort needed to manage network devices. Question number 21. Which two components comprise part of a PKI, that is public key infrastructure? Choose two, and the options are option A pre-shared key that authenticates connections, option B RSA token, option C CA, that is certification authority that grants certificates, option D clear text password that authenticates connection, and option E one or more CRLs, or that is certification revocation list. And the correct options are that the two components of PKI are CA, a certification authority that grants certificate, and one or more CRLs. So a PKI public key infrastructure is a system that provides cryptographic services. It consists of several components including the certificate authority, that is CA, an entity that issues digital certificates. These certificates verify the identity of a person or device and contain public keys. And the certificate revocation list, that is CRL, a list of certificates that have been revoked. This is important because certificates can be compromised or lost. Question number 22. What causes a port to be placed in the error disabled state? And the options are option A, nothing plugged into the port. When nothing is plugged into the port, option B, link flapping, option C, shutdown command issued on the port, and option D, latency. And the correct option is that the link flapping causes the port to be placed in the error disabled state. So link flapping occurs when a network link repeatedly goes up and down. This can be caused by various factors such as physical cable damage, faulty network devices, or software glitches. When a port experiences excessive link flapping, it may be placed in the error disabled state to prevent further disruptions to the network. Question number 23. Which layer 2 switch function encapsulates packets for different VLANs so that the packets traverse the same port and maintain traffic separation between the VLANs? And the options are option A VLAN numbering, option B VLAN DSCP, option C VLAN tagging, and option D VLAN marking. and the correct option is VLAN tagging. So VLAN tagging is a layer 2 function that encapsulates packets with VLAN information, allowing multiple VLANs to share the same physical port while keeping their traffic separated. This tagging is typically done using IEEE 802.1q, which inserts a tag into the Ethernet frame to identify the VLAN. VLAN numbering, VLAN DSCP, and VLAN marking do not specifically refer to the encapsulation of packets for VLAN traffic separation on the same port. Question number 24. Which two network actions occur within the data plane? Choose two options. And the options are option A, add or remove an 802.1q trunking header. Option B, make a configuration change from an incoming netconf or PC. Option C, run routing protocols. Option D, match the destination MAC address to the MAC address table. And option E, reply to an incoming ICMP echo request. And the correct options are option A, add or remove an 802.1q trunking header. And the second correct option is option D, match the destination MAC address to the MAC address table. And the explanation is that the control plane handles actions such as option B, that is making configuration changes, and C, that is running routing protocol. So the B and C are basically the control plane functions which are not directly involved in forwarding packets. Option E, replying to an incoming ICMP echo request, is a function of the data plane, but in this case, the correct answers are focused on packet forwarding. That's why the correct answers are A and D. Question number 25. Which QoS or quality of service traffic handling technique retains excess packets in a queue and reschedules these packets for later transmission when the configured maximum bandwidth has been surpassed? And the options are option A, weighted random early detection. Option B, traffic policing. Option C, traffic shaping. And option D, traffic prioritization. And the correct option is option C, traffic shaping. What is traffic shaping? Traffic shaping is a quality of service technique that manages network traffic to ensure that certain type of traffic receive a guaranteed level of bandwidth. When the configured maximum bandwidth is exceeded, excess packets are retained in a queue and rescheduled for later transmission. This helps to prevent network congestion and ensure that critical traffic is not delayed. Question number 26. Which interface mode must be configured to connect the lightweight access points in a centralized architecture? And the options are option A, wireless LAN dynamic, option B, management, option C, trunk, option D, access. And the correct option is option D, access. So in a centralized architecture, the lightweight access points typically connect to the controller through access mode interfaces. The access mode is used when the AP is on a specific VLAN and does not to carry multiple VLANs, which is common in most centralized wireless architectures where the AP only needs access to a management VLAN to communicate with the wireless LAN controller. Question number 27, refer to the exhibit. This is the exhibit. Which two commands must be configured on a router R1 to enable the router to accept secure remote access connections? Choose two options. And the options are option A, transport input telnet. Option B, crypto key generate RSA. Option C, IP SSH public key chain. Option D, login console. And option E, username Cisco, password 0, Cisco. And the correct options are option B, crypto key generate RSA. And option C, IP SSH public key chain. And the explanation is that for these two options, crypto key generate RSA, this command generates an RSA public private key pair on the router. The private key is used to decrypt data encrypted with the public key, while the public key is distributed to authorized users or devices. This is a fundamental step in setting up SSH. IP SSH public key chain. This command specifies the location of the public key chain file on the router. This file contains the public keys of authorized users or devices. When a user attempts to connect via SSH, the router compares their public key with the ones in the chain. If a match is found, the connection is allowed. Question number 28. Which type of network attack overwhelms the target server by sending multiple packets to a pod until the half-open TCP resources of the targets are exhausted? The options are option A, SYN flood, option B, reflection, option C, teardrop, and option D, amplification. So we are talking about denial of service attack, and in this case, the hint is that half-open TCP connection, and the correct option is SYN flood. So what is SYN flood? A SYN flood attack is a type of denial of service attack where the attacker sends multiple SYN packets to a target server's port. The server responds with a SYN ACK packets and waits for the client's ACK to complete the handshake, but the attacker never sends the acknowledgement. As a result, the server's half-open TCP connections remain unclosed, and eventually the resources are exhausted, preventing legitimate users from establishing connections. So this is how a TCP SYN flood attack look like, or you can say the SYN flood attack looks like. So we have the attacker, it has a bot, it sends spoof SYN packets to the target website. This means a web server or an application. Spoof means that the source IP addresses are spoofed to some random addresses, and the bot sends lot of SYN packets. The target responds to the spoofed source IP addresses. Since the addresses are spoofed, there is no, so the SYN act is three-way handshake is that you send a SYN, the server responds with a SYN act, and then the client sends the act packet to complete the three-way handshake. But in this case, this attack, the ACK response or the S packet is ACK packet is never sent because there are no legitimate clients to send the packets. And so the target is overwhelmed, all the resources are consumed. And when a legitimate user or client sends a SYN request or a request, the target denies the request because it has no more resources to oblige or respond to the legitimate user, and thus this attack becomes a denial of service for the legitimate clients. Question number 29. What is one reason to implement LAG, that is link aggregation group, on a Cisco wireless LAN controller? And the options are option A, to increase security and encrypt management frames. Option B, to provide link redundancy and load balancing. Option C, to allow for stateful and link state failover. And option D, to enable connected switch ports to failover and use different VLANs. The correct option is that the link aggregation group on a Cisco WLC is used to provide link redundancy and load balancy. So the link aggregation group or lag on a Cisco wireless LAN controller allows the bundling of multiple physical Ethernet links into one logical link. The primary benefit of implementing lag or link redundancy, that is, if one physical link in the bundle fails, the traffic is automatically redirected to the remaining links, ensuring continuous connectivity. The second benefit is load balancing. Traffic can be distributed across all available links in the lag, improving overall performance and throughput. And this is how it looks like. So this is the WLC or wireless LAN controller, and this is the switch. So we have multiple physical links that are bundled together through leg to form one logical link, and this helps in redundancy. So if one physical or two physical interfaces fail, there is no disruption to the services, and the traffic is distributed or forwarded across the remaining links. It also increases throughput. So let's suppose if these links are of 1G, then the four physical links means that we have a 4G throughput. So these are the benefits of forming link aggregation group on a Cisco wireless LAN controller. Question number 30. Which action implements physical access control as part of the security program of an organization? We are talking about physical access. And the options are option A, configuring a password for the console port. Option B, backing up syslogs at a remote location. Option C, configuring enable password on network devices. And option D, setting up IP cameras to monitor key infrastructure. And the correct option is option D, setting up IP cameras to monitor key infrastructure. The explanation is that physical access control involves measures that restrict or monitor physical access to systems, buildings, or sensitive areas. Setting up IP cameras allows for monitoring key areas, helping to prevent unauthorized access to critical infrastructure, which is a common method of implementing physical access control. Option A, that is configuring a password for the console port, and option C, that is configuring enable password on network devices, are logical access controls that secure access to devices via network interfaces, not physical access. Option B, that is backing up syslogs at a remote location, is a security measure related to a data integrity and disaster recovery, not physical access control. So that's all for this video. Please like, subscribe the video. I will upload the next video on CISCO CCNA practice question very soon. So stay tuned and see you soon.
Question number 1. Refer to exhibit. An engineer is asked to insert the new VLAN into the existing trunk without modifying anything previously configured. Which command accomplishes this task? So we have this exhibit and we can see that we have a trunk link, and this trunk link is already configured to pass through these VLAN, and these are 100, 101, 102 up to 103, and we have a new VLAN 104. So how will we add this VLAN to this trunk port without modifying or disturbing already configured VLANs? And the options are option A, switch port trunk allowed VLAN 100 to 104. So this shows the complete range 100, 101, 102, 103, and 104. Option B, switch port trunk allowed VLAN add 104. Option C, switch port trunk allowed VLAN all. And option D, switch port trunk allowed VLAN 104. And the correct command to accomplish this task is option B, switch port trunk allowed VLAN add 104. So this command will insert this VLAN or add this VLAN to the already trunk port that contains a VLAN up to 103. So this command adds VLAN 104 to the existing list of allowed VLANs on the trunk port without removing the current VLANs already allowed on the trunk. That are VLANs 100, 101, 102 and 103. The add keyword ensures that it only adds the new VLAN rather than overwriting the existing ones. Question number 2, refer to exhibit. Again, we have this exhibit. A static route must be configured on router R14 to forward traffic for the destination 172.21.34.0/25 network that resides on the R86, that is router 86. Which command must be used to fulfill the request? So we have this router R14 and router R86. So we want to configure a route on this router R14 so that we can reach a network that is available on the router R86, and the network or the destination is 172.21.0/25. Let me first go through the option and then I will explain the answer. So the options are option A, IP route 172.21.34.0 with the subnet mask 255.255.255.192, and the next hop is 1073.65.65. Option B, IP route 172.21.34.0 with the subnet mask 255.255.255.0, and the next hop is 10.73.65.65. Option C is IP route 172.21.34.0 and with the subnet mask 255.255.128.0, and the next hop is 10.73.65.64. And the option D is IP route 172.21.34.0 with the subnet mask 255.255.255.128, and the next hop is 10.73.65.66. So remember, to configure a static route, you must bear in mind three things. First is you just or forget about the command. The three things that you should remember is the first one is the destination network. So what is the destination network that we want to reach? It is 172.21.34.0. And then what is the subnet mask of this destination network? So the 25 can be written in the form of subnet mask as 255.255.128. This is the expression for /25. So this is the first requirement that you must understand, or you must identify the destination network, then the subnet mask, and the last and the important thing is the next hop. So what is the next hop? We are here and we want to reach this router because the network is connected to this router. So the next hop must be R86, this interface, and this interface IP address is 10.73.65.66. So the next hop is 10.73.65. 66. So overall command will be IP route. Sorry for my bad handwriting. And this, so this overall this matches with this option. So the correct option is option D. So again, this is the same explanation that I already explained. So the destination is this network. The net mask is 1 to 8 to match the /25 prefix of the network on R86. And the next hop is this 66, the IP address of the interface on R86, that is this one. Question number 3, which field within the access request packet is encrypted by the radius? So radius is the remote authentication protocol or service that is used to authenticate user when they want to log in on the network devices. And the options are, so the question here is that which packet is encrypted when this authentication takes place, and the options are option A, authorized services, option B, authenticator, option C, username, and option D, password. And the correct option is option D, password. So in radius, that is remote authentication dial-in user service, only the password field within the access request packet is encrypted. The encryption is done using a shared secret and an MD5 hash, but the rest of the packet, such as the username, is sent in plain text. This is why it's important to secure radius communication with additional protection, such as IPsec when sensitive data is transmitted. So another alternative to the radius is TechX Plus. In TechX Plus, both the username and password are encrypted, just for your information. Question number 4, a network engineer is configuring a switch so that it is remotely reachable via SSH secure shell. The engineer has already configured the host name on the router. Which additional command must the engineer configure before entering the command to generate the RSA key? So for the SSH, you need to generate the RSA key pair in order to encrypt the SSH communication. But before that, what is required? And the options are option A, password, option B, crypto key generate RSA modulus 1024, option C, IP domain name domain, and option D, IP SSH authentication retries 2. And the correct option is that before generating the RSA key, you should enter the command IP domain name domain. And this is the explanation. Before generating the RSA key for SSH, the network engineer must configure a domain name using the command IP domain name command. This is required because the RSA key is tied to both the host name and the domain name, and SSH relies on the key pair for secure remote access. For example, the command would look like this: IP domain name, and the domain is example.com. After configuring the domain name, the engineer can proceed to generate the RSA key using the crypto key generate RSA command. Question number 5, refer to the exhibit. This is the exhibit. Which two commands must be added to update the configuration of router R1 so that it accepts only encrypted connections? So again, we are talking about SSH connection, and the question is that which command must be added to this already configuration so that the router R1 only accept SSH encrypted connections. And the options are option A, username, CNAC secret, and the password. Option B, IP SSH version 2. Option C, line VTY04. Option D, crypto key generate RSA 1024. And option E, transport input SSH. So remember, we have to choose two options, And the two correct options are, the first one is option D, crypto key generate RSA 1024. We need to generate the RSA keys. And the second one is that we need to tell the router to accept input request as SSH. So the explanation is, for both the options, crypto key generate RSA 1024, this command generates the RSA key pair required for enabling SSH on the router. Without this command, SSH cannot function, or without the RSA key pair, SSH cannot function. And the second one is transport input SSH. This command limits the VTY lines to only accept SSH connections, ensuring that only encrypted sessions are allowed. Question number 6. What is the function of the controller in a software-defined network? And the options are option A, multicast replication at the hardware level. Option B, fragmenting and reassembling packets. Option C, making routing decisions. And option D, forwarding packets. So the purpose or the function of the controller in SDN is making the routing decisions. So in SDN, the controller is centralized entity that manages the entire network by making high-level decisions such as routing. It separates the control plane from the data plane, where the controller decides how to route traffic, and the switches or routers in the network simply forward packets based on those decisions. So this is what we are talking about. So this is the control plane controlled by the SDN controller, and all the routing decisions are basically made over here by this controller, and these routing decisions are then pushed to the data plane switches or routers. So this is the concept of SDN and the function of the controller in SDN, that the routing decisions are made here, and then these decisions are basically pushed or sent to the data plane, where the actual data forwarding router and switches are available, and where the forwarding between the source and this destination takes place based on the routing information sent from the controller. Question number 7, refer to exhibit. And again, this is the exhibit. An engineer built a new L2 LACP ether channel between switch 1 and switch 2 and executes these show command to verify the work. Which additional task allows the two switches to establish an LACP port channel? So we have two switches, switch 2 and switch 1, and they have two physical links, and we are trying to establish an LACP port channel, and these are already the commands that are entered on both the interfaces of both the switches. So what additional command should be entered so that the LAC port channel configuration is complete? And the options are option A, change the channel group mode on switch 2 to auto. Option B, change the channel group mode on switch 1 to desirable. Option C, configure the interface port 1 command on both sides. And option D, change the channel group mode on switch 1 to active or passive. And the correct option is option D, change the channel group mode on switch 1 to active or passive. So as we can see on switch 2, here we can see on both the interfaces the channel group mode 1 is already active, while this command is not available on both the interfaces of switch 1. So entering this command will do the trick, and it will enable both the switches to establish the LACP port channel. So the only remaining task to allow the two switches to establish an LACP port channel is to change the channel group mode on switch 1 to either active or passive. This will allow switch 1 to take the initiative in LACP negotiation and establish the port channel. Question number 8. What is the requirement for a non-overlapping Wi-Fi channels? And the options are option A, different security settings. Option B, discontinuous frequency changes. Option C, different transmission speeds. And option D, unique SSIDs. And the correct option is discontinuous frequency changes. So the explanation is that non-overlapping Wi-Fi channels require discontinuous frequency ranges to avoid interference. This means that the frequencies used by the channel should not overlap with each other. For example, in the 2.4 GHz bands, channel 1, 6, and 11 are the only non-overlapping channels. Question number 9. A network engineer is installing an IPv6 only capable device. The client has requested that the device IP address be reachable only from the internal network. Which type of IP address must the engineer assign? And the options are option A, unique local address, option B, link local address, option C, aggregatable global address, and option D, IPv4 compatible IPv6 address. And the correct option is option B, link local address. And the explanation is that a unique local address in IPv6 is used for local communication within a private network and is not routable on the global internet, similar to private IPv4 addresses such as 192.168. This makes it ideal for devices that should be reachable only within an internal network. Link local address are used for communication within a single link and cannot be routed beyond that link. So here this is wrongly marked as the correct answer. The correct answer is basically option A. So the link local address is the address that can be used for communication within a local network, while the unique local address, while the link local address, basically they are used for communication within a single link and cannot be routed beyond that link. The aggregatable global address are routable on the internet, and IPv4 compatible IPv6 addresses are deprecated and used in dual stack environment. Question number 10, refer to exhibit. So this is the exhibit. Side A was recently connected to side B or a new single mode fiber path. Users at site A report intermittent connectivity issues with applications hosted at site B. What is the reason for the problem? So we have these two sites, site A and site B. They are connected between each. They are connected using a single mode fiber, and the distance is about 7 kilometers. But there are some connectivity issues between these two sites. So what is the reason? And this is the exhibit. We will take a look at this in a while. Let me first go through the option. Option A, heavy usage is causing high latency. Option B, an incorrect type of transceiver has been inserted into a device on the link. Option C, physical network errors are being transmitted between the two sites. And option D, the wrong cable type was used to make the connection. And the correct option is that an incorrect type of transceiver has been inserted into a device on the link. So if we have the configuration of both the interfaces that are connecting these two locations. For site A, it is this interface 10 gigabit Ethernet 010, and using this interface configuration, here we can identify the issue. So basically the SFP SR stands for short reach or short range, and this type of SFP or transceiver is basically used for short distances and multimode fiber. While on the side B, we have the correct transceiver type, that is SFP-LR, that is long reach or long range, you can call it. This is the correct SFP, while this one is basically used for multi-mode fiber, and it can be used for distances up to 300 meters. And since the distance here is 7 kilometers, that's why we have the connectivity issues. So let me bring the explanation. So the SR in SFP-SR stands for a short reach transceiver, and this is used for short range applications of up to 300 meters distances with multimode fibers. The SFP-LR can achieve up to 10 km and is used with single mode fiber. So the SFP-LR, this is the correct. If we had how to correct this issue, we need to use the SFP-LR here as well. If we change this SFP-SR to SFP-LR, then the issue will be resolved. Question number 11. An engineer must configure router R1 for a new user account. The account must meet these requirements. And the requirements are: it must be configured in the local database. The username is engineer2. It must use the strongest password configurable. Which command must the engineer configure on the router? And the options are: option A, username engineer2 algorithm type script secret test 2021. Option B, username engineer2 secret 5 password and this password. Option C, username engineer2 privilege 1 password 7 test 2021. And option D, username engineer2 secret 4 and the followed by the password. And the correct option is option A, username engineer2 algorithm type script secret test 2021. And this is the explanation. So the algorithm type script is the strongest password hashing algorithm available on Cisco devices, offering more security compared to MD5, that is type 5, or SHA-256 type 4. Using this command ensures the password is securely hashed using the script algorithm, fulfilling the requirement for the strongest password configuration. Question number 12, refer to exhibit. Again, we have this exhibit. Router R1 resides in OSPF area 0. After updating the R1 configuration to influence the paths that it will use to direct traffic, an engineer verified that each of the 4 gigabit interfaces has the same route to 10.10.0.0/16. Which interface will R1 choose to send traffic to reach the route? So we have this configuration of router R1. So we have these interfaces. Each interface has the bandwidth given. So each interface has different bandwidth. And the question says that each interface has the same route, that is 10.10.0.0/16. So which interface will then be used? All the 4 interfaces are listed 00, 01, 02 and 03. So which one will be used? So the decision will be made based on the cost that will depend on their respective bandwidth. So the correct option here is option B, that is gigabit Ethernet 0, 1. And why this is selected? It is because R1 will choose gigabit Ethernet 01 to send traffic to reach the route 10.10.0.0/16 because it has the lowest cost and the highest bandwidth. So how the cost is calculated? So the gigabit Ethernet 00 has this MB divided by, it has this 10,000 MB of bandwidth, and the cost is equal to 10, while on G01 when it is calculated it is equal to 1. So the lowest cost interface, that is G01, is selected. Question number 13. What provides centralized control of authentication and roaming in an enterprise network? And the options are: option A, a lightweight access point; option B, a firewall; option C, a wireless LAN controller; and option D, a LAN switch. And the correct option is option C, a wireless LAN controller. So a wireless LAN controller, that is WLC, manages access points in an enterprise network, providing centralized control over authentication, security policies, and roaming. It enables seamless transition for wireless clients moving between access points, ensuring consistent network access and security across the wireless network. Question number 14. Refer to the exhibit. This is the exhibit. Traffic source from the loopback interface is trying to connect via SSH to the host 10.0.1.15. What is the next hop to the destination? And the options are: option A, 192.168.0.7, option B, 192.168.0.4, option C, 192.168.0.40, and option D, 192.168.3.5. So we are talking about reaching the 10.0.1.15. So if we look at the routes here, we have this route. It certainly does not contain the destination 1.15. This one also does not contain the 1.15. So this is crossed. This is also crossed. This one basically contains the 1.15. This one also does not contain because its range is up 0 to 15, but 15 is broadcast address. It is not a specific host or usable IP address. So the correct option is here, this next hop, 192.168.0.hop, because this route is the suitable route. So our correct answer is option B, 192.168.0.4. So the destination, that is 10.0.1.15, will be reachable via this hop. Let's move forward to the next question. Question number 15. Refer the exhibit. And this is the exhibit. Which network prefix was learned via the internal EIGRP? And the options are: so we have these multiple routes and they are learned via different routing protocols. So which network was learned via the routing protocol internal EIGRP? And the options are: 172.16.00/16, option B, 192.168.2.0/24, option C, 207.165.200.0/24, and option D, 192.168.1.0/24. And the correct option is option B, 192.168.2.0/24. And where it is? It is over here. this. So there are two reasons to select this when we are looking for internal EIGRP. First is that this D code stands for the internal EIGRP, and the second is that we can also identify the route that from this administrative distance. The administrative distance for internal EIGRP is 90. So these are different codes for the routing protocol types. C is for connected, S is for static, D is for EIGRP internal, O is for OSPF, R is for RIP, and D is also for external EIGRP. I think this EX is also for the external EIGRP, and these are the administrative distances of different type of routes. For OSPF it is 110, for RIP it is 120, for EIGRP external it is 170, for EIGRP internal it is 90, and for static it is 1, and for connected it is 0. So you must keep these things in mind when selected the route. The first and the foremost option is the looking for the longest prefix match. First is longest prefix match. And the second is then administrative distance. And the third one is the metric. So these are the metrics basically. After the administrative distance, this 2, 8, 4, 4, 3, 7, these are the metrics. So the lower the better. In this case, the 0, 1, these are preferred over other routes. Similarly, internal EIGRP will be preferred over all these. And again, when we have two routes having the same administrative distance, then we will go to the next option, that is metric. Lower the metric, the better chance of the route to be selected as the selected route for forwarding the traffic. Question number 16. How should the configuration be updated to allow PC1 and PC2 to access the internet? So we have this PC1 and PC2, and they both have these IP addresses. These are private IP addresses, and we have a net router between them and internet. So this is the configuration that we have available. What else must be added to this configuration so that these PCs can access the internet? And the options are, option A, modify the configured number of the second access list. Option B, add either the IP net inside or outside command under both interfaces. Option C, remove the overload keyword from the IP net inside source command. And option D, change the IP net inside source command to use interface gigabit Ethernet 0.0. And the correct option is option B, add either the IP net inside outside command under both the interfaces. So we are talking about these two interfaces. These are over here. One is this one and the other is this one. So this is the explanation. The correct way to allow PC1 and PC2 to access the internet is to add either the IP net inside or IP net outside command under both interfaces. This will specify the interfaces as belonging to the inside or outside network respectively and enable net to translate the private IP address of PC1 and PC2 to the public address, that is 201.165.202.130. So the public address is this one, which is configured on G01 to access the internet. And when you want to go to the internet, the private IP addresses must be translate it to the public address, and this is done by a net router through this configuration, including this one. Question number 17, refer to the exhibit. This is the exhibit. An engineer is updating the R1 configuration to connect a new server to the management network. This is the new server. The PCs on the management network must be blocked from pinging the default gateway of the new server. Which command must be configured on the R1 to complete the task? So the question is that we are here on R1 and we want to access this new server. A command must be entered on this R1 so that these PCs or network over here are able to access this new server, but only this new server, not the default gateway of the server. It means that we need to enter a command that will configure only the IP address of the new server and not the whole network. So the options are option A, IP route 172.16.2.0, 255.255.255.0, and the next hop is 1.192.168.1.15. So this command is basically configuring the whole network. So I think this is wrong because we want to reach only the single server and we want to block this PC from pinging the gateway of this server which is over here. Then the second command is IP route 172.16.2.2 and subnet mask is 248. So again, I think this is wrong because we want to for a single IP, this is not the correct subnet mask. So again, I think this is wrong. The third option is 172.2.2, 255.255.255.255 and GI00. Yes. So this seems like the correct command because we are configuring a route to reach this server whose IP address is 172.16.2.2 and subnet mask is again 255.255.255.0 and this route will exit through this interface. So this seems like the correct option. This is also wrong because this is also configuring the whole network. So the correct option is option C. I hope this is understandable. Let's move forward to question number 18. Which protocol is used for secure remote CLI? In the options are option A, HTTPS, option B, HTTP, option C, Telnet, and option D, SSH. So we are talking about CLI, that is command line interface. So option A, this is not a CLI, this is basically GUI, HTTPS. HTTP is again GUI as well as it is not secure. HTTPS is secure, but it is not GLI, while HTTP is both neither CLI nor secure. Telnet is CLI, but it is not secure. It sends data in plain text and not encrypted. So the only correct option remains is the SSH, which is both CLI and is secure. The SSH connection is encrypted. Question number 19. What is the purpose of the IP address DHCP command? In the options are option A, to configure an interface as a DHCP server. Option B, to configure an interface as a DHCP helper. Option C, to configure an interface as a DHCP relay. And option D, to configure an interface as a DHCP client. And the correct option is option D, to configure an interface as a DHCP client. So when you apply the IP address DHCP command to an interface on a router or switch, it instructs the device to obtain its IP address and other network configuration information dynamically from a DHCP server. This allows the interface to act as a DHCP client. Other options Option A, to configure an interface as a DHCP server. This would involve using the IP DHCP pool command instead. Option B, to configure an interface as a DHCP helper. This would involve configuring the IP helper address command to forward DHCP request to a DHCP server on a different subnet. And option C, to configure an interface as a DHCP relay. This is also done using the IP helper address command. Question number 20. Which wireless security protocol relies on perfect forward secrecy? And the options are option A, WPA3, option B, WPA, option C, WEP, and option D, WPA2. And the correct option is option A, WPA3. This is the explanation. So WPA3, that is Wi-Fi Protected Access 3, includes enhancements over previous protocols, one of which is the use of perfect forward secrecy. Perfect forward secrecy ensures that session keys are not compromised even if the private key is compromised in the future, meaning each session has unique encryption keys that cannot be derived from others. Question number 21. Refer to exhibit. Packets received by the router from BGP enter via a serial interface at 209.165.201.10. Each route is present within the routing table. Which interface is used to forward traffic with a destination IP address of 10.10.10.24? So this is the exhibit. We have these routing protocol EIGRP and OSPF. We have the same route 10.10.10.0/24, and the destination is available in all the routes. So which route will be selected? And the options are option A, F010, option B, F011, option C, F0/12, and option D, F0/13. These are these interfaces we are talking about. So which interface will be used to forward the traffic? So if you see here, in this case we have the same protocol. It has the same administrative distance. So for route selection, the first one is the, as I already said, the longest prefix match, but here we can see that the prefix length is same. So we will go to the next op is the, which is the administrative distance. So administrative distance of 1990 is less than 110.110. So these are basically struck out because 110.110 is greater than 90. Less administrative distance is preferred. So we are left with these three. So the third, we have again, since we have the same administrative distance for these three routes, we will go to the next option, that is metric. This is the metric, this is the matrix. So since we are not talking about this, these are already struck out, although the metric 20 is the least of all. So we will look in these three routes. So here we can see that 144 is the smallest metric, and in this way the interface F011 will be used to forward the traffic. So the correct option is option B, F0/11. Question number 22. What is a zero-day exploit? And the options are option A, it is when a network vulnerability is discovered before a fix is available. Option B, it is when the perpetrator inserts itself in a conversation between two parties and captures or alters data. Option C, it is when the network is saturated with malicious traffic that overloads resources and bandwidth. And option D, it is when an attacker inserts malicious code into a sole server. And the correct option is that the zero-day exploit is basically when a network vulnerability is discovered before a fix is available. Fix means a patch or a security update. So the explanation is that a zero-day exploit takes advantage of a newly discovered vulnerability in software or hardware that has not yet been patched or fixed by the vendor. This means that the exploit can be used to attack systems before the vendor has a chance to address the vulnerability. Question number 23. Which quality of service queuing method discards or marks packets that exceed the desired bit rate of traffic flow? And the options are option A, shaping, option B, policing, option C, CBWFQ, and option D, LLQ. And the correct option is option B, policing. So what is policing? Policing is a quality of service mechanism that enforces a bandwidth limit on traffic flows. When the traffic exceeds the configured rate, policing can either drop excess packets or mark them using a method like DSCP marking to indicate they should be treated differently. This helps manage bandwidth and maintain performance for critical applications. Question number 24. What is the role of disaggregation in controller-based networking? So the controller-based networking are basically the SDN, software-defined networking, where a controller is used, and the options are option A, it divides the control plane and data plane functions. Option B, it summarizes the routes between the core and distribution layer of the network topology. Option C, it enables a network topology to quickly adjust from a ring network to a star network. And option D, it streamlines traffic handling by assigning individual devices to perform either layer 2 or layer 3 functions. And the correct option is that the role of disaggregation in controller-based networking is that the control plane, it divides the control plane and data plane functions. It is in traditional network, both the control plane and data plane are aggregated in a single device, while in controller-based or SDN based, these both are disaggregated. They are separated. That is what this question means. So in controller-based networking, disaggregation refers to the separation of the control plane, which make decisions about how to forward traffic, from the data plane, which actually forwards the traffic. This allows for centralized management of network policies and configuration, while the physical devices, switches, and routers focus solely on handling data traffic efficiently. Disaggregation provides flexibility and scalability in managing modern networks. So this is how it looks like. So this is the controller. It is where the control plane lies, and it is completely separated from the data plane. So the routing decisions are made over here, and they are then pushed to the data plane where the switches or router lies, which forward the traffic from the source to the destination. Question number 25. Refer to exhibit the given Windows PC. So this is the configuration of the Windows PC. When you type the IP config/all on the CLI of Windows CMD, you are presented with this information. So looking at this information, the given Windows PC is requesting the IP address of the host at www.cisco.com. To which IP address is the request sent? We are talking about resolving this host name or this domain name to IP address, which is the this process is known as translating from domain to IP, and this process is basically done through DNS and is done by a DNS server. So the request will be basically sent to the DNS server. So we have the options of option A 192.168.1.226, option B 192.168.1.100, option C 192.168.1.254, and option D 192.168.1.253. And the correct option is this 192.168.1.253, and this is the correct option because if you look over here, this is basically the IP address of the DNS server configured. So basically, to translate this domain name to IP address, the request is sent to the DNS server, which is 192.168.1.253. Question number 26. An engineer has configured the domain name, username, and password on the local router. What is the next step to complete the configuration to a secure shell access RSA key? So we are talking about again the configuration of SSH, and the options are option A, crypto key import RSA PEM, option B, crypto key public keychain RSA, option C, crypto key generate RSA, and option D, crypto key zeroize RSA. And the correct option is option C, crypto key generate RSA. So after configuring the domain name, username, and password, the next step is to generate the RSA key pair, which is essential for enabling SSH access. The command crypto key generate RSA generates the RSA encryption key required for secure communication over SSH. The other options, option A, crypto key import RSA PAM. This is basically used to import RSA keys from a file, not to generate them. Option B, crypto key public keychain RSA. This is used to configure a public keychain, not generate the RSA keys. And option D, crypto key zeroize RSA. This command is used to delete zeroize the RSA keys, which is not applicable here. Question number 27, which REST, that is we are talking about REST API method, updates an object in the Cisco DNA Center Intent API? And the options are option A, change, option B, update, option C, post, and option D, put. And the correct option is option D, put. So in RESTful APIs, the put method is commonly used to update an existing object or resource with new data. The put method replaces the current resource representation with the data provided in the request. This is the appropriate method for updating objects in APIs like the Cisco DNA Center Intent API. Question number 28. An administrator must use the password complexity not manufacturer name command to prevent user from adding Cisco as a password. Which command must be issued before this command? And the options are option A, password complexity enable, and B, config 0x2142, option C, login authentication my authentication list, and option D, service password encryption. And the correct option is option A, password complexity enable. So to enforce password complexity rules, the administrator must first enable password complexity checks with the password complexity enable command. After that, additional complexity requirements like prohibiting the use of the manufacturer name, that is Cisco, can be applied. Question number 29. What is a function of Cisco Advanced Malware Protection for Next Generation IPS? And the options are option A, authorizing potentially compromised wireless traffic. Option B, inspecting specific files and file types for malware. Option C, authenticating end users. And option D, URL filtering. And the correct option is option B, inspecting specific files and file types for malware. So Cisco Advanced Malware Protection provides advanced threat detection and prevention capabilities, including inspecting and analyzing specific files and file types to detect malware. It continuously monitors for threats, provides detailed analysis, and can block malware before it causes harm. Question number 30. Refer to the exhibit. This is the exhibit Router R1 must be configured to reach the destination 10.0.3.0/24 network from the 10.0.1.0/24 segment. Which command must be used to configure the route? So this is the source. We want to reach from this source to the destination 10.0.3.0/24, which is over there. This is the destination. So which command must be used? And these are the option. Option A, IP route 10.0.3.0 with the subnet mask 255.255.255 and next hop 10.0.4.2. Option B, route add 10.0.3.0 mask 255.255.0 10.0.4.3. Option C, IP route 10.0.3.0.255.255.255.0 and 10.0.4.3. And option D, route at 10.0.3.0.255.255.255.10.0.4.2. So if we write the route ourselves, the route command is basically IP route, and then you write the destination network. In this case, it is 10.0.3.0. This is the network, and then you write the subnet mask. So the subnet mask for /24 is 255.255.255.0, and the last option is next hop. So what is the next hop? We want to reach here to this router R3. So the next hop will be basically this interface .3, and the network is 10.0.4.3. So the next hop will be basically 10.0.4, sorry, 10.0.4.3. So and this command is basically this one. So the correct option is option C. Question number 1, refer to exhibit. Load balance traffic is coming in from the WAN destined to a host at 172.16.1.190. Which next hop is used by the router to forward the request? So we have this exhibit, and inside this exhibit basically we have a routing table of R1, and we are interested in these routes, and we have to determine that which route will be basically used to reach this destination host or this destination IP address. And we are being asked about the next hop. These are the next hops that will be used by the router. So in effect we are being asked about the route and the next hop. So the options are option A 192.168.7.4, option B 192.168.7.7, option C 192.168.7.35, and option D 192.168.7.40. So let me first highlight the correct option and then I will explain it. So the correct next hop to reach this destination is 192.168.7.35, and it is basically this one. And this is because if we look at our destination, it is 1.190, and this particular route has the range that contains this IP address, as well as this is also the route having the longest prefix. So we do not need to look further, and the correct answer is this one. So if we analyze the route, we can see that this is basically the route. This is the subnet mask. The 184 is the first IP address of this particular route, which is the network address, and then the usable IP range is from 185 up to 190, which is our desired destination, which is also the last usable IP, and the broadcast IP address is the last one, 191. I hope this is clear. Let's move forward to the next question. Question number 2, what is the function of off-the-shelf switches in a controller-based network? So we are asked about off-the-shelf switches in a controller-based network. The controller-based network is basically the software-defined network, or SDN. So what do we mean when we say the off-the-shelf switches? And the options are: option A, providing a central view of the deployed network. Option B, forwarding packets. Option C, making routing decisions. And option D, setting packet handling policies. And the correct option is that the off-the-shelf switches in a controller-based network have the function of setting packet handling policies. And this is the definition. So I think this answer is wrong. Basically, the off-the-shelf switches are used to forward the packets. If we analyze the SDN network, in SDN we have a controller. Let me draw it. And then we have in the data plane, this is basically the control plane. In the data plane, we have the so-called off-the-shelf switches. So the routing decision or policies are taken over here in the control plane by the controller, and then these are pushed to the data plane where we have these switches, and the function of these switches is to forward the packets from the source to the destination. So the correct answer here would be forwarding the packets. And the explanation is that the off-the-shelf switches are a type of network device that is designed to forward packets between different nodes in a network. They are typically used in controller-based network where a central controller is responsible for making routing decisions and setting packet handling policies. So the routing decisions as well as the packet handling, setting packet handling policies, they are decided at the control plane by the controller. The off-the-shelf switches simply follow the instructions provided by the controller and forward the packets accordingly. I hope this is clear. Let's move forward to the next question. Question number 3. Which command entered on a switch configured with rapid PVST plus listens and learns for a specific time period? And the options are: option A, spanning tree VLAN 1 priority 4096. Option B, spanning tree VLAN 1 hello time 10. Option C, spanning tree VLAN 1 maximum age 6. And option D, spanning tree VLAN 1 forward time 20. And the correct option is option D, spanning tree VLAN 1 forward time 20. So this is the explanation of this command. So the forward time parameter specified the time that a switch will spend in the listening and learning states before transitioning to the forwarding state in the spanning tree protocol. In rapid PVST plus, adjusting the forward time controls how long the switch listens and learns before forwarding traffic for VLAN 1. The default value is 15 seconds, but you can modify it using this forward time command. Question number 4. Which WAN topology has the highest degree of reliability? We are talking about WAN topologies. These are also the LAN topology, but here we are talking about the WAN topology, and the options are: option A, full mesh, option B, point-to-point, option C, hub and spoke, and option D, router on a stick. And the correct option is that the full mesh topology has the highest degree of reliability and availability. And this is the explanation. A full mesh topology is where every network node is connected directly to every other node. This provides the highest degree of redundancy and reliability because if any single link or node fails, there are always multiple alternative paths for data to reach its destination. And this is a typical diagram of a full mesh topology. So we can see that every node is connected to every other node, and there are multiple links between, let's suppose, node A and node B. If this node A can reach node B through this link, so if this link fails, node A can still reach through this one and this one. If this one fails, it can still reach through this one, this one, this one. I hope you got the point. So there are multiple redundant links between nodes, and so this topology has the highest level of redundancy, but it is also again difficult and costly to maintain when the network grows. So this is not very practical, and practically this topology is not used when the network grows. Question number 5. What is a function performed by a web server? This is a straightforward and simple question. So the options are: provide an application that is transmitted over HTTP. Option B, send and retrieve email from client devices. Option C, authenticate and authorize a user's identity. And option D, securely store files for FTP access. So the correct option is that web server provide an application that is transmitted over HTTP, hypertext transfer protocol. A web server's primary function is to deliver content such as web pages, applications, or data to client over the HTTP or HTTPS protocol. So the secure version of HTTP is HTTPS. This allows users to access websites and web-based applications through their browsers. Other options like sending and retrieving email, that is option B, authentication, and FTP storage are handled by other type of servers or specific services. Question number 6. What is the collapsed layer in collapsed core architecture? So what does collapsed layer consist of in collapsed core architecture? And the options are: option A, core and WAN, option B, access and WAN, option C, distribution and access, and option D, core and distribution. And the correct option is option D. So the collapsed layer consists of core and the distribution layer. So in a collapsed core architecture, the core and distribution layer are combined into a single layer known as the collapsed core layer. This simplifies the network design, reduces costs, and is often used in smaller networks where separation of core and distribution is unnecessary. The access layer remains separate and connects directly to the collapsed core. And this is what we are talking about. So this is the three-tier architecture that consists of access, distribution, and core. And when these two layers, the core and distribution, are combined into a single layer that is known as collapsed core, then we get this architecture that is known as collapsed core architecture. Question number 7. An engineer is installing a new wireless printer with a static IP address on the Wi-Fi network. Which feature must be enabled and configured to prevent connection issues with the printer? And the options are: option A, client exclusion, option B, DHCP address assignment, option C, passive client, and option D, static IP tunneling. And the correct option is option C, passive client. So what is passive client? So in a wireless network, a passive client is a device that does not actively participate in the dynamic IP assignment process through DHCP, but instead uses a static IP enabling and configuring the passive client feature ensures that the wireless infrastructure can handle devices like printers with static IP addresses properly, avoiding potential connection issues. The other options, including the client exclusion, DHCP, and static IP tunneling, do not directly address this scenario. Question number 8. Which MAC address is recognized as a VRRP virtual address? And the options are option A 000.5 echo 00.010A, option B 00053709.8968, option C again tetra 00C07 AC99, option D 0007.C070.AB01. And the correct option is option A tetra 0.5 echo 00.010A. And the explanation is that VRRP basically uses MAC addresses in the format tetra 0.5 echo 00.01XX, and where the XX represents the VRRP group number. The address shown here .010A follows this format and indicates a VRRP group number of 10. So 0A in hexadecimal stands for 10 in decimal. The other options represent MAC addresses used by different protocols such as HSRP, that is Hot Standby Router Protocol. Question number 9. Refer to the exhibit. When router R1 is sending traffic to IP address 10.56.192.1, which interface or next hop address does it use to route the packet? So again, we are talking about reaching a destination of this 10.56.192.1, and we have a routing table of R1. So which route and which next hop will be used? And the options are option A 10.56.0.1, option B 000/0, option C VLAN 57, and option D 10.56.128.19. And the correct, let me first bring the correct option and then we will explain the answer. So the correct option is 10.56.0.1, this one, this next hop, which corresponds to this default static route. So why is that? It is because the 10.56.192.1 is not available in all these routes. These routes does not contain this destination address. Therefore, the router will resort to the default route. As you can see, I have analyzed the routes. So this is this one, this route. If you analyze this route, we have the range of 10.56.0.1 up to 127.254. So this does not contain the 192.1. Another route is this one. Let's analyze this one as well. So again, this route range is 10.56.128.1 up to 10.56.191.254. So this route also does not contain our desired destination of 10.56.192.1. And this is also /32. This one is also /32. So this one is also, it is so this is not a route basically. So our desired and our correct option is this default route, because other routes does not contain the specified destination address. I hope this is clear. Let's move to the next question. Question number 10. What is a benefit for external users who consume public cloud resources. And the options are option A, implemented over a dedicated WAN. Option B, located in the same data center as the users. Option C, all hosted on physical servers. And option D, accessed over the internet. So the benefit of public cloud for external user is that it can be accessed by all the external user over the internet regardless of their location and their geographical location, or they may be anywhere inside their homes or inside the office, and they can consume the public cloud. So this option highlights that external users can easily access public cloud resources via the internet, allowing for flexibility and convenience in utilizing cloud resources from anywhere. Question number 11. When should an engineer implement a collapsed core architecture? And the options are option A, for small network with minimal need for growth. Option B, the access and distribution layers must be on the same device. Option C, for large networks that are connected to multiple remote sites. And option D, only when using VSS technology. And the correct option is that the collapsed core architecture should be used for small network with minimal need for growth. So a collapsed core architecture is typically implemented in smaller networks where the access and distribution layers are combined into a single layer, making it simpler and more cost-effective for environments that do not require extensive scalability. Question number 12. What is the purpose of the Cisco DNA Center controller? And the options are option A, to secure physical access to a data center. Option B, to scan a network and generate a layer 2 network diagram. Option C, to securely manage and deploy network devices. And option D, to provide layer 3 services to autonomous access points. And the correct option is that the Cisco DNA Center controller is basically used to securely manage and deploy network devices. The Cisco DNA Center serves as a centralized network management platform that enables secure management, automation, and deployment of network devices across an organization's infrastructure. Question number 13. Which encryption method is used by WPA3? And the options are option A, PSK, option B, TKIP, option C, SAE, and option D, AES. And the correct option is AES, that is an advanced encryption standard. So that is the encryption algorithm or encryption method used in WPA3. Question number 14. What differentiates device management enabled by Cisco DNA Center from traditional campus device management? The options are option A, per device, option B, centralized, option C, device by device hands-on, and option D, CLI or oriented device. And the correct option is that the Cisco DNA Center management is basically centralized. So Cisco DNA Center enables centralized device management, allowing for more efficient and streamlined management of multiple network devices from a single platform, as opposed to the traditional campus device management, which is often more decentralized and manual. Question number 15. Which command implies the use of SNMP version 3? And the options are option A, SNMP server host, option B, SNMP server community, option C, SNMP server enabled traps, and option D, SNMP server user. And the correct option is option D, SNMP server user. So the command SNMP server user is associated with SNMP version 3 as it is used to configure users with specific security parameters, which is a key feature of SNMP version 3 enhanced security model. Question number 16, refer to the exhibit. This is the exhibit. What is represented by R1 and SW1 or router 1 and switch 1 within the JSON output? So we are talking about these. So what are represented by these? And the options are option A, object, option B, value, option C, key, and option D, array. And the correct option is that the R1 and SW1 are basically the values. And this is the explanation. In the given JSON output, the routers and the switches are keys and the values associated with them are arrays. Within these arrays, R1, R2, R3 and switch 1, switch 2, switch 3 are values. Here is the breakdown of all the terminologies. So a key is a name that identifies a value within a JSON object. A value is the data associated with a key. It can be of various types, including strings, numbers, arrays, or objects. And an array is an ordered collection of values. Therefore, R1 and SW1 are values within the arrays associated with the keys, routers, and switches, respectively. Question number 17. What are two examples of multi-factor authentication? Choose two options. And the options are option A, single sign-on, option B, unique user knowledge, option C, password that expire, option D, soft tokens, and option E, shared password responsibility. And the correct options are that the multi-factor authentication example is, first example is the unique user knowledge and the second is soft tokens. Multi-factor authentication, that is MFA, requires two or more different factors to verify a user's identity, typically combining something the user knows like a password or PIN with something the user has like a soft token or hard token. Question number 18. How does encryption protect the wireless network? And the options are option A, via the integrity checks to identify wireless forgery attacks in the frame. Option B, via an algorithm to change wireless data so that only access point and client understand it. Option C, via specific ciphers to detect and prevent zero-day network attacks. And option D, via a policy to prevent unauthorized users from communicating on the wireless network. And the correct option is option B, that is via an algorithm to change wireless data so that only the access point and client understand it. So encryption protects a wireless network by transforming the data being transmitted into a format that can only be understood by the authorized party, which are the access point and the client. This ensures that even if the data is intercepted, it cannot be read without the appropriate decryption key. Question number 19. Why implement VRRP? What is the purpose of implementing VRRP? And the options are option A, to hand over to end users the auto discovery of virtual gateways. Option B, to provide end users with a virtual gateway in a multi-vendor network. Option C, to leverage a weighing scheme to provide uninterrupted service. And option D, to detect link failures without the overhead of bidirectional forwarding detection. And the correct option is that VRRP is basically used to provide end users with a virtual gateway in a multi-vendor network. So VRRP, that is Virtual Router Redundancy Protocol, is implemented to create a virtual router or gateway that allows end user to access a single IP address regardless of the underlying physical routers. This provides redundancy and failovers capabilities, enabling seamless network connectivity in a multi-vendor environment. So this is how the VRRP looks like. So this is the virtual gateway we are talking about. So the VRRP is formed between two routers. These routers have their physical IPs as well, but to the clients, the virtual IP is used by the client. So at a time, one router is active and the other is standby. So the active router actively processes the traffic, and if the link fails or the router fails, then the traffic is diverted to the second router, which then becomes active. So that's the purpose of virtual gateway and VRRP. It provides redundancy and high availability. Question number 20. In a cloud computing environment, what is the rapid elasticity? And the options are option A, control and monitoring of resource consumption by the tenant. Option B, automatic adjustment of capacity based on need. Option C, pooling resources in a multi-tenant model based on need. And option D, self-service of computing resources by the tenant. And the correct option is that the rapid elasticity in cloud means automatic adjustment of capacity based on the user need. So rapid elasticity in cloud computing refers to the ability to automatically scale resources up or down as required by the demand. This allows for flexible resource allocation and ensures that users have the capacity they need without over provisioning or underutilizing resources. Let's move forward to question number 21. What is a reason to implement IP version 4 private IP addressing? We are talking about RFC 191net address scheme that contains n/8 192.168/16 and 172.16/12. So why are these used? There are multiple reasons. One reason is given here, appropriate reason. So we have to select that one. And the options are to reduce the risk of a network security breach. Option B. So the correct answer already highlighted accidentally. So one benefit of private IP addresses is that it reduces the risk of network security breach. How? This is explanation. Implementing the IP version 4 private addressing helps reduce the risk of a network security breach by isolating internal network traffic from the public internet. Private IP addresses are not routable on the internet, making it more difficult for external attackers to directly access devices within the private network. Question number 22. What is the purpose of configuring different level of syslog for different devices on the network? And the options are option A, to rate limit messages for different severity. This is severity levels from each device. Option B, to set the severity of syslog messages from each device. Option C, to identify the source from which each syslog message originated. And option D, to control the number of syslog messages from different devices that are stored locally. And the correct option is option B, to set the severity of syslog messages from each device. So configuring different level of syslog for various devices allows network administrators to categorize and prioritize syslog messages based on severity. This helps in managing the volume of logs generated and ensures that critical messages receive appropriate attention, while less critical messages can be logged at lower levels. Question number 23. What is a function of MAC address learning? Options are option A, it is enabled by default on all VLANs and interfaces. Option B, it increases the potential for MAC address flooding. Option C, it is disabled by default on all interfaces connected to trunks. And option D, it increases security on the management VLAN. So the correct option is option A. The MAC address is learned because it is enabled by default on all VLANs and interfaces. And the explanation is that MAC address learning is a function performed by network switches to dynamically learn and store the MAC addresses of devices connected to their ports. This feature is typically enabled by default on all VLANs and interfaces to facilitate official frame forwarding on the MAC address table, improving network performance. Question number 24. What is a fact related to FTP, that is File Transfer Protocol? And the options are option A, it uses block numbers to identify and mitigate data transfer errors. Option B, it always operates without user authentication. Option C, it relies on the well-known UDP port 69. And option D, it uses two separate connections for control and data traffic. And the correct fact about the FTP is option D, that it uses two separate connections for control and data traffic. And the explanation is that in control-based networking, sorry, this is not the correct explanation of this particular question, but let me show this diagram. So this is what we are talking about, the connections between FTP client and FTP server is basically based on two parts. One is data connection. This one is the data connection that uses port 20 on the server, and the second one is the control connection that uses port 21 on the server. So this is the fact about FTP, that two separate connections for control and data traffic is used. So the control means that control commands are sent between server and the clients, while the data connection means that when client download data, the actual data is downloaded from the server to the client. Question number 25, refer to the exhibit. So this is the exhibit. We have a router and its its routing table is shown. And the question is that a packet sourced from the IP address 172.168.33.2 is destined for the destination 172.168.32.38. Where does the router forward the packet? And we have this next hop addresses. So we have a destination, this 32.38. So how will this destination be reached using this routing table? Which specific route and its concerned next hop will be used? So the next hop options are option A 10.1.1.1, option B 10.1.1.3, option C loopback 0, and option D gigabit Ethernet 0/0. So let me first underline the correct option and then I will explain the answer. So the correct option is gigabit Ethernet 0/0. This is the gigabit Ethernet 0/0. So the our destination IP address is 172.168.32.38. This is 37.32. So obviously this is not this one is the correct answer, and it is because if you look at the other option, this one is also not, because it's 32/32. These routes also contain the required IP address, but always remember that we have to choose the longest prefix first. So this is /30 is the longest prefix. That's why this is the correct answer, and the correct option is that the destination will be reached through this route whose allied interface is gigabit Ethernet 0/0. And this is the analysis and breakdown of this route. So this is the network IP address, the first 36, and the usable two IP addresses are 37 and 38. So our destination is basically 38 and 39 is the broadcast address. 252 is basically the subnet mask for /29 or /30, sorry. I hope this is clear. Let's move to the next question. Question number 26. Which command configures the Cisco wireless LAN controller to prevent a serial session with the WLC or wireless LAN controller CLI from being automatically logged out? We are talking about serial session, remember? And the options are option A, config session max session 0. Option B, config serial timeout 9600. Option C, config serial timeout 0. And option D, config session timeout 0. And the correct option is option C, config serial timeout 0. So this command will make sure that the session is not automatically logged out. So the serial word is used for serial connection, while the sessions is used for other type of connection such as, let's suppose, telnet. Here we are talking about serial, so this option C is the correct option. Question number 27, refer to the exhibit. This is the exhibit. How many JSON objects are represented? And the options are option A 1, option B 2, option C 3, and option D 4. And the correct option is option A. So this whole thing is a one single object. The whole objects or the whole values between these curly brackets is a single object, and this is the explanation. In the given JSON output, there is only one JSON object. The entire structure within the curly braces represent a single object. This object contains multiple key value pairs where the keys are switch 1, switch 2, switch 3, and switch 4, and the values are arrays of strings representing interface names. So these are values and these are basically keys, and this whole thing is one object. Question number 28. Which enhancement is implemented in WPA3? This is the latest Wi-Fi security standard. And the options are option A, applies 802.1x authentication. Option B, uses TKIP. Option C, employs PKI to identify access points. And option D, protects against brute force attacks. And the correct option is option D, that it protects against brute force attacks. So WPA3 enhances security by implementing stronger encryption methods and protection against brute force attacks, including a feature called simultaneous authentication of equals SAE, which provides a more secure key exchange process. This makes it much more difficult for attackers to guess passwords even if they have access to the encrypted traffic. Question number 29. Which type of port is used to connect the wired network when an autonomous access point maps two VLANs to its wireless LANs? The options are option A, access, option B, lag, link aggregation group, option C, trunk, and option D, ether channel. And the correct option is option C, trunk. So when an autonomous access point maps two or more VLANs to its wireless LANs, it uses a trunk port to connect to the wired network. A trunk port allows multiple VLANs to pass through a single physical link, enabling the AP to communicate with devices on different VLANs. Question number 30. Refer to the exhibit. A network engineer must configure router R1 with a host route to the server. Which command must the engineer configure? So the question is, we have this router R1 and we have this host or server having this IP 10.10.10.10. So a route must be configured at this router R1 so that we can reach to this desired host or server. So what will be the route? And the options are option A, IP route 10.10.10.10 and 255.255.255.255 and next hop is 192.168.0.2. Option B, IP route 10.10.10.0 and subnet mask 255.255.255.0 and next hop is 192.168.0.2. Option C, IP route 0000 and subnet mask 0000 and next hop is 192.168.0.2. And the last option is that IP route 192.168.0.2, 255.255.255 and next hop is 10.10.10.10. So this is obviously wrong because we have, this is the destination, it should be here, and this is the next hop, it should be here. This was, we can configure this route and the host will be accessible using this route, but this is default route. We need to configure the host route only. And this route basically configures a whole /24 network. Again, it is this route will include all the hosts in this 10.0 network, ranges from 1 to up to 254. So again, this is also not desirable. This one is the correct option because it configures the route for the this .10 host only with a subnet mask of /32, and the next hop is here. This is the next hop, the next router interface IP address to which it is connected. So the option A is the correct option. So that's all for this video. I hope this video has been informative, and please subscribe and stay tuned for the upcoming video. And if you have any question, please comment. I will reply to each and every comment. Thank you and see you soon.